Today is Friday in California. Shoot! Bow, 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 bow. What's up? How's everybody doing? Are you ready to talk about space today? Welcome to the EJ Space and Rocket Review. You two chatters, tell your friends. You two girls. The Space and Rocket Review. One night only this week. Sounds like a Rush song. That was StarCraft. The tunage, the tunage that you heard right there, StarCraft 2. It's good tunes. Here, ready? You want a piece of me, boy? Jacked up, good to go. Rock and roll. Battle cruiser operational. Hailing frequencies open. Good day, Commander. Ready to roll out. Yeah? Identify target. Proceeding.
Go and throttle up.
Go and throttle up. Civilly, 50-month resub. Hey, before we get started real quick, I just want to thank everybody for yesterday. There was a little bit of some people gifted some subs yesterday, and yeah, I want to say thank you all for the support. I do appreciate it. You know, I don't want to sit here and make sure like, oh, this is all about money, but dude, that certainly takes some weight off. You know, chat was pretty clear about what they want to see from this stream yesterday, so yeah, there you go. Appreciate it, guys. Thank you very much. Now back to figuring out how to implement spell shots in my code. Print, quote, hello world, quote, semicolon. Bad syntax. Yeah, bad syntax. You probably should, Rockets, I'm probably not the guy to ask for that. They didn't have gift enough money to make you do the... That's my smug face. It's time for me smug face. Yeah, it was, that was pretty cool. I appreciate it. Appreciate it. Anyway, all right. Let's see what's going around the horn. What do you guys want to talk about for space news? I have some things here. Let me take a look. There is some ULA stuff. Actually, that's all old. Where did I put all the links? Huh. I have the scientific report about the feasibility of Starship. That is probably going to be a lengthy discussion here.
Discovery. Go and
Oh gosh. Oh gosh. Oh god. Oh crap. Oh crap. 2 paper notes gifted a sub. Thank you very much. To Turtle Nipples. All right. Okay. Yeah. Yeah, yeah. That is a name. That is a name of all time. Yep. Okay. All right. Yeah, there's yeah, some New Glenn drone ship stuff. Let's see. There's that. Thank you. Thank you, Thomas. Yeah, that Starship feasibility one is something I want to dive into. I got something from Sierra. They posted about how they're gonna do more tests with inflatable modules and stuff. So that's kind of cool. That's kind of neat. The Vast 1 Haven Pathfinder. Yeah, we saw some pictures of this, but there's apparently
What
Vast.
if you could do SEO?
What if I could not listen to ads? I'm really getting sick of this. This is getting very annoying because, you know, yeah, mm. This ad is for Wix, but it's not the Wix that I like. So, yeah. Way to screw up your targeting. I appreciate that. What's with the ad volume changing every new time an ad comes on? Yeah. Lack of broadcasting standards. Oh man, is the name of that game. Hey Jay, this will be a good weekend. I'm getting my new motorcycle this Sunday, an MB Agusta Super Veloci 800. Oh. Oh, yeah. Oh, yeah. That's pretty awesome. Thoughts on neutron delays? Yum Food, I don't have anything on... I don't have anything on that. Neutron delays? Fill me in, dude. Fill me in. I've been on a Fallout and Workers kick. So I'm a little bit out of the loop for this week. And also, doing space news right before a flame trench is actually, I like that because it gets me primed up on all the subjects so we could have better discussions on flame trench. I'm not going to lie to you. So I will say that Starship feasibility thing is going to take a while. I need to read through that article. So it's better to do it on stream so you guys can see the thought process, I think. Neutron delays, though, Yum Food. I'm unfamiliar with this. Also, Trevor, Trevor, what? Why? Why are you doing this? Why would you do this? Why would... Playing any Fallout today? Slick, today is going to be the day about space news, so probably not. I'm going to say probably not. Like, so this is the segment where I talk about what's going on in the spaceflight industry. Fallout will be back next week, though. I'm thinking for next week, probably a 5-day round robin of games. So, Fallout will be one of the games next week, Fallout 4. So, yeah. Neutron was delayed to net mid-2025. Makes sense due to the amount of development required. RJ, I have the Lucy images. Okay, that's cool. Push back to 2025. I feel that it's optimistic with the status of Wallops. Yeah. Okay. I still say you need to have a Calvin and Hobbes book today for the start of Flame Trends, especially if you have the first one with the wagon flying into the lake cover. Oh, JDG, don't kill me. Hey, I'd like to think in terms of pop culture references, I am playing with house money here. I never read Calvin and Hobbes. I know what it is, and I know people like it, but it wasn't, believe it or not, that wasn't my daily thing. Oh, well, not daily. That wasn't my Saturday morning funnies. It wasn't in my Saturday morning funnies. Maybe we got the wrong newspaper or something. I don't know. Hey, don't you shame me. I'm a master of pop culture references, all right? You let me have this one. You jerk. If I don't want to watch, I am Gumby, damn it. If I do not want to watch Calvin and Hobbes, I will not watch it. I will not watch the Calvin and Hobbes. I will not watch the Calvin and Hobbes. I am Gumby, damn it. I am Gumby. I smoked this cigar. Anyway, sweet. I enjoy space news. I learned a lot even though it's a different language. Yeah, you tell them. Yeah. Are you drinking rocket fuel? I think this is half and half. We had a huge cookout over the weekend when Bree's in-laws were here because it was my dad's birthday. So there's all kinds of stuff in the fridge. If you ever have had people over for a cookout and they bring all the drinks, right? You'll know exactly what I'm talking about. So, see, here's the thing: if people bring stuff and not all of it gets drank, you either put it in the downstairs fridge or it goes in the back of your fridge if you only have one fridge and you forget about it. Me, I like to run a tight ship on my fridge. I don't need science experiments happening in there. You know what? Leftovers, if you know, you know. I don't like that, so I'm cleaning out the fridge. So we got an AP today. It's half iced tea and half lemonade. So it's half English. I don't know how I feel about this. I don't know how I feel about that. Who wants some Arnie Palmies? Boo, boo, boo. So read Calvin and Hobbes even as an adult. Yeah, no, I know it's good. I don't hate. I'm not hating by any means. Yeah. APs are, this is actually, yeah, it's pretty tasty. Iced tea and lemonade. Yeah. It, you know, the lemonade is really making up for the fact that it has tea in it. Me, not a tea drinker. You know what I'm saying? Yeah, but you could have a whole ecosystem in your fridge. Yeah. I don't like having science experiments in the fridge. If the leftover, like, I'll usually eat the leftovers, but if something gets stuck in the fridge abyss in the very back of the fridge, I usually forget that it's there, and it sits there. I do not like stuff sitting in my fridge. The fridge, no, no. Rather dump it in the harbor, only kind of halfway. I would kind of like maybe cut it in half and throw half of that into a body of water. All right. Anyway. Let's see. I got a good amount of stuff here. We do have a Falcon 9 launch today. Yeah. It's a little, going all the way to the Flame Trench. Yeah, it should be, it's targeting 7:47 p.m. Good number. So neutron delays. I guess we could start there. That's fine. Is there still an Electron launch? There is the Electron Curie Pre-Fire and Ice launch targeting 11. And then, of course, we have Starliner CFT tomorrow launching at 12:25. I'll be here at 8 to pick up the coverage. Okay, RJ. It's PM, so it's noontime tomorrow. 12:25, noontime. That, for the people that, you know, if you go by my start time, I mean, this makes it really good for people who, you know, time zones and stuff. If you're overseas, that's 25 minutes after my normal start time. So, like, right now. Like, tomorrow at this time, we'll be sitting right here hopefully watching Starliner right up into space. APs are tasty. Yeah, man. I'm just linking whatever you can pick and choose. Yeah, I don't know about that one. European commercial cruise. Scrub liner. Damn. All right. Just saying it's going to grow on you. No, it's tasty, but it has too much sugar in it, dude. Too much sugar. Whoa.
Discovery, go and drop.
Willie! Did you break free of your Red Bull addiction? Yeah, I finished what was in the in the fridge, and I'm done. I don't want to drink that anymore. There's too much sugar in it. Starship Flight 4 on June 5th final. It's a net date, Wally, but it's trending towards the 5th or the 6th. Hey, Airbattack, what's going on? It's like Willie with those 5 subs. Thank you very much. Hopefully you're well. Honkers, I'm doing just fine. Golf is just like rocketry. Yeah, trajectory and stuff. Trajectory. All right, so neutron delays. First and foremost, not
Discovery, go and throttle up.
Didn't see that one coming. Yeah, of course we did. Nothing. It's like this self-defeating prophecy with rockets. So Neutron is Rocket Lab's next generation rocket. So it's the rocket that's supposed to be basically going to here's a let me get you some promo pictures of it real quick. Neutron is kind of here, let me take a look. Let's get the pictures there real quick. No, that's Hayes' video. Hold on. Yeah, here we go. All right, so I'll just keep this video up in the background. So Neutron is Rocket Lab's next generation rocket. It's their rocket that is a partially reusable architecture with a reusable first stage and payload fairing, kind of integrated into one unit, and a expendable load reactive second stage. So, all right, Willie, here comes the part that you might not understand. I will try my best to explain this. So, if you look at these pictures here, and this is Peter Beck. That's Peter Beck. That's the CEO of Rocket Lab. Good dude. He is explaining this all right here. This picture is a good picture to explain it. So, if you look, the first stage, you know, you have your fuel and oxidizer tanks. Obviously, you got your engines down the bottom, landing legs, because reusable first stage, right? And then the tankage is attached to an inner stage, right? And the inner stage has fins on it for, you know, steering that second stage back down to come back, propulsively land, right? Pretty, I'm not going to say it's garden variety stuff at this point, but Falcon 9, yeah, pretty much, that's the idea. Doing pretty much what Falcon 9 is going to do. And then on top, you have your payload fairing. Payload fairing is 2 halves. But here's the thing about the... actually, I think on Neutron, it might be 4 times symmetry, so the payload fairing opens up like this. Like, you know, like that. Woohoo! 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 Just like that. Anyway. So the idea is that the payload fairing opens and can close. The second stage is hanging. It's hanging inside of the interstage, the reusable interstage or reusable payload bay here. The interstages are usually a structural cylinder that basically is on top of a first stage that connects the first stage to the second stage. Usually interstages are hollow on the inside because the upper stage engine is riding inside of it, right? Pretty straightforward stuff. You want the second stage engine, you don't want it open to atmospheric conditions, right? So it's inside of kind of a structural, it's basically a structural cylinder. That's what it is. It's just a cylinder. It's usually made out of aluminum, carbon fiber, something like that. It depends on the design, right? Hey, Cryptech, 55 months. Thank you. Two Paper Notes gifted out another sub to Access Time. That Access Time's name is not as good as Turtle Nipples. I'm not going to lie to you, Two Paper. It's 2 fairings, Thomas. Thank you. So, okay. Now, why hang the second stage? Okay, so hanging the second stage allows you to make your second stage out of less mass. Think about it for a second. If you're pulling that second stage, I'll use my Arizona here. If you're pulling it, right, that means you don't need to push up on the thing. That means it's hanging. So it's hanging from something called a load reactor in rocketry. A load reactor is basically just a structural component that holds the second stage. It's very straightforward stuff. Load reactors are used to save mass on second stage designs. So Atlas 551, give you, Atlas uses a partial load reaction system. So if we look at an Atlas 500 here, okay? The upper stage of an Atlas 5 is made, the upper stage of an Atlas 5 is a Centaur, it's called the Centaur 3, okay? So that's a Centaur 3 upper stage. Centaur 3 is a stainless steel construction, but it's not like Starship. The stainless steel is about as thin as aluminum foil, or aluminum foil, right? Or aluminium foil, right? We'll use all 3 names and one of them is wrong. Actually, 2 of them are wrong. All right, so the stainless steel is about as thin as this, a soda can maybe. Now, how you get, why? How did they do that? Well, Centaur tanks, much like a aluminum can, relies on residual pressurization for structural integrity. That allows you to make the tank walls pretty thin. So when you're unpressurized, right, you can push on it. But if it's pressurized, filled up like a balloon, inflated like a balloon, but inflated with, propellant, it becomes very structurally rigid, right? So on an Atlas V 400, for instance, the Centaur is on it's in your primary load path here. So you have first stage and SRBs pushing through a conic interstage adapter cylinder. On Atlas, it's slightly conical to make up for the difference in tank wall. Centaur has a different diameter than the Atlas CCB. Why? Because they wanted to carry on the same Centaur design from Atlas 3 to Atlas 5. Why is there no Atlas 4? No idea. Because 4 is bad luck or something. Anyway, so you have your interstage adapter, and then you have your short interstage adapter. The interstage adapter is basically transferring the load from the conic interstage up to the Centaur. They're load adapters. But the Centaur is still in the primary load path. The thing about the Atlas V 400 is that Atlas V 400 can only launch with so many SRBs. Actually, most of the Atlas V series I think that there's no more Atlas V 400s anymore. I think it's all 500s from here on out. But no, so you're probably never going to see this one fly. You're a load adapter. No, you reverse Uno card. Boom. So, well, hang on. You got to turn the can the right way, idiot. So, the reason why you can't have many SRBs on this is with a 400 style fairing is because you'll crush the Centaur. You will crush it. Even though it's under pressure, it can still pop like a balloon. There's only certain loads that this thing can take before it basically gets hydraulic pressed between the first stage and the payload fairing, right? Because think about it, right? You have a lot of fuel right here in a pressurized balloon that's relying on structural integrity, right? Then you have a big, gigantic, heavy spaceship up here, or spacecraft, right? And then you have the aerodynamic load pushing down because the fairing is pushing the air out of the way, right? And then on the bottom, well, you have these things down here, solids and the RD-180, which is no slouch when it comes to thrust. It's making 4 meganewtons of thrust by itself. That's ridiculous. That is a ridiculous amount of thrust for one engine. It is so much power that the Russians actually decided 2 nozzles is a better solution to help with cooling and thermals. Yeah, true story. The power pack on an RD-180 makes so much power that they couldn't put it through 1 nozzle. It would melt it. They had to do 2. Yep. Fun fact. So the RD-180, despite having 2 nozzles, is 1 engine. It has 1 power pack feeding 2 nozzles. Now, that packs a lot of punch. You'll crush the Centaur stage if you put too much down here, combined with the aero load and the mass of the spacecraft. The Centaur is in your primary load path. It'll accordion itself. It will pop. Those tank walls are relying on residual pressure, but they are not... they're strong, but they're not that strong. So, go back to Atlas V 500. See the difference? The Atlas V 500 is a partial load reaction system. To overcome this, the engineers at Lockheed, because Lockheed designed Atlas, right? The engineers at Lockheed Martin decided to put the entire second stage inside and payload inside of a gigantic fairing, okay? So you have your solid rocket boosters, same RD-180 engine, same Atlas V CCB, that's called a common core booster, right? You have a cylindric interstage adapter on top of it with that same Centaur adapter, and then you have a conic adapter for the payload fairing. Now, Centaur is still sitting here. I say it's a partial load reaction system because it's still pushing up on it, but the load is dispersed up the payload fairing. Some of the load path, well, actually the primary load path is still through the Centaur stage. But inside of that payload fairing, there's a structural load reactor here called the CFLR. Centaur Forward Load Reactor. That is taking off some of the compression forces induced, via aerodynamic compression and acceleration from the rocket engines. Basically, Payload fairing, moving air out of the way, same thing as before. Payload fairing, moving the air out of the way, big old heavy spacecraft up on top. Some of the spacecraft on Atlas V 500s can exceed 50,000 pounds. That's a lot. That's heavy. That's very heavy, right? 50,000 pounds on top of basically a balloon. Think about it, right? You drop an anvil on a balloon, there will be no balloon left. So the forward load reactor here is to overcome. The forward load reactor there is to take off some of the compression load induced from launch of the Centaur so it doesn't pop like a balloon. Now, this was a solution to a problem because they didn't want, because ULA didn't want to redesign Centaur. That's what Vulcan is for. Vulcan has a 5-meter Centaur. You don't need to worry about that. The 5-meter Centaur is has a little bit of a thicker tank wall on Vulcan. So that's what Vulcan doesn't need a forward load reactor. The Centaur still needs to be held up though, or else it'll just collapse in on itself if it's not pressurized. But it is a little bit stronger. The Centaur that flies on Vulcan is called the Centaur 5. Once again, they went from 3 to 5. I don't know. I guess ULA doesn't like 4. That's fair. Whatever. So this has been done in the past, but now going back over to Neutron, Neutron wants to do that, but to the next level. They want to design a rocket with a second stage that is out of the critical load path that's induced from the engines and from the payload fairing. Right? Rockets like to accordion on the way up. This is why they throttle down for maximum dynamic pressure, and this is why this is such a key milestone. Maximum dynamic pressure, or max Q, when a rocket launches, is basically the peak compression load that's going to get induced on the entire vehicle. Because you have the rocket engines pushing up and aerodynamic forces pushing down on the fairing, the rocket's trying to accordion itself. That's why they throttle down, so it doesn't. You throttle down a little bit, you sacrifice a little bit of efficiency so the rocket doesn't blow up. Yeah. You just go up a little bit higher, the air's not going to be there anymore because you're going to be in space, and that's when you can throttle the engines back up. That's why they call it a throttle bucket. So, because if you're looking on the telemetry, the throttle of the engine goes from 100 down to 60 and then back up again. It looks like a bucket, throttle bucket. Now, if you take your second stage out of the critical loading path here, right? So, the critical loading path is basically where the force from the aerodynamics are going to push down on the vehicle. If you take that second stage out of that path, you can afford to make your second stage a lot thinner. You can afford to make it a lot lighter. And the name of the game with rocket science is to put less rocket on your rocket and have more fuel on your rocket. If you have more fuel on your rocket and less rocket on your rocket, it'll go further. That actually is a plain English way of explaining the ideal rocket equation. Tsiolkovsky's rocket equation. That is the equation that governs how all rockets fly. What that basically means in plain English is, like I said, you have less rocket on your rocket, more fuel on your rocket can accelerate further, or it can accelerate over for a longer period of time. That's the name of the game with second stages. You don't want a lot of second stage on your rocket. You want a lot of acceleration, though. Doesn't necessarily need to be fast acceleration. It just needs to be a lot of it, right? Now, first stages are kind of a little bit of a flip from that. First stage is, I mean, obviously you want less rocket on your rocket, but the first stage really favors thrust. Favors thrust over efficiency of motors. The first stage basically you want to get the second stage up out of the atmosphere as quickly as possible. But obviously you have to fight against aerodynamic loads too, right? So taking your second stage out of your critical load path means that you can put less second stage on your second stage and more fuel on your second stage. So at the top of the second stage right here, and at the top of Neutron's inner stage, right? Now that you kind of know the terminology. If I'm speaking Japanese here, just bear with me. I'll get to the point. It's hanging, and the payload is actually transmitting its load through a load reactor here, and the load gets pushed down on the first stage. You're basically trading mass between first and second stage here. As long as you have the thrust to overcome this, more rocket on your first stage, less rocket on your second stage, right? If you can overcome that with more thrust, you're looking at an insane efficiency increase here. Now, once again, the payload fairing. Now, I know what you're going to ask. Well, what about the payload fairing? Why, or what about the payload? The payload should be pushing down on the second stage. Well, no, not really. You have to build some structure into the payload attachment fitting up here. What connects a second stage to the payload is called the payload attachment fitting, or PAF. The PAF, you have to build a little bit more structure into the top there because it needs to, well, interface with the load reactor, right? They need to connect, but you should be able to transmit the load from this out through the PAF to the inner stage, so the second stage is super light. All the second stage has to do is basically be strong enough to handle the thrust from the rocket engine. That's pretty much it. So, that's Neutron's idea here for what they want to do. 26 minutes in, your video 26-ish minutes in. I was thinking the other day about aluminum foil. Flicking balls on SpaceX's launch. I'm guessing it's just solid gas, but I'd love you to confirm. Most likely JDG. But yeah, anyway. So, been here 2 minutes and I already learned something. I got you. So what if you make the rocket out of fuel? Solid rocket boosters is the answer to that question, AP. Yeah. Solid rocket boosters. If you make the rocket out of fuel. You just described what an SRB is, for the most part. That's solid rocket. There are some solid rocket boosters designs, nothing that actually flies yet, where you make the entire rocket out of solid rocket fuel. Yeah. Oh yeah. People have 3D printed SRBs and they used PLA and an oxidizer as your solid rocket fuel hybrid rocket engine. Yeah. Yeah, that's been proposed before, dude. Yeah. And you could also theoretically make your nozzle out of solid rocket fuel if you wanted to as well, and use the solid rocket fuel in the nozzle as an ablator. It's possible. Yeah, to keep the nozzle cool. Anyway, problem with SRBs is that you can't turn them off. Now, Kix, you're not wrong here, but I think that's an applicative thing. In what scenario do you want to turn your rocket engines off except that main engine cutoff? I know, Challenger, etc., right? I get it. But I don't think that SRBs shutting off, like, oh, I can't shut it off. We can't shut off the SRBs once they're activated. I think that right there, thinking that way, is basically admitting that your SRB could have a problem or your stack could have a problem. I think that's putting your magnifying glass on the wrong spot. If you can't turn off your solid rocket boosters because you're worried about your rocket having a problem on ascent, you should probably address said problem on ascent. O-rings. Just saying. Just food for thought. Anyway, so no propulsive landing with SRBs. SRBs can use parachutes. Parachutes would be light enough for no propulsive landing. They did it for about 30 years and demonstrated it pretty damn well, actually. Have you never seen Space Camp? Thermal curtain failure. So, anyway, Joe Barnard would have something to say about that. And Joey B. Parachutes don't work on the moon. What does the moon have to do with this? We're talking about reusing first stage reusing SRBs on an ascent vehicle. I didn't realize that we're using it for an ascent vehicle on the moon. What does the moon have to do with it? I'm confused. wait, now you confused me. Anyway, hey, Ebsta, what's going on? So, seemed a bit down the beginning of the stream yesterday. I'm good, Erida. Yeah, I'm fine. He's saying your head is reflective like the moon. Oh, okay. Anyway, so this right here is an awesome design, okay? So we have a reusable first stage, reusable payload bay for the most part, and then it's a fairing, but it's basically a payload bay door. And the second stage and the payload rides inside of the payload bay. Pretty awesome design. I really, really like it. It's a really interesting design. Now, this rocket will be made out of, because it's Rocket Lab. Rocket Lab really favors carbon fiber designs. Neutron will be made out of carbon composite and carbon fiber components. Now, I don't have a, that's fine, whatever. But I'll be honest with you, no one's ever built carbon composite aerospace components quite like in this application. So, you know, you guys asked, and here's me getting to the point. I'm sorry, that took a little bit of a primer here. So here's me getting to the point. Because this has never been tried, it's a great idea, but because it's never been tried, there's, you know, they originally promised Neutron to be done by this year. No, no. Anytime you're trying to do something new, especially with aerospace, it's going to take time. It's going to take time. Now, that's not to say, I don't think that's any particular reflection of Rocket Lab or their development or how they go about doing things or how Peter Beck runs the company. I think they're doing just fine. Something like this does take time, okay? Because it's never been tried. This is one of those things with aerospace. And the plain English way of saying this is that you don't know how it's going to fly until it flies. Because there's that uncertainty with every space flight. Anytime you try something new, you're not going to exactly know what needs to be done to get it to fly. So this feeds into a little bit of a mentality that SpaceX kind of has. They don't know how Starship's going to fly until you send it. You could do all the simulation in the world. There's no way your simulation fidelity is going to get detailed enough to be able to match exactly what goes on in aerospace. The reason why? There is a little bit of a margin of error with aerospace engineering. There's a little bit of margin of error because you're not, once again, you can't exactly predict what it's going to do. It's a thing called Navier-Stokes equations. Basically, it is ridiculously hard to be able to come up with a simulation that predicts exactly what a vehicle is going to do when it flies through the air. So this is the double-edged sword of aerospace engineering. You're dealing with all this crazy engineering, all these numbers, but you're never going to get it accurate enough to match an ascent, the data and the simulation. We live in a simulation that you'd get from actually launching it. That's why SpaceX just launches things whenever they can. And that's why everybody says that ascent data or like all-up testing data is invaluable, because it is. That's data you cannot get with simulation. Our simulations are nowhere near exact enough to be able to predict exactly what a vehicle is going to do. So there's always that margin of error there. So, long story short, Rocket Lab and Neutron, not to say that they don't have the chops to do this, right? They'll get it and they'll test it. Sure, absolutely. Right? Like, it's Rocket Lab. They're the only other people that have even gotten a first stage back aside from NASA and SpaceX. NASA with the SRBs on the shuttle and SpaceX with Falcon 9, right? They're like, right? They're the only ones that have done it. The only ones. Well, there were some Gemini Titan missions back in the day where they did go fish out a Titan first stage from the ocean. But yeah, that Titan stage is actually at the Space Force Missile Museum at the Cape. If you know, you know. Yeah, and New Shepard if you want to go that far, Thomas, right? Wait, when did EJ come to YouTube? I've been streaming on YouTube, Ed, for, I don't know, 2 months? Maybe a month and a half? So here's the thing. Long story short, anytime you're trying to do something new in aerospace, you're trying to push the envelope, it's going to take time. See this thing? This thing right here. It's going to take time. Okay? See this thing right here? Going to take time. That thing, also going to take time. This thing right there. See that one right there? That took time. That took 10 years to make that, to get that to work right. So it's going to take time. Now, the more you test, the more data you're going to get, and the more you're going to understand what you made. This is why I always talk about it's about understanding what you made, okay? And your simulation is never going to give you a complete understanding of your vehicle. You need the ascent data and you need empirical data to match your simulation. But your simulation is never going to be 100% accurate. There's no that is a huge thing with mathematics and aerospace, trying to get the simulation fidelity to be accurate to real life. No one has done it. once again, they're called Navier-Stokes equations. No one's been able to solve those. Yeah. If you figure that out, you're going to make a lot of money. But you also might do a Nikola Tesla and go insane. So, Space News All Stream. We're going to do Space News until the Flame Trench, and then I'm probably going to do some racing after that. But we do have some rocket launches. There's an Electron launch from Rocket Lab at 11 p.m. tonight, which is 10 hours away. And there's Starlink Group 664 launching out of the Cape. Slick 40 down at the Cape. That is launching in about 7 hours, give or take, from now. There's also there's the three-body problem for why simulations can't predict everything. Yep. Yeah, Rogue. Yeah. Aerospace is much more complicated than a three-body problem. Yeah, that's the thing. You have millions of molecules flowing over a wing. Actually, I wouldn't say millions. I'd say trillions. That's, we can't math good enough to figure that out. So there's always going to be an element of testing and flying, right? And then you're trying something new on top of it. So Rocket Lab, obviously, Rocket Lab is publicly traded. So this is my opinion about this now. Rocket Lab's publicly traded. Obviously, finance bros who know nothing about rocket science, if they see Rocket Lab failing, they're going to dump it, right? Anybody that has equity, that doesn't know about what I just told you, is going to dump the stock at the first sign of a failure, right? Because people making monetary decisions about things they don't understand, oh, that never happens. Canceling Constellation. What? Sorry. Yep. No, yep. If canceling Constellation was on your bingo card for EJ Space News, well, congratulations. Good for you. So, has the teleconference started yet? I don't know. When does the road trip start? Next weekend is when it should start. Starliner pre-flight conference is on now. So anyway, okay, I'll sum this up, and it's very clear that you guys want to watch that. So, all right, we can switch over to that. To sum up with Rocket Lab, whatever, it's going to take time. I'm not surprised that Neutron slipped to next year. It's going to take time to build something like what they're trying to do. It'd be better to take your time with this one. New launch vehicles are a pain, especially reusable ones. Anyway, Starliner press conference. Let's go.
I got here just after Butch and Sonny arrived on Tuesday, and it was great to see them here. When the crew arrives, we're getting close to launch, and of course we got the vehicle at the pad now. I'm very proud of the teams that have worked very hard over the last 2.5 weeks. As Jim said, we were able to get a little bit of downtime over the long Memorial Day weekend. I could tell when we came back on Tuesday, people were more rested and really ready to go to hit the final phase of operations, getting to launch. As we said, we're on track for the June 1st launch. 12:25 Eastern is the launch time, and we'll dock about 25 and a half hours later at about 1:50 p.m. on Sunday, June 2nd. If we have to scrub for some reason, we have a backup opportunity on Sunday, June 2nd with a launch time of 12:03 Eastern. And then we would stand down for a couple days and have backups on June 5th and June 6th. It's great to all be here on the panel. I would tell you a few things that we worked over the last few days, and Dana will go into more detail. We received some data from SpaceX on a reflector on ISS that showed during some of their Dragon approaches and the port relocate that there was some degradation in the return signal from one of the reflectors. So SpaceX provided some data to us. We took that data and gave it over to Mark and the Boeing team. They ran a few simulations to make sure if that reflector weren't there overall, we could go ahead and dock successfully with the Vesta rendezvous navigation system. So we did that in the interim, and kudos to SpaceX for sharing data with us. I think one of the things I'm starting to see now amongst all these entities that are flying in space is a sharing of data back and forth, which has been incredible. I mentioned Blue Origin had a recent human space flight suborbital flight where they had a parachute that did not fully inflate. Starliner uses some similar components to that parachute system in terms of reefing line and reefing line cutters that cut that parachute system. Blue Origin provided some data from their flight, shared it with the NASA, shared it with SpaceX, shared it with Boeing. We were able to meet and go through the particular components on Starliner, and we made sure we had good separation from that particular parachute that didn't fully inflate. We went through and looked at all the data, and that's good to go fly. And then finally, one of the last things we worked was there was a component on station, and Dana's going to talk more about that needed to be sent up, and we repackaged some cargo on the Starliner and are flying up about a 140-pound item for Dana and the space station that really needs it. So we had to manifest some of the cargo on Starliner, and that was done today. I think what I've seen out of the Boeing and NASA team and the ULA team working with our space station team is a lot of agility in the last week at dealing with these things as they come up, which tells me that we're really ready to go fly, and we'll take it one step at a time and watch the vehicle. Mark will talk about the weather. We have a really good shot at the weather, and we're just going to watch the onshore flow a little bit. And other than that, we're ready to go fly when the vehicle and the crew's ready. I'll turn it over to Dana.
Thank you, Steve, and thank you all again for being here today. Let's see, Wednesday's agency review was really thorough. Obviously, we had a lot of discussion about the helium leak and also about fault tolerance. I think the Boeing, the commercial crew program, and all the technical teams did a fantastic job bringing forward a thorough discussion on the flight rationale. I feel like we have a really solid mission plan to go fly this flight. From a station standpoint, our responsibility is really what we call integrated safety. That's safety of the two vehicles as they operate together through rendezvous docking, the joint mission, and also undock. Those issues specifically don't really change the risk to that integrated operations space. It's really a subject for deorbit, as Steve mentioned. We did hold our ISS mission management team readiness review yesterday morning. Everyone pulled go, including the international partners. As Steve mentioned, we got surprised by an onboard anomaly this week. On Wednesday morning, our urine processor assembly, or UPA, had a pump that failed. That urine processor takes all of the crew's urine and processes it in the first step of a water recovery system. It then sends it downstream to a water processor, which turns it into drinking water. And so station's really designed to be closed loop and to have the urine processed continually all the way through down to drinking water. And so with that processor failed, we're in a position where we have to store urine on board station. We can do that to a certain extent. We've got bags and tanks that we've got up there for this purpose, but we've got limited inventory. The intent is really to recover and get the equipment going again. In this case, the pump that failed was really expected to run until about the fall timeframe. And we had our next spare manifested on the Northrop Grumman cargo flight that goes up in August. And so it failed a little bit early, which put us in a position where we'd have to store an awful lot of urine. Obviously, adding 2 more crew members to that further constrains the storage capability we have on board. And so we worked with the Boeing team, our ISS team, and our CMC Leidos cargo teams for a quick change to the plan for the Starliner manifest. So on Wednesday, we flew the ORU out here to Kennedy, got it to the launch pad. As Steve mentioned, it's quite large. In its packed configuration, it's in a bag that's about 3 feet long by 20 inches by 20 inches, and it's about 150 pounds total. So pretty substantial size, and the key for the flight was not to perturb the mass properties. So we wanted to keep the mass and the CG of the overall vehicle the same. So we worked to find cargo we could offload or displace without impacting that. And we ended up pulling off 2 crew suitcases. Those have clothes on them. It's funny, you're used to all these technical terms. Suitcases, just like we would take on a vacation. We do have a lot of generic contingency clothes on board, so not an issue. The crew's just going to use that instead of the specific items they're going to fly up. But huge kudos goes to the whole team for the quick response. I mean, they turned this around rapidly. So the flexibility from the Boeing team, from the ISS teams, and the cargo teams was just outstanding to get us to this point so that we could capture this launch opportunity and send up this critical spare to station. We will put it in pretty soon after the vehicle arrives. Obviously, we want to get that capability up and running again. Other news on board space station, let's see, on Tuesday, the Progress 86 vehicle, or 86P, undocked. That freed up the port for Progress 88. That vehicle launched just yesterday. It's in free flight right now. It'll dock tomorrow morning, Saturday, around 7:45 Eastern time, so about 5 hours before the CFT launch. The crew on board is working through EVA preparations. We have a series of spacewalks we're going to do this summer starting around June 13th. So they'll continue working through that. If Butch and Sunny are up there with us during that time frame, we'll still conduct the EVA. We can also move them if we need to for any Starliner critical activities that would have priority over those EVAs. So from a station standpoint, from our crew, from our ground teams, we are ready to go fly this mission, and we're excited that we are on the doorstep of this historic mission. With that, I will hand it to Mike Fink.
He is stored in the bags.
Good afternoon, everyone. It's good
You're
to
welcome.
be back here.
Mikey.
Captain Wilmore, Captain Williams, Butch and Sunny, they're veteran astronauts and my dear friends. We've been training together for a long time, and more importantly, though, for this mission, the crew flight test, they're test pilots, and they are looking very forward to getting flight test data that will help continue the certification process for Starliner, so that Starliner 1, 2, 3, and to infinity and beyond can fly and provide services to the International Space Station.
You Buzz
And,
Lightyear?
Depends on up to
your
Boeing,
movies.
but other missions available out there too. So they're very excited for tomorrow's launch. Butch and Sunny, they haven't seen the capsule since I took them to the launch pad, and then we scrubbed, so it wasn't me. But they haven't seen the capsule since they strapped in on May 6th. So they're actually back in the capsule. They should be there right about now for some comm checks to make sure that all the comm systems are working. They're talking through the TDRS satellites and making sure MCC, the Mission Control Centers in Houston, the Boeing Mission Control Center here in Florida, as well as with the United Launch Alliance. So we're all talking to each other tomorrow. So, but they're also going to take a sneak peek and get reacquainted with the capsule, especially with the new cargo configuration. So that'll just make everything ready, even more ready for tomorrow. I can say that they've been in quarantine for since end of April. They're very excited to go launch soon. But it's been a great process, learning more about Starliner along the way. And the more we know about our spacecraft, the safer and more successful we are with our missions. And so Butch and Sunny, I've talked to them, and they have every confidence in our rocket. They have every confidence in our spacecraft and in our operations teams and in our leadership management teams. And they are definitely ready to go. And speaking of our spacecraft, over to Mark Nappy from Boeing.
Mikey.
All right, good afternoon, and thanks for joining us. The teams are on station, and they're monitoring the spacecraft as we sit here and talk to you. They reported this morning at 3:30, powered up the vehicle, and have been in a continuous monitoring mode, and will continue to work the launch preps and the launch countdown, leading up until tomorrow morning at 4 a.m. when the launch team will come in and start supporting the mission. So far, there's been no issues that we've been working with the spacecraft, so all's going well. Yesterday, we performed the L-2 briefing, and the purpose of that is to close any open issues and I should say, look at the changes that have happened since the May 6th launch attempt and make sure that we've got those all closed and taken care of. That meeting was successful, and we got a go poll to proceed to launch. Today there was an L-1 crew briefing. That went well also, and so we are ready to support going down into the launch countdown starting tomorrow at 4 a.m. We look forward to flying this mission. This is a test flight. We know we're going to learn some things. We're going to improve, and that improvement starts with Starliner 1, Mike, for your mission, and it'll be even better than the mission that we're about to fly. So with that, I'll turn it over to Gary.
Thanks, Mark. So we're very excited to be here today, preparing for our first human spaceflight launch to deliver Butch and Sunny to the International Space Station.
Gary?
The rocket's at the pad. We're doing our final launch preparations today, as Mark talked, making sure everything's working between the launch vehicle and the capsule. For the majority of our team, today's a crew sync day, so they're getting set because the team comes in at 1 in the morning to start the launch count to fuel the rocket in support of tomorrow's launch. So everything's going smooth. We're not working any issues, and want to take this opportunity to thank the NASA and Boeing teams for working with us to get through the past couple weeks since May 6th, and looking forward to launch tomorrow. With that, I'll turn it over to Mark Berger, our launch weather officer.
Right, thanks, Gary. So we're heading into June, and it's an early afternoon launch attempt. So oftentimes, if you're familiar with Florida weather, that would often mean thunderstorms. So no such concern for tomorrow. Generally, local weather and weather down the ascent corridor over the Atlantic look quite favorable for us. That being said, there is one watch item, and that is the local winds. You may have noticed it's already turning breezy out of there with sort of a stiff onshore flow, and that's what we'll be monitoring for tomorrow as well. So taking a look at the numbers here on the forecast graphic, 90% chance of go weather, again, not considering any rain or thunderstorms, maybe a few clouds, but not anything concerning for us. Again, as mentioned, the winds will be a little feisty tomorrow, not only in terms of the magnitude of the winds, but also the direction of the wind. So again, a pretty good onshore component nearly perpendicular to the coast. So that tightens or restricts us just a little bit in terms of favorability. But again, now winds, as you know, are a highly variable factor both in time and space. So hopefully we'll be able to get off without a hitch. Looking at the backup opportunity for the next day on Sunday, again, very similar weather conditions, although luckily winds do ease a little bit. So not only in terms of the magnitude, but the direction becomes a little bit more southeasterly or east-southeasterly, which is not quite head-on to the coastline. So again, that gives us a little more latitude as well. May pick up a few more clouds, but otherwise very favorable conditions for, again, early June.
All right, thank you very much, Mark. And I want to make one correction. If I said AM at the beginning, I meant PM. It's 12:25 and 40 seconds. PM. Don't show up here overnight. You'll only be eaten by bugs. All right. All right. We'll take your questions beginning now here in the room at Kennedy. Please raise your hand, state your name and affiliation, and to whom you are asking the question. We'll start with Marcia.
Probably for you, Steve. Are there any changes to the game plan since a month ago? Is it still planned to be an 8-day docking to the space station? And by my count, that would be the earliest coming back on June 10th. Does that sound right?
Yeah, right now I'm just looking. I knew you would have that question, Marcia. So right now, the mission's going to be about 8 days long, right, to fulfill all the objectives. We talked about some of the things we want to do, some manual piloting and some habitability. We want to demonstrate the ability to do what we call safe haven, which is the crew get in Starliner in the event simulated there's a problem on ISS. We'll do all that. But the earliest landing would be around Monday, June 10th. And that would be an undock around, this is Central, 4:50 a.m. Central. Landing at Wilcox would be the first one around 10:16 Central. And then we have a backup on June 11th at White Sands, and that landing time would be about 5:35 Central Time. So, but again, what we want to do is, once we get docked, we want to take the time to check Starliner out, check out all the systems, all the things we need to do for the long increment flight. And so I would say there's a chance that when we get to these opportunities, if we need to stay a little longer or we need to wait for the weather to get good, we'll stay up a little longer. So.
Irene, in front here.
Thank you. Irene Klotz with Aviation Week. 2 questions for Dana. First of all, do you need the Progress 88 to dock prior to CFT launch? And for Steve, can you go over a little bit more detail about what happened with the NS-25 parachute and what the possible overlap is with Starliner? Thanks.
Nice.
In terms of Progress 88, if they had a problem docking and they were in free flight past the time of launch, we would want to stand down to let them dock. Anytime you have a spacecraft in free flight, it's got a limited duration where it can just stay in free flight. And so it would have the priority. We'd go ahead and deal with whatever anomaly we had, finish the docking,
Discovery,
and
no
then we would
throttle.
get back into discussions about where to launch.
Yeah, I'll talk a little bit about what we have seen with Blue Origin. First of all, Blue Origin has done a great job of working with us and trying to understand what happened in that parachute test. That was actually a crewed flight, I'm sorry. One of the parachutes didn't fully inflate, and so the way a parachute works is it can have several stages of what we call reefing. And so initially the parachute doesn't fully inflate for loads. In this case, one of the parachutes was sort of stuck in what I would call first stage at some amount of the mouth of the parachute wasn't fully open. And so the way that works is there's essentially a line or a band around that throat of the parachute that keeps that parachute from being able to open fully. And what we saw is the cutters, for some reason, did not cut that line. And so it turned out we use a very similar cutter that Blue Origin uses, so it was important for us to look at that data. We went back and looked at all of our test data on our cutters. We've fired them like 160 times out of the lot that we're using, so we had good separation. We've never seen an issue with any of our cutters. All the testing was really superb on cutting the reefing line, and so that's why we proceeded. We have good flight rational and good separation.
All right, Jeff, right here.
Jeff Faust of Space News. For Steve, looking ahead just a little bit, assuming we have a successful launch in the coming days and a nominal mission with no major issues, do you think there's still enough time to get Starliner certified in time to fly Starliner 1 in the first part of next year?
Yeah, I think that'll be something that we'll work on, after the flight. Right now, we're really focused on the crewed flight test and collecting all the data that we need. I think obviously the path to Starliner 1 clearly is the crewed flight test. That is the most important thing we have towards certification. So we'll go fly the flight, and we'll look at the data coming out of the flight, and then we'll make the right call relative to when we go fly Starliner 1. We have to go through this full certification. We really haven't had a chance. Mark and I have been super busy working the crewed flight test, so we haven't really had a chance to lay out that whole timeline yet.
All right, Joey, for our next question.
Thanks, Joey with Reuters. For Steve, I just wanted to quickly follow up on Irene's Blue Origin question. Is NASA interested in learning about how Blue Origin's fixing that band issue? Do you guys open any kind of investigation into that, or are you continuing to work with them? Thanks.
Yeah, I would say Blue Origin has been outstanding. What we have found is like the parachute community between SpaceX, Boeing, NASA, and Blue Origin, it's a small group of people that really work on these parachutes. And so Blue is in the middle of an investigation. They've been great at sharing the data from us. They don't really have what I would call any kind of root cause yet, but we'll continue to follow along with them, our parachute team will.
And that's airborne systems that suppliers that they all share?
Airborne makes the parachutes for all three. I don't really know who the reefing line cutter manufacturer is. So.
All right, Ken?
Hi, Ken Kramer, Space Up Close. Thank you, and good luck to everybody. Great rollout yesterday and remotes today. My question is for Steve and Mark Nappy. I'd like to ask some details about the helium issue, please. Can you tell us, first of all, what was the rate of loss? I've seen a whole bunch of different numbers, and I'd like to know that loss of helium, like in pounds, how much would it be, and what is the volume? What is the weight you have in the helium tank? I'd like to know, on a percentage basis, how significant is that helium leak? What is the margin that you have? Do you have more than one helium tank? Does it go to different dog houses? So if you could
Good question.
talk in detail about the helium leak. Thank you.
Kenny, good question, man.
Maybe I'll start.
That's
with
what I
Mark
would ask.
So the leak rate we saw, I think we talked on Friday a little bit initially at the launch pad in this P2D2 thruster flange. We saw a leak rate of about 7 pounds per square inch per minute. And then we came back to the vertical integration facility, did some more testing, and the leak rate increased to about 70 to 80 pounds per minute. So And keep in mind that leak rate, the volume is very small, so it's like 15 cubic inches of volume. So that's probably the size of a softball in terms of volume. So when we close the manifold valve, that's a real small volume, and so that leak rate will look pretty big. So that's the leak rate. We have roughly, I'm trying to think about how to characterize this in terms of the total amount of helium. We have margin of about, I would say, what we would call 500 psi of margin in the helium tank. The helium tank pressure is about 3,000 psi, so we have quite a bit of margin for the mission. This kind of size leak uses a small fraction of that. That's really our rationale to go fly. And again, we're going to power up the vehicle today, and then when we get to the pad tomorrow, when we activate the prop system, we'll take a look at the leak rate. We can see that leak in the tank, actually. So we'll see if the leak's about what we expect it to be and see if Mark has anything to add.
Yeah, there's about 50 pounds of helium on board, and this leak, if it was left open to vent all the time, it would lose about a half a pound a day. So there's plenty of margin left over.
Half a pound a day, but we're going to, when we get docked to station, we're going to close the manifold, right? So we're going to isolate from the tank, as Mark said. So.
And it's one tank?
I believe it's 2 tanks. So.
Do they go to the different doghouse?
Yes. It's two tanks are plumbed together, right? The tanks are together, and each of those 2 tanks has 2 manifolds that go to each of the doghouses.
All right, let's go to the phone lines, and Bill Harwood is on the line.
Yeah, thanks very much, and apologies for not being in the room with you. This is just a quick follow-up on helium, and I realize nobody expects anything like this to actually happen, but when do you pressurize the system for flight? In other words, when would engineers, get a chance to check that leak rate, just to have some context for the countdown? And finally, if the leak rate really did go up for some reason before launch, would the solution be to simply isolate the manifold at launch and go to your RCS-only deorbit scenario, or is there some rate that you just would say, I'm not going to fly? Thanks.
That's a lot of what we spent.
Guys, can I rewind it? Sorry, I was responding to you. I will answer all your questions about this in a little bit. I just want to hear Bill's question again.
Thanks for the count like this to actually happen, but yeah, thanks very much, and apologies for not being in the room with you. This is just a quick follow-up on helium, and I realize nobody expects anything like this to actually happen, but when do you pressurize the system for flight? In other words, when would engineers, get a chance to check that leak rate, just to have some context for the countdown? And finally, if the leak rate really did go up for some reason before launch, would the solution be to simply isolate the manifold at launch and go to your RCS-only deorbit scenario, or is there some rate that you just would say, I'm not going to fly? Thanks.
Fair question.
That's a lot of what we spent the last week or 10 days working on was all these contingency cases. So the teams have looked at when we open up these manifolds, and that's around T-minus 4 hours, so it's going to be around 8 o'clock tomorrow morning, and then that's when we would see if this leak has increased or not, and if it had increased substantially. The managing of the system is a lot of what the teams worked on over the last 2 weeks, is to, okay, what if it does increase prior to launch? What's acceptable? What would we do as far as troubleshooting? What would cause us to go back and reevaluate our flight rationale? All those conditions have been laid out for the launch team. And the same thing for flight. If we have an increase in leak, or if we have additional leaks, what's the criteria for what we would do? Those are all laid out in the flight rules. The teams have all been trained. The crew has been informed, and we're in good shape to fly.
Mark, I just add that the crew also spent a lot of time at the Boeing facilities in Houston to practice the contingencies. We're not expecting them, but in case they happen, our flight procedures and the crew will be able to safely come home and deorbit, and that was part of our risk trade-offs as we got closer to flight rationale.
Another question on the phone line, Micah Maidenberg. Go ahead.
Thanks, Daryl. maybe you guys just touched on this a little bit, but, Steve and Mark, regarding the design vulnerability and a plan to address that, having gone through the review this week, could you just explain one more time a bit more about accepting that risk, however remote, for CFD? Thanks.
ATR, listen to this part.
I'll start, and then we'll let
this part's important regarding your question.
As we talked about on Friday, we have different methods of deorbiting the vehicle. We primarily use what we call the OMAC thrusters to deorbit with, and those are 3 OMACs per doghouse. And we got doghouses all the way around the clock, top, bottom, port, and starboard doghouse. It turns out for certain failure cases, we would lose OMAC thrusters. In other words, if we lost a helium manifold due to either the valve not working properly or some other line leak, which we have to be way bigger than what we're seeing in this flange, we would lose that doghouse. And then the way the software works is there's 3 OMACs there, 2 of them which would fire for deorbit, or maybe 1 if we use all 4 doghouses. The opposing doghouse, then the software says, I can't fire those OMACs because of asymmetrical thrust. And so it would really require the loss of 2 adjacent doghouses, the helium systems in 2 adjacent doghouses, say the top and port or the top and the starboard, to get into this situation where we need the RCS thrusters. So it's very low probability that would happen when we looked at the potential failure modes. But we have a way to get out of that, and that's when we would use this. If that were to happen in flight, which we don't expect it to happen, and we're managing the system so that we don't get into that scenario pre-flight, but we could use these 4 RCS jets to deorbit in the 2 burn sequence that we talked about on Friday. I'll see if Mark has anything to add.
Yeah, I talked to the process that we go through to come to these conclusions with safe flight rationale. There's a number of different disciplines that get involved, and we walk through these step by step, and the level of what if questions that are asked is pretty amazing to make sure that we fully understand what's going on, what our problem is, what our solutions are, and what if we're wrong. And that is what took place over the last couple of weeks. Not only does our team with Boeing and NASA work this together, but we have independent people that come in, both from Boeing and from NASA, that looks over our shoulders to make sure that we're answering all these questions and addressing the issue correctly. So with that, besides being a very low probability that we'd get into this situation, we have very high confidence that the solution we came up with works.
All right, let's come back to the room, and the gentleman in the 3rd row.
Thank you.
Oh, that's Vulcan over there. I know that guy.
The space program in Spanish. Last
Not that guy.
Conference, you mentioned that Boeing is thinking in a potential redesign of their propulsion system. So I would like to know, I think I did this question before, is this needs to be done before Starliner 1? If that's the case, how does this affect the certification? Or it could be a potential delay on Starliner 1?
Okay. As far as a redesign goes, no, this would not be under the redesign. What I was referring to is that this leak has somehow sneaked its way through the system. What we suspect is that the seal was somehow either damaged during installation, or there was some debris in there that caught up and is not allowing the seal to seal properly. And obviously, we'd like to screen that before we get this far. So what we're doing for Starliner 1 is coming up with a screening technique that we can go apply to all the thrusters that are being built up right now for Starliner 1 to make sure that we don't have this same situation.
And then on the system vulnerability with deorbit, we would go look at, is there a way to maybe do a little more testing for those 2 big burns, hot firing the thrusters, or is there a software change that would enable even more thrusters to fire? So.
All right, let's go to the phone lines real quick and get Stephen Clark. Stephen, go ahead.
Hi, thanks for taking my question. Daryl, Stephen Clark, Ars Technica. Just to follow up on an earlier question about the flight rule for the helium leak. Yeah, when you pressurize that system at -4 hours tomorrow.
Discovery, throttle up.
Vanguard?
I guess the last time you checked the leak rate, it was 70 to 80 pounds per square inch. What would be the acceptable
That's not the
level
leak rate, Stephen.
of leak rate to press on with the launch tomorrow?
Turn to our resident flight director on the panel.
Yeah, we could manage about roughly a double the leak rate, and we can manage it in flight. What we'll do is we'll look at once the system is pressurized and open, we will be able to look at how much helium is being used from the tank. We talked about two tanks. Think of them as one tank because they're together. So we'll look at we know what that drop in helium should be per hour in the tank for this size leak. So we'll look at that to make sure it hasn't changed. And then if it has changed, we can go isolate the manifolds and then go take a look at this specific manifold and understand the leak rate there. And we've got criteria in place that says when we'd stop and talk about it or whether we were ready to go fly. So.
And Will Robinson Smith is on the phone. Go ahead.
Danger.
Yes, hi. Excuse me. Thanks, Daryl. Will Robinson Smith with Spaceflight Now. So just to put a button on and follow up on Bill and Stephen's questions. So if there were to be an isolation of the manifold, you would still be able to proceed with launch. Am I understanding that correctly? And is there a specific rate in the leak in which you would, feel more comfortable standing down and taking a deeper look at it? Thanks.
Yeah, as I said, so we'll go look at the leak rate, looking at the drop in the tank, right? And so we've got a criteria of about 20 psi per hour we're looking at before we would isolate manifolds to go at that kind of leak rate. If it's more than that, we would think maybe the leak has changed in our manifold, so we would go look at that. We wouldn't launch with the manifold isolated. Remember, part of the beauty of the Starliner system is it has an incredible abort system. And that abort system relies on needing all the OMAC thrusters, orbital maneuvering thrusters, in each of those doghouses. So we wouldn't launch with a manifold isolated. We could manage it on orbit. Should we get on orbit and see some change in the leak rate, we could close a doghouse. As Dana talked about, we looked at the approaches to station, and it really doesn't, with the doghouse down, we can go ahead and approach station. It really is affects at the end of the mission, the deorbit capability. And then we really have a criteria up to 30 psi per hour in the tank that we wouldn't launch if it was above the 30 psi per hour in the tank.
All right, we've got a number of reporters on the phone, so we want to stay there for the moment and pick up Andrea Leinfelder.
Look bigger if I should remove it.
Try to get us up here.
Cargo headed to station.
All right, I'm just going
It's
to get
on
us
the
to live.
vehicle. For example, the crew's got
She asked a question about the
spacesuit parts
toilet.
and a few other things that are being taken up for us. The two specific suitcases that came off had clothes for both Butch and Sunny in them, and also some crew specific, what we call hygiene equipment, so crew members can pick some of their own unique hygiene
toothpaste
materials. Of course, we have generic hygiene, shampoo, soaps, etc. on board that they can just use from the generic supplies. Same with clothing. And so that's what they'll do. They'll just use our generic supplies that we have on board. And the reason why we have them there is for cases like this. In case a cargo resupply vehicle doesn't get there, we keep a certain contingency supply on board. And
Now, just the certification process. About 80% of the certification process, we know what we have to go do today and have been doing that over the last year. And that plan closes by November to have a certification review with NASA. The 20%, or maybe a little bit less, that's left over is reliant on the mission, on the CFT flight. There are likely going to be some kind of in-flight anomalies or things that we need to, data that we need to collect from the CFT flight. We have to download that data and analyze it and understand it, and that's going to be part of what we bring to the certification review, the results of that. So obviously the longer it takes to fly CFT, the shorter that period becomes for us to review that data and make sure that we have reports written and we understand it. So that's the variable. How many things how many in-flight anomalies do we have on CFT, and when do we bring the vehicle back, and do we have enough time to turn that around by November? If we don't, then we will move that review or do partial review. So that getting the certification review done as soon as we can is important, regardless of when we fly.
All right, back to the room. And Marcia, you're in the front.
Marcia Dunn, Associated Press. 2 quick questions. Steve, how deep into June can you keep trying if things don't work out in the next week? And for Mike, when the crew is at quarantine in Houston, can they go home, or have they been stuck at not seeing their homes since the end of April? How tough has it been, this quarantine for so long?
Yeah, we have launch opportunities, as I said, June 1st and 2nd, the 5th and the 6th, and then I think we would have to talk with Gary and ULA. We've got to stand down for a number of days to do some replacements of batteries on the launch vehicle, on the rocket, and then I think we'd have to talk about what the opportunities were after that. So.
How long is that?
Gary can comment on how long it takes to replace the batteries.
So with the magnitude of the batteries we're looking at changing out, it's probably about 10 days.
Yeah, so real quick about Butch and Sunny and how tough the quarantine has been. It's so they were able to go back to Houston. We were able to do some training there. We do take the health stabilization program very seriously. We learned a lot, especially we all learned a lot during the COVID. But Butch and Sunny were able to go home a little bit. We have to be careful about maintaining separation with the family. But Barry Wilmore, if you know him, he really likes to sit on his lawnmower and cut his grass. So I think he has the best manicured lawn in his neighborhood. And I know Sunny enjoyed spending some time with her puppies, their dogs, and so they were able to get and that again, keeping the crew motivated and focused on the mission is important. So we were able to manage that with the flight docs, and then so they're back here obviously and ready to go.
All right, Irene, here in the front.
I'm not sure if this is for Steve or Mark or Mike as well. With the benefit of hindsight, if CFT had launched on May 6th and then the leak was discovered, was the understanding that there would have been an issue for a backup deorbit burn, do you believe that would have been recognized, and was the solution to develop the 4 RCS dual burn, was that obvious, or does it only seem so now after you went through this and not in the heat of needing to get this crew home? Just trying to get a sense of what discovering this before launch sort of provides. Thanks.
Yeah, I'll start and then maybe let Mark add. I would say if we would have launched back on May 6th, we would have gotten on orbit and we would have seen this leak after we docked and closed the manifold. We would have seen this small leak. I think we probably would have gone through the system and we might have figured out that we had this vulnerability. It's really hard for me to speculate. I think we would have maybe seen it and figured out this solution that we came up with. I mean, the teams, when we found the leak, it didn't take very long to see that if we started talking about losing dog houses, that we had this vulnerability. So I think we would have understood it pretty well on orbit, and we would have then started looking at what the options were and see if Mark has anything to add.
Yeah, I'd be probably a little bit more forward on that. I'm 99.9% sure we would have caught it. As part of this troubleshooting,
well, yeah, of course, because you did.
It said this is where all the leaks could occur. And as we went through that is where we discovered this fault-tolerant issue. Had this occurred in flight, we would have had a unexplained anomaly coming home. We'd have built that same fault tree, we'd have gone through the same process, and we'd have learned the same thing. So I'm very confident we would have caught this.
Just to add 2 sentences, the process of developing the flight procedures and understanding with 8 RCS and 4 RCS I think it was very similar to what we would have had done anyway. The only difference was that Butch and Sonny were able to be there for the procedure development and for the testing out. Had they been up in space, then their trusty backups and Starliner 1 crew, we would have joined the team and helped with that. So it's we think we would have gotten to a similar, if not the same answer.
Okay, back in the front of the
That's
room.
a decent
Joey?
question, drummer.
Thanks. Question for Steve or Mark. Have you found out anything more about why you think the seal failed and led to the helium leak? Is that something you guys are continuing to be interested in? And then for Mark, if the delay goes beyond Thursday and the rocket has to have its batteries replaced, what on Starliner has to be replaced or replenished, if anything, and how long would that take? Thanks.
Start with the seal question. We are staying hungry to find out what exactly happened here. Let's learn as much as we can. So we have some doghouses that we're currently taking apart in the C3PF right now, and we plan on taking those apart and looking at those seals very closely to see if we can see anything that would give us more information about what might be happening inside of this one. So we will continue to look for the root cause and try to build evidence on what it is. You know, we know it's the seal. We just don't know, was it damaged or was there some kind of debris in there with the leading causes, and we'll work to try to determine what that is or what that was. On the, so your second part of the question was on what is your replacement Starliner if it goes beyond Thursday? So the work we have on Starliner, we do have some limited life items that we would go take care of as well, but it all fits under the window of Gary's flight termination battery systems being changed out.
All right, back to the phone lines, and Marina Koren is on the line.
Hi, Marina Koren with The Atlantic. This is a question for anyone who knows the answer. What are Butch and Sonny planning to have for breakfast tomorrow before launch?
All right, that's fair.
I'm supposed to know that answer, but I called them up today, and unfortunately they were headed off to the launch pad, so we don't have that answer. But I will assure you, it'll be a delicious breakfast.
Okay, we'll take another question on the phone line. Anthony, the Spectrum.
Hello, thank you for taking our questions today. I'm just trying to, I guess, wrap my head around this, and I'm trying to use it in terms that most people would understand. If this was an airplane and there was a leak like this, I really don't think it would be allowed to take off. So I'm trying to understand why NASA and Boeing says, you know, we have a good backup plan here, we can launch this, but why don't we just play it on the safe side, roll it back, take the Starliner off the rocket, and fix the seal?
It's a good question.
I'll try to answer that, and we'll see what Mark has to add. I mean, I think, you know, first of all, we looked really hard at what our options were with this particular flange, and the fact that this flange has a fuel line that goes into the flange and an oxidizer line and a helium line all going into the flange makes it problematic to work on. It makes it almost unsafe to work on. So what we really have taken an approach is for this size leak, when Mark talked about, you know, it's a half a pound a day out of 50 pounds of total capability in the tank. I mean, it's a really, really small leak, and it's well within the margin that we have. And so sometimes for space flight, you plan for contingencies and you design the vehicle to have margin. And in our case, we have margin in the helium tank. And we've looked really hard and worked really hard to understand that margin and to understand maybe the worst cases. And we took the time to go through that data, and we really think that we can manage this leak both by looking at it before we launch, and then if it got bigger in flight, we could manage it. In fact, we could handle, as I said on Friday, a leak that's 100 times worse than this. So in this one flange. So when we looked at all that data, we concluded that the smartest thing to do was to go fly the mission, and we could fly it safely, and we would have the redundancy we needed. And I'll see if Mark has anything to add.
It's really just a matter of safety. When we looked at this problem, it didn't come down to making trades. It came down to, is it safe or not? And it is safe. And that's why we determined that we could go fly with what we have.
All right, another question on
So
the
there.
phone. Leo Enright with Irish Television. Go ahead.
Leo.
I think this is for Mike Fink. Just wondering about transatlantic abort.
I know that guy.
scenarios.
That's Vulcan.
I haven't seen any reference to a transatlantic abort zone, so I was wondering what happens. Can you talk us through it? And I'm assuming that this would be a water landing, and they're not going to parachute onto Shannon Airport.
No, we would not be landing in Shannon Airport. So there is a period of time over the North Atlantic Ocean, a spot over the North Atlantic Ocean. It's called the North Atlantic Exclusion Zone that we don't want to land because the water is always cold and wavy and dangerous. So Starliner, along with the dual-engine Centaur, has the capability of, once it gets near this exclusion zone, to head back towards Canada, and it flies kind of a burn, points towards Canada and flies back, and we call that a St. John's abort. And then if that's not going to work, we can continue the flight or continue, and we fly outside of onto the Irish coast in the water at a specific point. There's a guided entry sequence, and it'll take us close to Shannon, Ireland, right off the coast, and then hopefully, and we're counting on you for the Irish Coast Guard to pick up my crewmates, and then we'll get them back to the U.S.
Mikey.
Another question on the phone. Tim Fernholtz. Go ahead.
Hi there. Thank you for taking my question. This one is for Mike. I was just curious for my readers if you could share the perspective of the astronaut office in the last week going through the analysis here and coming up to this flight rationale. What is your perspective on it? And I was also curious what it's like for an astronaut to fly in a vehicle that has a deviance like this. I was curious if that had happened in your own career. Thank you.
Yes, so from an astronaut perspective, one thing that I'd like to say is that, and we mentioned it here, the NASA Commercial Crew Program Office, as well as the Boeing Company, have included us and Butch and Sonny and their representatives and all of our Flight Operations Directorate, and we're part of the team. We know what's going on. We understand the discussions and the risks that are being talked about for being mitigated. Butch and Sonny especially have a very strong voice that if they were concerned about something, we would send it up through our chain to the chief astronaut who would take it forward. I think if you ask Butch and Sonny directly, and I can answer for them, that they feel very comfortable and confident that we've chosen a good path forward. And as flight testers and as engineers, this is something that we know. It's giving, I don't say birth to a new spacecraft, that's a little dramatic, but when you have a new spacecraft, you need to learn all about it. And this has been a great exercise in understanding about all the nuances of a new spacecraft, as well as what are we going to do about it, how do we work together as a team. And this is a really good example of finding a tricky problem and coming up with solutions, answering a lot of what ifs, and looking forward to saying, all right, how do we make sure this doesn't happen again? And all of those pieces are in place. And that's part of developing. This is development, not operations as much. And we see those same kind of things in airplane programs I've been involved with, as well as first times we got to the International Space Station. I remember I was there for that, and we were learning how things operated, and we learned what pieces were going to fail sooner than later, and we know our space station really well now. And we're going to get to learn Starliner through a lot of operations even better. So this is, I don't say par for the course, but this is what we do. This is how it is to develop a new spacecraft, and we understand that everything isn't going to be perfect. So what do we do about it? And we have good discussions and good understanding as we move forward comfortably. And the crew is a part of it, not just Butch and Sonny, but all of us get a voice and get understanding. So we are excited for launch, and we're confident. We have every confidence in this mission.
Well said, Mike, and we'll end the briefing on those words. Thank you to our panelists for taking the time to join us, as well as the members of the media here in the room and on the phone. A reminder, the ULA Atlas V rocket with a crewed Boeing Starliner spacecraft is set to launch at 12:25 and 40 seconds p.m. Eastern Time tomorrow, June 1st. Coverage on NASA Plus and our website, nasa.gov/live, begins at 8:15 a.m. Eastern Time, with special guest star Mike Fink is on the broadcast. So we looking forward to that. Should be entertaining as well as informative. Until then, everyone have a great afternoon and go CFT.
That was the Starliner crew flight test pre-launch news conference. Sawyer was in the queue. They didn't answer his question, but they chose to answer that last dude's question. Just all right. That last one was kind of Bush League. You going to stream the Starliner launch? Absolutely. Actually, yeah, there was a pretty. Most of those questions weren't bad. Yeah, not bad. NSF Sawyer. Yeah. I'm talking to him right now. Yeah. Okay, you guys had questions. Give me 1 second. I got to tell Sawyer something real quick. Sorry. Okay. All right. Do they cut the queue short all the time usually? They don't ever answer NSF's questions, dudes. I don't know what the hell that's about. It's kind of a little bit on the annoying side, but hey, whatever. All right. So, sorry. I needed to shoot a question out. I was asking NSF a question. So, all right. So the gist of this is that they're going to launch Starliner with a known helium leak. Yeah, I've only ever seen them answer Ryan Catton's question when he was there. Like, they used to always answer Chris G's question. I'm not sure what that's about. Maybe they don't like the name. It's possible. Possible. All right, so I was trying to get as much of that press conference as I possibly can, but yeah, people are shooting me messages left and right, as per usual. It's okay. It's just the point where I need to pay attention. So I didn't get all the information exactly, but I got most of it. Sawyer is writing for NSF, mate. Yeah, for NSF. Yeah, they answer Phil's questions for sure. All right, so Starliner has a known helium leak. Let me first thing that I'm going to do is bring you guys up on Starliner nomenclature. Phil brings donuts. Not bad. So here's a picture from NASA of the Orbital Flight Test 2. That's a picture of Starliner from the front, and I need a picture of the service module. Gotta type. Where are you? Where are you? Where are you? Oh, where's that service module, bud? Okay, because, yeah, in order to explain this right, I got to show you guys the different pieces. That's an old version of Starliner. I don't want to mess it up, mate. Huh. Oh, it's a thumbnail. Dang it. Gotta go to the side. I think Vulcan is Space Scout, Meg. Oh, you betcha. How many dog houses are on Starliner? Starliner's got 4. This is what I'm dealing with today. Oh, boy. All right, let's try this. Images.nasa.gov. Starliner. I just need a good picture of the service module. From the bottom, preferably. Yes, I need a picture from 1920. That's what I thought. Thank you. Yep. Nice. Yeah, that one will be good for what we're trying to do here. That one would be good for explanation. So we got that one, we got that one. I'm just trying to put together somewhat of a report here for you guys to understand. You gotta define all the dang pieces. Okay, this one will work too. All right, so look, inflatable Starliner. So here's Starliner. This looks to be a pretty updated version of it. All right, so Starliner has a couple of different principal components. You have obviously the capsule part. Capsule part is where the people are. It can take up to 5, but probably will be flying with 4 for NASA missions. You can do 5 with it. I think right now it's configured for 3 seats. Calypso, which is the Starliner that's on the pad right now. Now, these forward components are aerodynamics, so that's basically the fairing for the docking port. Now, this is the reason why I know this is an older version is because the newer versions have that. This thing can open and close to protect the docking port during ascent and descent. Now, that ring right there, that ring still pops. The parachutes are behind that ring. That ring should... they redesigned it since then. But whatever. That's not part of the system we're necessarily talking about. I get more into the reefing with the parachutes later. I saw one at Spaceflight Now. Yeah, that one will work too. Oh, that's an Aerojet Rocketdyne picture. That'll definitely help. So I'm trying to just organize my thoughts here. There was a lot of information conveyed in that press conference. So you got your capsule here. The capsule does have some thrusters on it. Those thruster systems are just basically to roll a capsule for the most part, and for venting to vent excess propellants before landing. You need some RCS to go through reentry, so the capsule is steerable to an extent. I can talk more about that if you want to understand that, but those thrusters are not the issue here. The issue here is on this part. Obviously, number 6 here is the heat shield. I don't think I need to tell you what that does. Now, behind the heat shield here, you have your umbilical that connects the data and power from this. Power is generated on the very back of the service module. There's solar panels on the bottom. The reason why it has a hole in it is because of the payload attachment fitting right there. So that's the part that connects to the rocket where that ring is. Now you have your service module. The SM is here. I need one more picture of this here. The service module is basically houses all the thrusters and power generation systems. I need one more picture to get this right. There was a picture I found last week of there's a picture I found last week of the open doghouse on the service module, because we need to get into a little bit of nomenclature for the service module here. I think I may have found it. Just give me 1 second to get one more picture here. And once again, this is it's important to kind of understand what each thing is called. It makes the explanation a little bit easier. Ah, found it. Here we go. All right, so the service module, once again, you have your payload attachment fitting right here, and then you have your solar panels down here. This is an aero skirt attachment right here. We can get more into that later. So on the service module here, you have 4 thruster blocks, is what they're called. There's one at where's the first picture? So the hatch is on the starboard side right here. So 12, 3, 6, and 9. So you have a zenith and you have a nadir thruster block, and then you have a port and starboard thruster block. These are designed for on-orbit and deorbit operations, okay? Now, so I said Starliner has RCS here. Now, obviously, anything that's south of the heat shield here is not coming back down in one piece. The service module is disposable, okay? It has a jettisonable service module, kind of more vanilla capsule nomenclature from what we've seen in the past. Gemini, Apollo, etc., etc. Soyuz, if you want to rope that in too. So you have these thrusters on the capsule here, and those thrusters are used for descent, okay? Now, the service module is used for deorbit, okay? Those thrusters, number 4, are used during reentry. This is used to deorbit, and it's also used for on-orbit operations. Now, you have these 3 thruster blocks here, and the thruster blocks are designed specifically for, well, like I said, on-orbit maneuver changes, on-orbit maneuver changes, and deorbit burns. And then rendezvous proximity operations. So RPOD is what it's called. Rendezvous proximity operations and docking. Docking to the ISS. You need thrusters to be able to move into the docking port. In order to do that, you need thrusters controlling 6 axis of control. Okay? This is basic kind of plane and spacecraft nomenclature. So capsule has pitch, yaw, and roll. Those are the 3 rotational axes. Okay? Pitch is like this. Yaw is like this. Roll is this. Okay? You have thrusters that control each one of those. And then, on top of that, you have thrusters that do translational control. Forward, back, left, right, up, and down. 3 axis of translational control, 3 axis of rotational control. So, there's a lot of thrusters that do a lot of different things. Now, once again, let's look at the dog box, or the doghouse here. Dog box is a transmission. You have 4 of these. 4 of these thruster blocks are... So how do these thrusters work? Okay, let's get a little bit into that here. How do these things work? Okay, so these thrusters are very similar to the thrusters that were on the space shuttle. Starliner, because it's Boeing, and Boeing operated the space shuttle, operative word there, operated the space shuttle from when they acquired Rockwell International in 1993 to 2011, the end of the program. And Boeing, wanted to reuse the thrusters. Why? Why would you reuse the thrusters from the shuttle? Propulsion development is one of the most expensive parts of any rocket program. Designing new engines takes a ton of time. Rudy, привет, как дела? So that takes a lot of time. So reusing the components is probably the right move here. In hindsight, I don't know. But anyway, so you have translational and rotational thrusters here. So now, if you notice, some of these thrusters are bigger than others. The reason why is these thrusters they're not really constant firing rocket engines. The reaction control system usually uses a different fuel delivery system and a little bit of a different type of burn. Now, like I said, what do these thrusters do? They control, translational movement. These are very, very small corrections on orbit. You don't need a lot of thrust to move a spacecraft around up there, okay? I'm good, Ollie. How are you? So, they had extra thrusters in the junk box. I don't think they took the exact thrusters off of the shuttle. They probably didn't. They probably made new ones that were the same design. Using the same production line, probably a good idea. Hey, around about 32 months. Yeah, the design is the same. They're derived from the shuttle. I know that they are. They're not an exact rep. They're not the ones. They didn't go to Atlantis and cannibalize it for parts, even though they've done that a couple of times, like the engines. They took the main engines off of each shuttle and put it on SLS and sent it into the ocean. Anyway. So these thrusters are very, very fine control thrusters. Now, I said that the fuel delivery system is a little bit different on these. So on Starliner, these thrusters are what are called pressure-fed hypergolic systems, all right? Pressure-fed hypergol thrusters. I'll be mentioning that a lot here. Now, what's the principal difference between this and like a shuttle engine or a Raptor engine, right? Raptor engines use fuel pumps. They use a fluid impeller to pressurize fuel and deliver it into the rocket engine. You need fuel at high pressure because you need to, in a rocket engine or any type of combustion for that matter, you need fuel delivered at high pressure, right? And you need to go from high pressure to lower pressure inside of whatever your combustion chamber is. The reason why is because you need the fuel to atomize. So with Raptor, or like we'll take the shuttle engine, or even we'll take the Merlin, even simpler, Merlin engine on Falcon 9. You have two fluid impellers that are basically just a big water pump. It's a liquid impeller or fluid impeller. And those pressurize your fuel and oxidizer, which is liquid here, deliver it to the injector, the injector plate on the rocket engine, high pressure, goes through the injector plate, high pressure to low pressure inside of the combustion chamber, boom, comes out the bottom. That high pressure to low pressure spreads out the fuel and oxidizer because it's going from high to low pressure. To get you a good atomization to make an explosion. Now, that's how those engines work. These engines are a little bit different. There's no fuel pumps in this design. There's no pumps in thruster design. These rocket engines here, and they are rocket engines, they're just small rocket engines. These engines here have what's basically akin to a fuel injector. Kind of similar to a car. I wouldn't be surprised if they were some type of Bosch injector or something. Like, I wouldn't be surprised. But they're from the shuttle program, so probably not. So what these thrusters do is they spray hypergolic fuel and oxidizer into the rocket engine, and hypergolics don't need to be atomized or anything. I mean, you can get them to atomize if you really want to. The fuel injector you probably uses some type of pintle for the fuel and the oxidizer, and it sprays it in and makes a big old explosion. Okay. Now, why does it make a big old explosion? It makes an explosion because, well, the propellants that we're using here are monomethylhydrazine and nitrogen tetroxide. Hypergolic propellants, if those are like, yeah, kids, Walter White, chemicals, what are you talking about? Polyethylene, Jesse. I'm talking about polyethylene. No, monomethylhydrazine and nitrogen tetroxide, when they find each other and atomize together, when they combine, they explode. This makes for a very simple design. You don't need a spark igniter. You don't need a torch igniter. You just need to get the get the two things to go into the rocket combustion chamber, and that's it. That's why their hypergolic systems are used for RCS. Now, here's another reason. The other reason why you'd use something like this is because monomethylhydrazine and nitrogen tetroxide are chemicals. It's a chemical compound. And this type of compound, you don't have to worry about boil off. You don't have to worry about them decomposing or changing state on orbit. Monomethylhydrazine and nitrogen tetroxide are both very stable. So you can store them for a long time on a spacecraft that's going to dock to the ISS, for instance, or take a flight out to the moon, right? That's the one we want. So that's a hench-looking coffee maker. Oh, yeah, it makes great espresso. So another thing to understand about hypergolic propellants is that they'll kill you. Yeah, if those chemicals sound like a type of chemical that you don't want to be near, yes. Nitrogen tetroxide and monomethylhydrazine will kill you at like 1 ppm or something. Yeah, like it's not good for humans. Very good for a spacecraft, really not good for humans. Yeah. Very toxic propellants. That's the downside to it. If you want to talk from an engineering standpoint, there is a little bit of a downside. It doesn't give you the best explosion, but the simplicity of the design, is a trade-off for efficiency. These thrusters are so simple to make, you're going to take an efficiency hit because they're so simple, right? Trade-offs. That's engineering, and that's aerospace engineering in a nutshell. Rudy, you said your teacher worked on the pad abort engines for Starliner. I got to say he hates them. Whenever I ask him, he remembers the long nights troubleshooting the failure they had on the test stand. It happens. Is it a 1-to-1 mixture? Actually, Willie, I'm not 100% sure. That's a really good question. I think it's roughly 1-to-1, but I'm not sure. We'd have to ask a chemist or something. All right, so now, how do they deliver? So there's no impellers, there's no pumps in this system. How do they deliver fuel to these things? Well, helium. I said it's a pressurized hypergolic system, okay? So, there's going to be some funny words here. So you have a helium tank. Steve Stitch in that press conference said there's 2 of them. These are your pressurant tanks. How do you get fluid to move somewhere? Well, you could pump it, but pumps are, once again, that's more complicated than what I'm about to tell you. Pumps are a little more complicated. They have a lot more moving parts, etc., etc. So they have helium tanks. These helium tanks are called ullage tanks, all right? In this particular design, they could be used for... Helium tanks aren't necessarily always used for ullage. It's almost like rocket science is complicated. So what these helium tanks do is, well, in Starliner's case, each tank has manifolds, and the manifolds do go out to these thruster blocks. So why would they have 2 helium tanks? Redundancy and margin. We'll get into that a little bit more later. 5th, Rivian. So the helium tanks also have one of those manifold lines being delivered to each hydrazine and nitrogen tetroxide tank. Now, why? Why would you're just going to pump helium into these tanks and it's just going to shoot the propellant down into the rocket engine? What if some helium gets into the line? Well, if some helium gets into the line, explosions happen, which is why the fuel tanks, the hydrazine and the NTO tank, have bladders inside of them. Think about like if you had a propane tank, for instance, and you take a balloon, right, and you inflate a balloon with propane inside of this propane tank, boy. So these are called fuel bladders. And once again, I'll bet you dollars to donuts, these fuel bladders are the same ones that were used on the shuttle's OMS pods. If I had to guess, it's probably the same thing. Hey, those thruster blocks on the shuttle worked fine. I mean, why reinvent the wheel? They just took a shuttle OMS pod and made it into a service module for a capsule. I mean, I say that like that's some easy thing to do. But the helium goes into the cavity between the outer wall of the tank and the tank bladder. You pump the helium into the bladder, pneumatic pressure builds up, and it squeezes the tank, like squeezing a balloon, and it shoots, you can pressurize the whole system, right? So fuel will go down into the rocket engine. Now, obviously, I said these thrusters, RCS is usually modulated on spacecraft for thermal reasons. Why? Because things exploding in space don't really explode like they explode down here. There's nowhere for the heat to go. So keep in mind that RCS are, they're modulated for temperature reasons. So they don't, well, melt the thruster. There's nowhere for the heat to go. In the vacuum, you can't convect anything. So you can't convect anything, and you can rely a little bit on thermal radiation. So shedding heat through light, which is what like SpaceX's engine does on their second stage. The Merlin vacuum, it glows. That's the cooling system. It sheds light. It sheds heat through black body radiation. So light is what dissipates the heat, because you can't rely on air. You can't rely on convection, because space, there is none of that up there. So RCS is modulated to basically not melt the thrusters. Okay, so keep in mind that these thrusters are modulated. So if they're modulated, right, you need a valve on your fuel injectors on the engine. Starliner has 2 fuel injectors, one for hydrazine, one for nitrogen tetroxide. So how do these valves move? A fuel injector on a car is an electronically actuated solenoid. So it's an electronically actuated valve. So you send an electrical signal to it, it opens, sprays fuel into the car's combustion chamber, air is coming in from the intake, explosion, boom, piston goes down, wheels turn. Simple. Simple. Starliner's a little bit different. You don't want to pressurize those helium tanks. You don't want the helium tanks to pressurize the hydrazine and NTO bladders, squeeze them out, and to just shoot all the fuel into the RCS all at once. You need valves, just like a car has. Well, they're not the same. Valves on a car are not valves on these things. They're more, like I said, they're more like a solenoid. Now, Starliner does not use an electronically actuated solenoid. They use pneumatics. They use what's called a pneumatic actuation, kind of like a Formula One car. Valves on a Formula One car are pneumatically actuated. Why would you do this? The pneumatic system can allow the valves to open and close faster. You can get shorter duration and shorter lift on the valves for modulating thrust, right? Anytime if you've ever played Kerbal and you're just tapping the RCS to do fine movement, yeah, real spacecraft do that all the time. Yeah. So, your fuel is pressurized inside of this. Helium is squeezing the bladders in the tanks. The pressure goes to the engine, and there's another set of valves there, the fuel injectors. Those valves are actuated via helium, okay? Helium, the pressure line, so you need to pressurize the valves, right? And when the valves open and close, the helium, when you send the signal to open and close the valves, the helium will open it, and it'll force the valve open. Why would they do this as opposed to a straight electrical design? Most likely derived from the shuttle. Once again, Dragon, as far as I know, does not have a pneumatically actuated thruster. I don't think the Draco engines do that, but I could be wrong. Don't know. I don't know enough about pressure-fed hypergolic systems to be able to say that or not. So you have helium. So you have helium that goes to the tanks, squeezes the tanks, pressurizes the line to the thruster, and then you have helium that goes pneumatically to the thruster to be able to open and close the valves to turn the rocket engine on and off. Believe it or not, that's one of the simplest ways we have for spacecraft propulsion and doing fine maneuvering in space. So like, once again, RPOD, rendezvous proximity operations and docking. Which system is more prone to failure? A fluid impeller system, Jordan, I would say is more prone to failure because there's more moving parts. You have an impeller that's spinning at ungodly amounts of revolutions per minute, and that's a lot of moving parts to get a liquid fuel, fluid impeller, liquid fuel engine. Well, we'll call fuel actuation, I guess, or oxidizer actuation. There's a lot of moving parts. More than that, rocket engines are complicated. So, now, think about this. They were talking about manifolds. Each manifold goes to the doghouse, and then most likely goes through another manifold to all the different thrusters. How many thrusters are on this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 thrusters in each doghouse. Why so many thrusters? 1, derived from the space shuttle. 2, redundancy. Operative word. 3, This allows you to, you can control each thruster, and you can do basically any type of precision maneuvers. You know, you use 2 thrusters or 1 thruster or all 3, you can induce an acceleration on the spacecraft at variable rates. So think about it like if you're a Kerbal player, think about it like when you hit caps lock. In real life, they group thrusters together to get fine control with the RCS. That's why some of these thrusters are different sizes. Now, with that being said, these other thrusters here are used particularly for different purposes. These guys right here, 1, 2, 3, 4, 5. The 5 bigger engines, or well, 6. See that? The 6 bigger thrusters here are OMAC thrusters, orbital maneuvering and control. Now, what are OMAC thrusters used for? They're used for changing, that's like a course adjustment, changing your orbit. Or changing your attitude, for instance, here, the attitude of the spacecraft. It's course adjustment of yaw, pitch, roll, translate, forward, back, left, right, up, and down. Those are supplemented by these smaller vernier thrusters here. These ones are your fine control systems, okay? So 1, 2, 3, 4, 5, 6, 7. These are used to control 3-axis of movement with what's called low impulse, or low thrust. Those are definitely the vernier thrusters from the shuttle. They look exactly the same. The nozzle diameter is exactly the same. The shuttle had a lot of redundant thruster systems in because moving that lumbering beast around in space is kind of a pain, right? To do the maneuvers that you need to do. But when you get near the ISS, you don't want to be firing these big thrusters because the thrusters could outgas to the space station and, well, turn the solar panels into sails. For one, that's why the solar panels on the ISS are way out here, because when the shuttle would go to dock to it, they were worried about the thrusters shooting at the solar panels and causing a bending force on the truss segment. Yeah, true story. That's why spacecraft dock in the middle of the ISS and the solar panels are way out on the sides. That's entirely by design. Now, okay, we have a helium actuated system. You have different thrusters for different things. So what's malfunctioning? Where's your leak? Well, we talked about the valves, okay? The valves here. So each one of these motors, doesn't matter if it's a big one or a small one, has 3 things going to it. You have hydrazine, nitrogen tetroxide, your fuel and your oxidizer, and then you have helium. Helium to actuate both of those valves. There is 3 lines that go into every thruster. That's why this looks so freaking complicated. And then your electrical control systems, your thruster block control systems. On top of that, you need electrical to send the signal to actuate the helium valves, right? It's complicated. Believe it or not, this is one of the simplest ways to do it, guys. That right there. Look at, just pause take your rocket science cap off for a second and look at that. That's simple. That is simple spacecraft design. I guarantee you peel the skin off Dragon, it looks like that. This is not Boeing. That's simple right there, believe it or not. Crazy, right? That's a lot of tubes. The internet, it's a series of tubes. So, once again, where's our leak? The leak is on one of the OMAC thrusters, so one of these bigger thrusters here. I mean, dude, that cable management and hardline management is ace. It's sexy. I'm not gonna lie to you. That's pretty sweet. Bold of you to think I have a rocket design hat. All right, Element. Let's see. Okay, I'll speak moron to you. That's easy. You wanted me to insult you. I'm gonna insult you. Okay. Put your exhaust work in perspective. Ugh. We don't talk about that. Anyway, so one of the OMAC thrusters has a leak at the helium valve flange to the thruster. So the helium line that goes to actuate the valves, the flange there is leaking. What is a flange? Aside from a very fun word to say. Flanges are used to butt certain systems up, like in plumbing, they're used to butt certain systems together. You've seen flanges before. If you have any mechanical inkling at all, or if you've ever went into your house or basement and looked at your water heater, most likely you've seen a flange. They're very, very straightforward things. The flanges like this is a flange on a pneumatic valve. It's these rings right here that are on the end of the pipe. That allows you to bolt the pipe together and squeeze the two flanges together to make sure that nothing leaks out. Now, flanges sometimes have a channel. See this kind of ring right here? They have a channel that will have an O-ring in it. It's just a little piece of rubber that when the two flanges are bolted together, it squeezes the rubber just right to be able to create a seal so nothing leaks out. Remember this part. This part is pertinent. So one of the thrusters, one of the OMAC thrusters on Starliner has a problem. It's leaking. I got to find this picture. It's one of the orbital maneuvering and control thrusters. Now, Steve Stitch and Mark Nappy. Steve Stitch is the head of NASA's Commercial Crew Program, and Mark Nappy is the head of the Starliner program for Boeing. If we're gonna, his technical job title is the vice president of project management for Starliner. He runs the Starliner program. Okay, they both said that the concern is on an OMAC thruster that has to do with deorbit. Okay, so it's probably these ones, the ones that are designed for deorbiting. There's forward thrusters and backward thrusters. Starliner could do its deorbit burn backwards, so it could be those thrusters, but whatever thrusters they're using for deorbit, it's one of these big boys here. Now, here's the thing. They discovered the leak when they scrubbed Starliner and were safing the system. They discovered a leak. Why? Well, once again, there's individual control systems for each doghouse. Okay? So, long story short, you see that manifold right there? There's lines, there's individual thruster block control. So, you can switch this thruster off or switch that thruster off or switch these on and switch these. You could basically shut them off. Basically. Now, it seems like there's some logic with Starliner that makes it so the computers really don't want to shut individual thrusters off, but you could. I think the systems, in terms of like logic for on-orbit operations, this could be a software thing, it could be a hardware thing, I'm not 100% sure, but they can safe the entire system and depressurize the helium that's used for the bladder tanks, and the helium that's also used for thruster actuation. You can basically depressurize it and send it all back into the ullage tank with a set of valves, a different set of valves. There's valves and flanges. There's millions of them on every spacecraft, and O-rings too. They're all over the place. If you're not too familiar with space flight, I'm sure you've heard about O-rings in the application of space flight. It's probably not for a good reason. Yeah. So, sure, Forge, I'll get into that later. Why not nitrogen versus helium? Good question. What's the mass of a nitrogen atom? What's the mass of a helium atom? Less mass, dude. Helium is inert, non-reactive, right? And it's really good at picking up heat, but thermal conductivity of helium is not really applicative here, right? Helium is lighter. Lighter. It's all about mass. Weight has nothing to do with it, Marty! That's the flip side of dealing with helium. Helium is a lot less mass, but it's also very, very small. So it's very easy for helium systems to leak. You guys just don't hear about it. We don't hear about it at all. Dragon had helium leaks. Shuttle had helium leaks. Starliner has helium leaks. In fact, I'm surprised there isn't more.
Discovery,
to be honest with you.
throttle up.
Hey, SVO, 15-month resub. Thank you. Now, so they can basically shut the systems down and safe the doghouses, but they don't want to do that during ascent. The reason why they don't want to do that during ascent is because you're going to need the RCS to be able to orient the capsule correctly in case of an abort. You do not want your RCS shut off when a capsule is launching. That's a really bad idea. And that's how they found this leak. The systems on the service module, the reaction control systems, orbital maneuvering and control thrusters, rendezvous thrusters, everything was turned on. You're going to need all that to get away from the rocket in case something goes wrong. They're called abort contingencies in spaceflight ascent, right? We're going deep with, this is a deep dive into Starliner systems, all right? Yes, you need to learn all this, and this all needs to be understood to be able to understand why they're cool with launching this thing, okay? So, they want the thrusters on during ascent. In case something goes wrong, Starliner can eject. Now, keep in mind, these thrusters are not the thrusters that are used to get the thing physically away. These thrusters are used for attitude control, because a capsule with a conic front and a straight back is aerodynamically unstable if your center of mass isn't right at the front. Think if anybody's ever played badminton. If anyone's ever played badminton, a conic design is actually okay. It's not the worst, but all your mass needs to be up at the front. Your center of gravity needs to be over here for this to be stable. Starliner is the same shape, except, well, this up here, there's a couple of meat bags and a lot of air. And down here is a bunch of fueling systems. Fuel, helium, all those pipes, all that stuff down there, long story short, unstable. Aerodynamically unstable. Even if the center of mass is right on the heat shield, that's still enough to where you could have translational forces during a launch escape. You definitely don't want that. That would be very bad. You don't want the capsule to be aerodynamically unstable. What if it curves right around and hits the rocket that it was trying to escape, right? Makes sense. So, the thrusters are needed to keep Starliner on an even keel during separation. So the thrusters, OMAC, translation rotation thrusters, all of them are online during ascent. Now, they're also online for when Starliner needs to do the insertion burn to get to the ISS. You need to use these thrusters here, the OMAC thrusters, to be able to do the rendezvous burn with the ISS. And then these little boys, the little guy thrusters, are used for actually the docking components. You don't use the big thrusters near the ISS. NASA's, like I said it a little bit earlier, NASA's very anal about that. You don't need to outgas and turn the solar panels on the ISS into gigantic sails. Yeah, that's really bad for the gyros on the ISS and for stabilization on the truss system. Yeah, you could turn the solar panels into sails if you shoot the thruster at it. That, like I said, that's why the solar panels are way away from where the spacecraft docks on ISS. So, now, keep in mind that this whole system is going to be armed. Like I said, they probably could individually control this stuff, but there's probably a software limitation to be able to do that. Remember that part, okay? So this system is going to be armed, and it's going to be leaking, albeit at a very small rate, a minuscule rate here, for basically the first 24 hours of the mission. Basically, from the time they arm the system at T-minus 2 hours to lift off through ascent for on-orbit maneuvering and control, and then dock to the ISS. The system will be leaking. Once they dock to the ISS, they can shut it off. They can safe the entire system. You don't need thrusters going off inadvertently. You don't need thrusters going off inadvertently while a spacecraft is attached to the ISS. Roscosmos tried that once. It didn't work. This here, I'll show you. It's a little sketch. It's a little sketch.
Why does Wi-Fi only seem to work in this room?
You need Verizon home internet.
When the Russians moved a capsule up to the ISS,
good afternoon from Mission Control in
Nauka,
Houston
their
and the
science
International
module,
Space.
Yeah, something malfunctioned with the system, and it caused the
Why does Wi-Fi only seem to work in this room?
ISS
You need
to
Verizon home
deviate
internet.
off course a little bit. We'll say that. It overpowered the gyros, and yeah. Here.
Copy.
Here's a shot from outside the ISS. This would be on the Columbus module. You can see it's nighttime down there. Everything's all fine and dandy. Yeah, it's nighttime. You know, you're looking. You know, you can see the lights at night. Pretty easy to spot. These are all cities. I'm not sure exactly where it is, but here, let me. Uh-oh.
ML.
Just for some reference here, the ISS is always designed for the nadir, or the bottom of the space station, to be relative to the horizon. So the ISS flies around like this. So if you see it do this, that means something's gone very wrong. This is precisely why you don't want this to happen. Yep, that's doing a flip in space. That's not good
we
for
could
it.
feel it.
Yeah. So
Right now.
once again, Starliner's entire
right
system
now.
is safe when it gets to the ISS. All this is shut down and the helium will no longer leak. The real problems affected here from this leak are when Starliner detaches from the space station. Not because they might not have enough helium, but because if the thruster doesn't work, because the valves can't actuate, because there's a leak, the computer and physics is not going to allow you to deorbit with that engine configuration that they've planned with. So NASA has been, this is the reason right there. That's the reason why Starliner has been delayed, because they're trying to figure out, just in the very, very unlikely case that they lose pressure on one of these OMAC thrusters, they lose valve actuation on one of these OMAC thrusters, they can make a combination of, they can come up with contingencies for combinations of thrusters that could be used for Starliner to do its deorbit burns successfully. That's what's delayed this. Them figuring out, okay, in the very unlikely chance that this thing goes completely belly up, we can still get our astronauts home. So, with all that being said, this is a case study in what's called risk management. Now, you got to remember, this is a test flight, okay? It's a test flight. Ideally, with test flights, you want to get everything working 100% all the time. It has to be working perfect. With a test flight, you want to get a good baseline. You got to understand how Boeing is doing testing. It's very different than how SpaceX does testing, for instance. SpaceX, first of all, fails very overtly, a lot, but that's okay. They learn from this. You learn from the scientific experiment, okay? That's SpaceX's testing. The way that Boeing tests and ULA is kind of more old school. It's what's called all-up testing. You build the entire spacecraft out, test as much as you can on the ground, put the whole thing together, put it on the pad, launch it into space, and this type of testing is not more about learning something from your test flight. Consider it like a final in school, or a big exam, or a big test in school. You're not supposed to learn anything during those final exams. If you do, you probably didn't study good enough, right? So this type of testing is the type of testing that Boeing does. You really don't want to learn anything new. You want to get a good baseline, demonstrate that you have a fundamental understanding about what you made. That's what Mike Fink was talking about in that presser. Understanding the spacecraft and understanding what it does. And part of that is understanding that, problems can go wrong. Stuff can go wrong. Look, if that looks like linguine, yeah, of course, it's complicated. Look at all this crap. Look at all this stuff. But you need every single piece of it. Like I said, that right there is the simplest way to make spacecraft thrusters. It does not get simpler than this. That right there is as simple as you can get. Yeah, I know. Remember how I said hyper-pressure fed hypergol systems? Simplest way to make a thruster. That's what that is. So here's the thing, right? Here's the thing. They're going to fly with the helium thruster leaking. They know it's going to leak, but that's a good understanding of what the spacecraft is doing. Now, the margins are there. There's plenty of extra helium on board because helium controls your thruster actuation and your valves. You should probably put it into fault redundancy, 2 helium tanks, 2 manifolds, right? And you should probably carry a little more than you need, or else your spacecraft isn't going to get home. That's pretty good design. That's pretty well thought out, if you ask me. I mean, people hate Starliner. I get it. And people like to shitpost about it. I understand. I'll time myself out later. So, understanding your spacecraft is so ridiculously important. Even understanding that it might have flaws. When you take a final exam, unless you're Superman, you're probably gonna not get something exactly right, but you're gonna get good enough to pass, right? This leak is like getting an A instead of an A+. So like if you're, let's talk tests in percentages. This leak is a 99.8 or 99.9 instead of 100. Pretty straightforward stuff. The risk is acceptable. Now, going back to what I said a little bit earlier, ideally on a test flight, you want it to be as good as it possibly can. Okay. Here's an example of risk management and how it works. You want your test flight to be perfect. It needs to be as good as it possibly can. Every single system on Starliner, except for that one flange on that one valve on one thruster, which has 13 of them, and you have four clusters of 13. Okay. Every single valve is working exactly right, except for that one that has a minor leak. Believe me, it's NASA. They know. I think they could speak pretty dang well to, it's fine, send it. That and why that hasn't worked in the past. I know people are going to say like, oh, they're going to launch with a leak. That's so stupid. Why don't you fix the leak? That's dumb. Why would you do that? Well, here's the thing. This is a minor enough thing that they could fix it on orbit. NASA's confident enough that if they had launched it, they would have run into the same fault tree analysis and fixed it up there. Just use a different combination of thrusters. Easy peasy. Not a big deal. Now, so what are we dealing with here? So, okay, why don't they fix the leak? This is the question I know I'm going to get asked this a bajillion times today. So why don't they fix the leak? All right, here's the big thing about risk management. You understand. NASA understands what that leak is, what it's doing. It's repeatable. Think about it like a scientific experiment. It's repeatable. It does the same exact thing every time. Now, wherever Boeing and NASA's balance between what you want it to do and what it's actually doing, the difference between those, that's your risk management there. Whatever margin that is, I don't know off the top of my head, but it's clearly enough for NASA and Boeing. It's clearly low enough of a risk to be able to, for NASA to think to, just launch it with the leak. We can, it's not a big deal. Now, the other, launch it, deal with the leak, maybe learn one or two new things about your spacecraft. Hopefully the rest of the flight test, 99.9% right, and go. The other thing is you're always going to have problems with spacecraft every single time. I'll get more into that later. You can't take into account everything. It's way too complicated. Like I said, ideally you don't want to learn anything new during a flight test, but sometimes you do. It happens. I mean, Kobayashi Maru, you could do everything right and something will still go wrong. But whatever. Star Trek. So, what's the flip side of that? Replace that? Okay. All right. Remember, this test flight, not just the ascent going up to the ISS, coming back down, bringing the capsule back to the C-3PF after recovery, obviously getting Butch and Sonny out of there and having them go back to Johnson Space Center in one piece. Not just that, it's Starliner getting assembled, getting put together, getting fueled, getting moved to the pad, stacked on the rocket, and then obviously, after that, obviously launching. It's not just the ascent, going up to the ISS and coming down. It's the entire picture. This crew flight test campaign has been going on for years. Years. Remember, the whole purpose of this is to get as close of a baseline to a perfectly ideal space flight, not just from launch, but from the time when the capsule is built, put together, assembled, move to the fueling, move to the pad and go. It's the entire process. That's what we're already into the campaign right now. Now, put yourself in NASA's shoes, okay? Put yourself in their shoes right now. Your job is to make sure that this mission goes as close to 100% right as humanly possible. So, you have two options. a leak that you very well understand, and you know what it's going to do, you understand the spacecraft, even though it's not exactly what you want, you know it and you understand it, it's repeatable, you know what it's going to do, you have the margins to overcome the leak is extremely small, right? And helium being vented into the dog box is not that big of a deal. Helium is inert, non-reactive. It's not going to do anything in there. It'll just leak out the dog box. I keep calling it a dog box. A dog box is a slang term for a type of transmission. Doghouse is what it's called. And once again, if just in case anybody came in late, the doghouses are the thruster blocks that are on Starliner. These things. Number 12, 14, 13, and, well, it's not labeled in this picture. These things. They're the thrusters for on-orbit maneuvering in rendezvous to the ISS, etc., etc. So you have that option. Launch it with a well-understood leak that you can emulate, or go backwards in your processing flow. Safe the capsule. Take it off the rocket. Put it back into fueling. Defuel it. Defuel it. Safe the capsule. Bring it back to the C-3PF, their processing facility, which is an ex-shuttle hangar. Take the entire freaking thing apart and put it all back together. And start your processing flow over. Which one of those is closer to emulating 100% operable spaceflight? Like an ideal spaceflight condition. This one is. It's option A. For the ideal Starliner mission, it never calls for taking the stupid thing off the rocket, defueling it, and bringing it back to the processing hangar, putting it out on the rocket, bringing it back, putting it out again, bringing it back. That's not the closest thing to ideal. Believe it or not, the well-understood leak is less of a risk than taking the whole damn thing apart again. You run the risk of more leaks. Now, why? Why do you run the risk of more leaks? You don't know what caused that. They still haven't figured out what caused that valve to not work. What caused that valve to leak or the valve flange to leak relative to the other valves. Starliner has, there's 13 thrusters on 4 thruster blocks. All right, that's 26, 52 thrusters. If we're just counting orbital maneuvering and control systems, there's 28 of them. 1 out of 28, where 1 out of 28 went wrong. They're all the same. Why did that one fail and not any of the others? That behavior needs to be more well understood. That's going to take time. As long as, but are you going to stop the entire program for a leaky helium thruster that you know you have the margin for? I don't know. Yeah, I mean, NASA clearly doesn't think it's a big deal. And once again, NASA's pretty good at, they had a pretty good lesson in risk management about 40 years ago, give or take. Pretty good lesson in risk management and know when to say send it and live with acceptable risk and when not to. January 28th, 1986. They got a pretty good lesson in it. So I would, if NASA's saying that it's fine, right? Because once again, you're trying to mimic an ideal test flight. This one little leak, one out of 28 or 27? No, 28. There's 28 total. So 1 in 27 went wrong, even though all the valves are the same. That tells me that somebody over-torqued this and pinched the flange, or tightened a fitting down too hard and crushed the O-ring. That happens. But you're not going to know that until you go back and look through all the documentation. Any nut and bolt, electrical line that gets plugged in, electrical wire that gets sheathed on the spacecraft, every single piece of assembly is documented. Every single piece. You tighten a bolt, take a picture, okay? You torque it down, take another picture. You connect a wire, take a picture. Everything is documented for this exact purpose, but it's gonna take a little bit of time to go digging through the archives. Are you gonna delay an entire flight campaign just to figure out that somebody didn't tighten a bolt? No, you can do that after they fly because the risk is acceptable. It's fine. And don't get me wrong, Boeing absolutely will be trying to figure that out probably for the next couple of months. Yes, it takes that long. You have to be absolutely sure. Because once again, saying it'll be all right, I'm pretty sure, is not gonna, that doesn't fly very well. actually fly very well. That's, see what I mean? Yeah. All right. I've been hanging around with Sawyer too much. So basically the risk is acceptable. It's acceptable risk. It's not ideal, but this is 99.99 out of 100 ideal. It's pretty damn close. There's acceptable risk tolerance here. Because once again, the alternative is taking the whole thing apart again and run the risk of damaging more helium lines. Because you don't know what caused it. You got to figure that out. That's going to take time. So if all the other thrusters are working fine, and every other system on that capsule is working fine, and one tiny little helium thruster on one of your 27-fold redundant thrusters is malfunctioning with a leak rate that is 100 times less than what your margins allow for, it's not a big deal. And that's the short answer to this. The leak's not a big deal. It's not a big deal. It's really not. They would not be so confident about flight if it was a big deal. Now, I know what people are going to say. You see me? I see you. What's up, man? Now, with all that being said, yeah, there's always a probability of a failure. But here's the thing. Sitting there and focusing on that and saying, it could be a problem here, it could be a problem, even though it empirically, with the people that designed the capsules and the astronauts that designed the capsule. I mean, Mike Fink saying he's confident in the spacecraft is all I need to hear. Considering his butt's on the line on CFT or on Starliner 1, and his two buddies, Sonny and Butch, their hides are on the line here tomorrow. If they're comfortable with it, I'm good with that. That's good enough word for me. I mean, considering it's their hide, they say it's fine, I believe them. If Mike says it's fine, it's fine. It's not a big deal. Like, Mike Fink is a colonel. He's a colonel in the Air Force. So is Sonny Williams and Barry Wilmore. Actually, I don't know if Sonny and Barry are colonels, but they're all Air Force test pilots. If the test pilot, the Jebediah Kermans of this flight, are saying it's fine, it's fine. Those are the people I believe. You know what I mean? Once again, not every time what astronauts say is gospel, but once again, you got to remember that Sonny, Butch, Mike, and Chris Ferguson, another Air Force test pilot, helped design this spacecraft. They didn't just put him in the hot seat and said, okay, figure this out. They were there for every step of the design phase. So, just like Bob and Doug had a lot to do with Dragon 2's design when DM2 launched 4 years ago, almost to the day. Same idea. I mean, it's not even about prior qualifications, Vulcan. He was there for design of this spacecraft. Which is why that question about having deviant engineering on previous spacecraft was such a Bush League question, dude. I'm like, are you freaking kidding me? Oh my God. Okay. That was a Bush League question. I'm sorry. It was. That was lame. That was a lamer question. You answer questions like that, you got guys like Sawyer waiting in the wings. And you got, no. What did they have for breakfast? Like, oh, bro, kill me now. All right, anyway, sorry. That's a little bit of a soapbox there, but you get the idea. James, tier 2, 86-month resub. Thank you. So long story short, guys, now you got a little bit of a primer on thruster block systems, hypergolic thruster systems on Starliner, how they work, and a little bit of a lesson on risk, what's called risk management. Risk, long story short, the leak is manageable. It's well within the margins of the spacecraft. In an ideal circumstance, you don't want a leak to happen, but leaks are going to happen. There's always an unknown. It's how big of the unknown are you dealing with? And are you willing to roll the dice with that big of a risk? Now, with that being said, I think this is an easy question, or an easy answer. This is a very low risk thing. You can switch to other thrusters. There's redundant systems built in to take into account the leak, and they have the margin to deal with it. You're always going to have bumps in the road with a test flight campaign. That's why it's a test flight campaign. This is acceptable risk to continue with the launch campaign, which will culminate in Starliner launching tomorrow, hopefully, at 12:25 p.m. Eastern Time. tomorrow and spend 8 days up at the ISS and come back down on the 10th. The risk is acceptable. The alternative is taking the entire spacecraft apart. You want to go digging through that? I think digging through that runs you more of a risk of breaking something else. Does that look complicated to you? If you said yes, yeah, it is. Yeah, it is. He always says long story short. Okay, I'll just say this is a longer or this is a shorter explanation, and you guys can base it off of that. How many times has a spacecraft launched with a similar leak and nobody even knew? Well, Steve Stitch, in not this press conference, but the Delta Review, the press conference from last week, said that every spacecraft runs into helium leaks at some point. Every one of them. Dragon included. Dragon, Dream Chaser, Starliner, the Space Shuttle, Apollo, they all had helium leaks. Because at the end of the day, helium's a pain in the butt to manage. You're always, dude, this stuff happens. It always happens. You're not, and that goes back to what I was talking about a little bit earlier. You're never going to be 100% certain. Anybody that says they're absolutely sure that a spacecraft won't malfunction, I don't believe them. They could say, you could say you're 99.9% sure. That's fine. Don't ever count out Murphy's Law. Ever. That's a really bad idea. Helium is like hydrogen all over again. Yep. Helium and hydrogen are cousins on the atomic, the periodic table. They're cousins. Yeah, they're both at the top on either side. They're distant cousins. I'm glad you're thorough in your explanations. Thank you. With that being said, if you guys have questions, ask me. I'm pretty confident that I can answer most of these questions with 99.9% accuracy. Hey, all right. Give us an update about NASA's Advanced Composite Solar Cell System, or ACS-3. I know nothing about it, Willie. There's your update. They both explode the same when they do explode. Helium does not explode. It's non-reactive. It's conductive, but non-reactive. It's an inert gas, noble gas, part of the noble gases sector in the periodic table of the elephants. Elephants, all right. Nice Freudian slip, EJ. Periodic table of the elements. I'm calling it periodic table of elephants from now on. It's the periodic table of elephants. Yes, yes. It's used in the application of no Fortrunnians. Why can we not flip the stages on Vulcan so that we use Centaur 5 during initial flight in Vulcan for on-orbit operations? What? I don't understand the question. The hydrocoptic Marsal veins. Yep. I thought you knew all. Last. All right, what's up? Forge had a couple of good questions. See, Kraken, I don't see your last anywhere, at least not as a highlighted. Okay, there it is. All right. Do you know Boeing or SpaceX's process for wire management? Anytime I deal with wires, it doesn't look good. It's most likely to a NASA specification. There's probably an NTRS report on cable management on NASA's technical reports server. I'll bet you there is. I'll bet you there's one on soldering too, and different types of plugs and connectors. If I had to guess, it probably stems from Air Force grade specifications for airplanes. Yeah, I'll bet you there's something out there. Now, what else? What are other questions? I'm scrolling through. Interesting thing about the leak is that the area with the leak will burn up, so there's potential that the cause of the leak will never be found. Havoc's, like I said, yeah, it's possible, but I think that and figuring out contingency procedures in case something else happens on orbit is the reason why it delayed, not actually the leak itself. They figured out the leak. They figured out the leak the day they scrubbed Starliner. But now it's not what you know, it's what you can prove, right? Let's see. I'm actually more shocked Atlas V had a problem before Starliner. The chattering valve happened on Atlas V previous times, T-Men, but there are different rules when there's people on board for launching. What's called not flight acceptance criteria. It's called launch acceptance criteria. There's different rules if there's 2 meat bags on board. Crew Dragon secured the majority of the ISS flights to the 2030s. Current contract for Starliner ends at Starliner 6. So what's to say that they won't buy more Starliner missions to Axiom Station or something? Forge, what is this next one? Do you sometimes feel that the Starliner program got too big to fail? Boeing invested a lot of their own money in the program and it ballooned to nearly $5 billion. Do you see that they have a future past the 6 contracted missions for ISS? Yes, and yes. Yes to the future contracted missions. No, I don't believe it's too big to fail. The commercial crew program has been one of the, even with Starliner's overruns, it is, I will say it's been one of the best cost managed programs in probably NASA's history. Yeah. You said the total investment, even with Boeing footing some of their own money for the entire commercial crew program, is $5 billion. $5 billion to get 2 crew-rated capsules with completely redundant dissimilar architecture. $5 billion is chump change for Uncle Sam, dude. That's nothing. I don't think it's too big to fail at all. I think it's quite the opposite of that. There's a lot of very technical standards in electronics and wiring. Yep. The questions become, where's the dollar for getting Starliner approved and developed further to mate it to other rockets? Since Atlas V time is limited. Any Starship related news? We'll get to more of that later. Completely redundant dissimilar architecture. Atlas V time is limited. Havix, there's no way somebody didn't do some type of feasibility study for mating Starliner to other launch vehicles. Long story short, that glaring of an issue is probably not something that they just said, oh crap, what happens when we don't have more Atlas V's? Duh. They probably made the mating system on Starliner and the data and avionics systems compatible with systems that were at the time when Starliner was developed up and coming. Long story short, nobody will say anything. This is very much my opinion. I honestly think that Starliner could already launch on Vulcan right now. I think they could do it right now. But the contract says launch it on an Atlas V. And they already bought all the Atlas V's for Starliner, so they're not going to do that. Safe to assume Vulcan, probably not Falcon 9. Well, Havix, okay, this is getting into some hard speculation here. This is hard speculation, okay? So take this part with a grain of salt, all right? Here, I got some. There you go. See? Take one. If I was Steve Stitch, and before him Kathy Luters, overseeing the commercial crew program, I would have commonality in my spacecraft mating systems. That's just being smart. Think about it. I would design the future-proofing system for each of these capsules to be able to launch on either launch vehicle in the event of something crazy happening. Now, Starliner and Dragon are supposed to be redundant dissimilar, but certain components can be used on either side. We've seen this with the parachutes. New Shepard, Starliner, and Dragon all use very similar parachutes from one provider. So there's not completely redundant dissimilar architecture here now, is there? Starliner on SLS. If I were running the commercial crew program, that would have been a design standard from the start. You want to now, once again, does that mean that these systems are being developed and are already made? No, you're not going to make it unless you have to. But there's no way they did not take that into account. I guarantee you, in some crazy upside down timeline, Dragon could launch on Atlas and Starliner could launch on Falcon. I guarantee you there is future-proofing systems on either capsule to be able to do that type of cross-payload manifest. I guarantee it. Yeah, I'm pretty damn sure. I mean, that's not even like, I said it's speculation on my part. I'm not, and once again, I'm not saying there's a Starliner Falcon 9 adapter sitting around in NASA's VAB somewhere. I'll bet you they designed the systems to be able to make these components if they need to. What's the harm in putting another plug in there to be able to interface Starliner to a Falcon 9 just in case? The structural part is easy to figure out. You know, making the payload attachment fitting. We've seen this. That's the easy part. Getting the avionics and everything to work, to jive together, that's the hard part. What's stopping us from thinking that there's an Atlas V plug on the bottom of Dragon somewhere on the trunk to be able to allow it to plug in to Atlas V and interface with its avionics? I guarantee you the provisions for those are there, but none of those systems have been developed because there hasn't been a need to. Starliner on Neutron. That's awesome. I can confirm that Vulcan is designed with Starliner flights in mind. The only major component that would need certification is the adapter between Centaur 5 and Starliner. Otherwise, Vulcan is flying with all needed crew-rated systems. Just needs to knock out a bunch of flights. Like Vulcan, it's probably the same thing for Vulcan. Yeah. It's probably the same. I mean, Centaur has commonality in its avionics between 3 and 5. There's no reason it wouldn't be. And Centaur, the reason why I say, talking to the second stage, talking to a Falcon 9 second stage, talking to a Centaur is because that's where the brains of the rocket usually are. Right? There's no way that they didn't design that with that provision in there. But they probably didn't develop the system. They designed it, but it needs to be certified. You don't just send it with human spaceflight, right? That's dumb. They tried that once. They've tried that actually twice. Yeah, that doesn't work. So, what about this one? All right, I already got through that. Yeah, if I were running the commercial crew program, Havocs, I would have designed commonality in all these systems. And once again, you see it with the parachutes, you see it with the docking system standards. Starliner and Dragon are designed to dock to the same port. And guess what? Orion could probably dock to that same port on the ISS-2 if needed. You'd probably have to do a manual docking, but it could be done. Also, I have photograph. Vulcan, that doesn't suck, man. Yeah, there it is. It's kind of sad that they won't stream anything from the capsule. There's cameras, but they're not connected and will only record post-flight. This will be done for future flights. Yeah. Starliner was concepted to fly on Atlas, Falcon, Delta, and the Stick. Yeah, Thomas, like I said, I guarantee that commonality is there. And I would go so far as to say if weight wasn't a problem, if the mass of the capsule wasn't a problem, I bet you a partially fueled Orion could also launch on a Falcon or an Atlas or a Vulcan. I'll bet you. Those systems haven't been developed, but the pieces to develop those systems are probably there. That's just being smart. That's just being smart with your spacecraft. You want awesome redundant dissimilar architecture? You want ultimate redundant dissimilar architecture? What if a problem happens with Atlas V, right? And not Starliner? What if a problem happens with Falcon 9 but not Dragon? I know that seems really pretty far-fetched at this point, but you get the idea. NASA didn't know that. NASA didn't know Falcon 9 would be the powerhouse that it is 10 years ago. They didn't know that, right? They had no idea. So when the program was developed, and Orion actually came around at the same time in 2014. I'll bet you they designed commonality in there all the time. That's the best redundant dissimilar architecture. Not only do you have two completely independent systems of each other, but cross-pollination of systems, if needed, you should figure that into the design. I would have done that. But then again, I ain't a rocket scientist, so who knows? Orion is not fully IDSS. It's NASA docking standards, but I'm not sure if it's full IDSS. What is this? International rocket launch on YouTube. When was this posted? August 14th, 2021. Starliner CST-100 was originally planned to be capable of orbital flight on both Falcon 9 and Delta IV Medium. No surprise there. That's just being smart. But yeah, that's what's going on with Starliner. Long story short, the leak isn't a big deal. We'll probably talk more about it on the Flame Trench, which should be happening in about 2 hours, give or take. But yeah, there's your Starliner stuff. Sorry, that took a second, fellas, but yeah, spacecraft. Sometimes you have to dive in at least at, a relatively fundamental, if not general level of spacecraft design and how risk is mitigated in spaceflight. Delta IV Medium, how old is the Starliner program? 2014. CST-100 existed a little bit of time before that, believe it or not. Boeing pitched CST-100 as a potential alternative to Constellation's Orion, which is why CST-100 most likely has some type of provision to be able to launch on Ares 1. I'll bet you that was designed out of the system, though. Flame Trench is the highlight of your Friday evenings? Hell yeah, man. That's what I'm talking about. Didn't CST-100 start at Bigelow? Not sure. Anyway. Yeah. Hopefully this flight goes off without a hitch. Yeah, see this docking port? That's a docking system standard. The plugs between Dragon and Starliner, see the power and data plugs right there? Exactly the same. And the mechanical latching system and the pilot dowels are exactly the same. Orion has the same plugs on its docking port as well. I don't know why NASA doesn't talk about this, but it does. Could Starliner and Dragon kiss each other? Yeah. Yeah. Yes, not automatically. I mean, Starliner might be able to. Starliner uses a relative navigation system for docking. Not a lot of people know this. See all that right there? The cameras? Actually, I'm not sure if those are the cameras. Starliner has an optical relative navigation system, which, believe it or not, is the opposite of Dragon. Dragon uses LiDAR to find the docking port during automatic docking operations. Starliner does not have any interfacing system with the ISS when it's kind of flying next to it. Starliner has a camera at the front, and the onboard software is designed to look for the docking port. That's Starliner's automatic docking system. I think it's called Vesta or Vespa or something. It's a relative navigation system. Starliner has a camera and the computer is using some type of primitive neural net to be like, oh, yep, there's the docking port. I'm going to line up now. The lead engineer for the optical targeting system for Starliner is the founder of Autopilot. Yeah, if that sounds familiar, exactly, Forge, that's the funny part. That's the funny part of this whole thing. Dragon uses LiDAR to find the target. But with LiDAR, you need kind of a beacon so the LiDAR can see it, right? Starliner uses an optical relative navigation, right? Which means it just has cameras and the computers are trained on images of what to look for and find it and dock to it automatically. That's what Tesla's Autopilot does. Boeing's capsule is flying with a very, 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 very stripped down version of Tesla's Autopilot for docking operations. Yeah. It's not exactly Tesla's Autopilot, but it was developed by the same guy, as you said. Weird, huh? You'd think that would be the opposite, but it's not. What's more interesting to me is how incredibly small that engineering community really is. The aerospace community is small, Hellfish. Everybody knows everybody, which is why I don't pick sides with rockets. One, I think it's stupid. I don't think the industry is big enough to have brand loyalty. And certainly the aerospace engineers that work in this industry don't think it is either. People that work at Blue cheer on SpaceX. People that work at SpaceX cheer on New Shepard. Every rocket company wants to see Starship successful. It's not even a judgment call. I've talked to people in the industry. I've talked to people that work everywhere. They all say the same thing. Yes, the cynical people are all at NASA. Ooh. Spicy. Maximum. Oof. And fun fact, some of the software engineers created the early machine learning programs were Apollo software engineers. Engineering is a small world. It's all interconnected, Raja. That's one of the main points that I illustrate, guys, on this stream, where I try to tell you. That's why I use cars I use cars a lot in analogies for explaining rockets, because what they do is not that far off from each other. I use cars, ships, trains, whatever. They're all doing similar things. They're all just a means to create mechanical work. Or aerodynamic work in the case of rockets, but you get the idea. It's almost like they're all governed by the same laws. Physics. Sure, that's why you use cars. Also, I use them for explaining a hefty car cane. Anyway. Cars as a vehicle or an avenue for explaining engineering. We've been hanging around with Sawyer too much, man. Damn, we've been hanging around with Sawyer too much. What the frick? Anyway, there's your Starliner update. Long story short, it's not a big deal. They know it's not a big deal empirically. So it's not a big deal. Like I said, if Mike Fink, the guy, a colonel in the United States Air Force, a test pilot in the United States Air Force, says it's fine, it's fine. He helped design the stupid thing. It's fine. Anyway, any other questions regarding Starliner before we move on? I have other stuff to talk about. There's that Starship feasibility article that I think would be kind of cool. I mean, he is putting his butt on the line. Yeah, Hellfish, here's what I'm saying. If Jeb Kerman says it's cool to fly, I believe him. You know what I mean? Yep, could talk for hours on that. You think it's going to fly tomorrow? Yep. We have the Sawyer transmitted disease. I'm telling him that, Fish. I'm telling him that. Here. It's getting a little toasty in here. I'm turning on the fans. If Jeb says it's good, I will wait on what Bob says. Well, Sonny, Butch, and Mike all say the same thing. And considering if they're wrong, they get hurt at the very bare minimum, I'm pretty sure it's okay. We'll talk more about Starliner, like I said, on Flame Trench. Ooh, new Dream Chaser pictures just dropped. Yeah, I hate that I used that phrase, just dropped. But anyway, there are new pictures coming out of the Neil A. Armstrong Operations and Checkout Building at Kennedy Space Center of Starliner, which is going through final spacecraft processing for launch on a ULA Vulcan rocket to the ISS for a commercial resupply mission a little later this year. What's Jeb's take on KSP-2? You know what, Geek? I know it's a joke. I don't want to talk about KSP-2. Yeah. Anyway. So not only is Dream Chaser getting ready to go, there's the Shooting Star. It's, payload attachment fitting and service module. So that thing is going to be attached to the back and allow Dream Chaser to be able to stay on orbit for long periods of time. Pretty dang cool. Pretty dang cool. And also, those attachment brackets are very nice. Those are some good bracketry. There's some good bracketry going on right there. It looks beautiful. Or it looks like a bowling shoe. I mean, whatever. Shuttle or bowling shoe. I mean, you take your pick. Take your pick. Anyway, check this out. I'm going to get through everything. I'll save Starship feasibility stuff for last. All right, so this is coming from Gav. Cornwell. He's kind of the resident NASA spaceflight guy when it comes to space navy. So like SpaceX's ships, Blue, and now Blue's ships. He's the resident tracker of those systems. So what you're looking at here is landing platform vessel number 1. Blue Origin's New Glenn landing barge is named Landing Platform Vessel 1. The vessel was captured passing through Istanbul as it was moved from its construction shipyard in Romania. The barge is currently being outfitted in France. Does that mean Dream Chaser is a hatchback? Dream Chaser is a station wagon. A rear-engine station wagon. Kind of like a Corvair or a Corvan. Nice. What would you call it? A barge? Does that count as an aircraft carrier? Kind of. Ship 29 is moving back, potentially back inside of the chopsticks. Okay, thanks, Eric. Yeah, we'll talk more about Starship in a little bit. Cool. Thanks for the update, though. I have Starbase Live up right here, dude. I have SBL on. Oh, what? Oh, yeah, here. Yeah, okay. Oh, look. A message from the government in a YouTube ad. That's great. Yep. Yeah, I have SBL going. I don't know why it refreshed like that when I moved the window down here, but that's what it does. uBlock Origin is my friend. Yeah. Spoon, you want to know what that commercial was? That was for Massachusetts Department of Health's new suicide hotline. Yeah, 988. Yeah. I'm not saying anything else. I can feel different people have different things to say about this. I don't know. I'm not weighing in on this, dude. If you need help, get help. That's all I'm saying. Yeah. I'm going to go back to talking about this landing platform. So that right there looks like it's going through Istanbul. Let's see. And not looks like, that definitely is Istanbul. There's the Hagia Sophia. Beautiful building. Are you going to be here tomorrow for the crew launch? Absolutely need. Yep, that thing is going to have a Nuglins land on it. Now, in case you're trying to understand scale here, look at the shipping containers. Look at the shipping containers on this vessel. That is not a small vessel. See the shipping containers? Look at the railings on the side of this thing. Those are 1 meter tall railings. This thing is freaking huge. That's bigger than SpaceX's. Way bigger. Probably, if I had to guess, it's probably way bigger because New Glenn is a way bigger rocket. Or way bigger first stage, at least. Look at that, dude. This freaking barge has superstructure attached to it. I don't know why I asked. Yeah. You know, I was thinking, why did they go all the way to Romania to order a barge like this? But I don't think there's anywhere in the U.S. that makes a freaking barge that big. That thing is huge. Guessing people won't be on this one, too. Blue scrapped plans of having a vessel with people on board that lands rockets. The Stena freighter that was converted to the vessel Jacqueline was sold by Blue Origin and scrapped. It was Jeff Bezos named it after his mother. I don't know why I thought that pertinent information, but yeah. Last for a little bit of info. The ship is made by Daman Shipyards Bengalia, shipped over to the Daman Shipyards in Brest. When in doubt, buy stuff from a Dutch-owned company. We know water. Where's your aircraft carrier? Got you there. I got you there. Okay, now you listen here. Where's your 12 aircraft carriers and like 30 amphibious assault rotor wing carriers? Actually, the Netherlands did have an aircraft carrier, if I'm remembering right. You scrapped it, though. Is this helping? I'm like Google search. Did you find this information helpful? Would you like to know more? Look, I'm not saying our Department of Defense is smart. Didn't your Department of Defense merge with the German Bundeswehr? Your army merged with the German army. No? No? Are you sure? Look it up. How many different ships has the U.S. sailed? Just one tank division? I'm pretty sure it was 3, Elvis. Last time I checked. Maybe they changed it since. We are, in fact, very much cooperating extremely closely. We only have one. Pretty sure the last time that happened, it didn't end well. That was a joke. That was a joke. It's a joke. It's a joke. Anyway, yeah, no, honestly, yeah, you guys understand water probably better than most. Considering you've been picking a fight with it for over 1,000 years. Yeah, good call. Good call. Sure, your middle name is short. Nice, James. Service guarantees a citizenship. And also, Hagia Sophia. I just want the wiki page, damn it. Yes. Oh, hello. Nice. Very nice. Yeah. The Hagia Sophia was built under the Byzantium Empire by Constantine, if I'm remembering right. For you people that like antiquity. Been there. It's full of cats. Yeah. Pretty impressive building, considering it's like 1,500 years old. Are those considered flying buttresses? That right there is, yeah, maybe. 1,200 years old? Yeah. The towers were added later, not by the Byzantine Empire. I wonder if Blue will have similar systems to SpaceX with their booster recovery ships like Chains or an Octograbber. Maybe. Ugh. The towers work, though. They look nice. They don't look bad. The towers were installed by the Ottoman Empire because they took the Hagia Sophia and converted it to a mosque, if I'm remembering right. I'm pretty good with antiquity, but not the best. I can tell you how full flow stage combustion cycle works, though. High five! Whoosh! 1453. I know it was 1453, Everest. The Ottoman Empire toppled the Byzantine Empire. And Constantinople remained under the Ottoman Empire until World War I. Think about that for a second. That's a long time. 29th of May, 1453, the fall of Constantinople. Yeah, can you believe that? Constantinople was called Constantinople until World War I. Yeah, believe it or not, they changed the name when the Ottoman Empire collapsed and Turkey became I think they changed the name again to Turkey, if I'm remembering right. Turkey became an independent country. That's when they changed it to Istanbul. Istanbul, Constantinople, I like to drive my Opel. I don't think that's the words. It could be, though. It could be. Just saying. But anyway, yeah. I've always said, so why am I showing you a picture of a barge in Turkey? Why am I doing that? Well, guys, here's the thing. There's this rule that I abide by when covering space news. The rule is talk is cheap. Talk is cheap. Show us what you're making. Anyone can say we're building a rocket. Anyone can say we're going to land rockets on a vehicle. Anyone can say that, you know, oh yeah, we'll launch this, you know, heavy duty lifter from this launch pad in this year. And, you know, it'll move this from the pad to location B or whatever. Anybody can say anything. Talk is cheap. Once you start seeing hardware, though, that's when you could be pretty dang sure that whatever they're saying or whatever, in this particular case, Blue is planning to do is probably going to happen. You know why? Because there's a barge right there that's the size of a small stadium with landing platform vessel on it that just happens to be painted blue and white, with Blue Origin's color scheme. I'm pretty sure that means that a New Glenn flight is somewhere on the horizon relatively close. Keep in mind, relativity for aerospace engineering and development programs is on a annual scale, not a weekly or a monthly scale, meaning that a New Glenn flight is probably going to happen within a year. I would say, I think that's a safe bet. You think they'll make September 29th? I think September 29th is a little bit on the optimistic side, Phil. I would say probability for the next 6 months. Okay, so a biannual scale here is probably, I'd say the end of the year. Maybe January. Maybe, with what I'm seeing. So first of all, you plan to recover the first stage. The barge being halfway around the world isn't going to help you in this regard. Okay? Like I said, look for the hardware and look where it is. If this thing was at the Cape right now, I would say a New Glenn mission is sooner rather than later. Right now, it's just on the horizon. We can kind of just barely see it. I'd say either late this year or Q1 2025, Roger. I would say more Q4 this year than anything, to be 100% real. I would say Q4. I'm going to say December. Yeah. Take about 6 months. Once again, look at the hardware. Tori Bruno has been posting pictures of BE-4 engines left and right for Vulcan's campaign. They're just popping up out of the woodwork, man. There's engines everywhere. There's engines for Vulcan Booster 2, Vulcan Booster 3, Vulcan Booster 5. Like, they're 4, they're everywhere. So that tells me that Blue Origin is ramped up production on BE-4s. So there's not going to be 1 or 2 BE-4s by the end of the year. There's going to be like 20. At the rate at which they're, you know, people are showing us hardware, I think it's safe to say that that factory in Huntsville is ramping up big time. There's a lot of engines that need to be made. And keep in mind, and this is the most important part here, there's a lot of engines that need to be paid for missions with paying customers. That's important. Blue Origin isn't just ramping up BE-4 production because they're anticipating a market. These missions are already locked in. For now, you know, with New Glenn, it's for the NASA's Escapade mission. So NASA is a paying customer, inadvertently, for producing BE-4s. Amazon is the biggest customer. 38 Vulcan launches. That's 66 engines alone. We're talking about a production ramp that's gigantic here. So, once again, I wouldn't be surprised if just one day you see a fully completed New Glenn booster in the next 4 months just pop out of their integration and assembly facility down the Cape and just find its way to the pad. Wouldn't be surprised. Big time, big time, big time. This is our evaluation. Big time. Yep. Does Blue have a big crane ready for lifting the booster off of the barge? Actually, yes, Make. It's been sitting down the Cape for a year now. Yeah, probably about a year. Here, I'll show you where the crane is. No, the crane's down here. So it's actually right next to SpaceX's crane, believe it or not. Let's see if we can get an updated picture. Yeah, it's not there in this picture. This picture's from April of last year. There's the crane for recovering Falcon 9 right there. Blue's crane is right here. Yep. Actually, give me one moment. Yeah, they don't have a picture of it on Space Coast Live. But, yeah, it's there. If you look at Space Coast Live and they have a view of Port Canaveral, it's there. Yeah, but it's there. Anyway. So, yeah, like I said, I would say New Glenn probably by the end of the year. That's even taking into account things going wrong. I think if everything goes right and they have the processing flow for New Glenn launch figured out, I would say probably September or October. That's like way optimistic, though. That's like everything going right. But the one thing you got to take into account with spaceflight is that never happens. Yeah, like I said, 99.9% sure, not 100. There's always Murphy's Law. Always take that into account. I looked right there when you started talking about the cranes. Nice. So, yeah, with that being said, completely optimistic, it's probably September. I would say add a touch of, reality on top of that, probably the end of the year. Flame Trench later today. Oh, you know it, dude. About 45 minutes, I'm going to start tooling up for Flame Trench, man. Absolutely. I have stuff to say about Starliner. Actually, it's not anything that I didn't say last week, Nadodo, but also the toilets on the ISS aren't working. That's good. So the astronauts have been peeing in a bag. So there's that. What book are you going to select for your opener? I got a goodie. Here we go. I actually got most of my books out of boxes yesterday because I was looking for parts. Here. How's this one? Fundamentals of Aerodynamics by John Anderson. Mr. Anderson, I'm going to enjoy watching you die. Anderson. Yep. Thomas, thank you for the picture. This is from Jerry Pike, who I should probably give a follow. Yeah, that's the crane right there. It is a big one. It's a big one. It's a big. Look at the telehandler. It's freaking huge. Oh, yeah. There's also this thing. Yeah, that's from Max Evans over at NSF. There's that. Yeah, how many tons is that thing? Like I always say, Jim, you want to know how heavy a crane can get? Look at how many wheels it has. And if it doesn't have wheels and has tracks, very heavy. Yeah, that is a chunky freaking crane. Also, there's this piece of processing equipment to, as Thomas said, be able to take the actually, I don't know if I want to use this book on a side note because it has a Prime Student sticker on it because it was a rented book. I bought it used. That was the only way I could get it for a good price. Probably use a different one. Anyway, yeah, so this thing is used for taking the booster horizontal, or it's a cage match because Blue Origin is secretly planning to have the Thunderdome here, where Bonesaw is ready or something. It's a lever crane. Yes, it do be like that. It definitely is. It looks like they took SPMT components and attached a lattice crane to whatever that is. I don't know what type of crane that is. It's a lattice crane for sure, but I've never seen this kind of house on a crane like that. I don't know what that is. Whatever it is, it's beefy. Can we get beyond the Thunderdome? Yeah, it's that parking spot over there, dude. Imperator levers they're also made in Ireland. You have a factory in your home county of Kerry. That's cool. Thunderdome, Running Man. Hey, take your pick, man. Take your pick, dude. If you want Running Man, I would say Running Man's good, but Commando. Hey, do you remember when I said I'd kill you last? I lied. Running Man is good too, though. Yeah. Let off some steam, Bennett. Yeah, so once again, Blue Origin is either planning on having cage matches or it's used to move a gigantic first stage horizontally. Take your pick. Take your pick. Twins was peak Arnie. Terminator 2. Terminator 2, dude. It doesn't get better than that. Come with me if you want to live. Does Liebherr roughly translate to Mr. Love? I don't know. True Lies. Good call. Good call. Dana! Dana! Give me the key. Give me the key. Give me the key, child. Give me the key. No way, you psycho! Give me the key, the case. Give me the case. It translates roughly to nice, friendly sir. Give me the key. Yes. Dear man, leave her. You were close. Nice. Give me the case, child. Give me the case. That freaking movie, dude, it's so stupid. I love it. The freaking Harrier. Oh, shoot. All right, so that's what's going on in Blues World. Pretty good updates here. I don't know if we have, I was about to say if we have any clues. You're right, I've been hanging around with Sawyer too much. Are you kidding? Eraser? Eraser where he kills the alligator and says, your luggage. Yeah, that's pretty good. That's pretty good. That's pretty good. That's a tool and repair parts container. Oh, the thing that's up on the top of the crane, Everest? Yeah. Cool. So you guys remember when I said I would save Starship for last in the space news? I didn't lie. That's what we're going to do. And you're going to learn about VAST space station prototype now. Here, enjoy. So this is coming from VAST. VAST is a company that's working on making spaceflight habitation modules, hopefully pining for some of NASA's commercial low Earth orbit destinations contracts in the future. This is their Pathfinder, Haven 1 Pathfinder. We did see some pictures of this last week, but we got a promo video now. How much you want to bet it has some like obnoxious corpo music over it? That's not a slight at VAST. It's just yeah. All right, let's see. Ready? It doesn't. It doesn't. Very nice. There was some machining pornography in this. Oh, there it is. Nah, this is pretty good synthwave. I'm cool with this. No, all right, cool. No front of the mill corporate promo music. That was actually pretty rad. Thank you, Vast. Very cool. All right, so let's see what we got. This is all at all different phases here from what I can tell, but they did show some machining. Oh, yeah. That's the docking port door right there, or the hatch. And that is, what do we got? A 5-axis mill from what I can tell. Link to the video? Sure, man. Yeah, almost. Yeah, you ain't wrong, dude. That is a 5-axis mill. You can tell because of the way that flange, that flange is. See, it's at a 45. That allows it to turn. You can turn the mill, so it's not just working in. It's not just working in translate, rotate, or translate. So forward, back, left, right, up, and down. You can actually rotate, and you can mill on different axes, on 5-axis. Just one time, I want to see one of these with Cletus's time lapse music. Oh yeah, that's kick butt. So what we're seeing right here, oh, that's milled aluminum. These milled aluminum inserts, like lower areas, are called an ortho grid. Basically, this works like a rib cage for the spacecraft. Same idea. You're building structure. You build structure into the design here by having these ridges here. In traditional like rocketry, they're called stringers. This is an integrated stringer milled directly into the skin of the inside and potentially outside. It depends on the component of the rocket and or spacecraft. This is a really nice way of saving a lot of mass by combining the structure and the skin of the rocket into one thing. Think of it like an exoskeleton for a spacecraft. So right there is an English wheel, a gigantic freaking English wheel. So they would mill the ortho grids into flat sheets of aluminum and put it through this English wheel, and that makes it curvy. Yep, that is a gigantic freaking English wheel, but it's an English, like that's a diesel freaking one. Yeah. The building I'm in, we operate Machino D2s. They're 7-axis. I'm a little bit jelly. Hey, you want to give me one of those? So right here is a welding jig. This is a jig for welding together those panels that we just saw. Now, something particularly interesting here that I saw from Vast. Traditionally, like let's take the ULA's Vulcan rocket. Vulcan is built very similar to this. So is SLS and New Glenn. It's built very similar. They have milled ortho grids on the inside of the rocket and a smooth outside of the rocket. Once again, this is like an exoskeleton. They've milled the structure directly into the outer part of the rocket. Makes it super strong. But I've noticed that Vast is TIG welding it. That's a TIG welder. It made the TIG welding noise. Now, SLS, New Glenn, Vulcan, Falcon, they're all stir welded together. They use a different type of welding fixture to be able to weld these panels together. It looks like Vast is using a TIG welding jig here from what I can tell. Yeah, see? Wire feed. So what's TIG welding? TIG welding, tungsten inert gas is what it's called, is a method of welding that is used when mitigating heat transfer during the weld is needed. So you see TIG welding a lot with aluminum or aluminium. Aluminum. You see TIG welding a lot with welding aluminum parts together on rockets, cars, whatever. Tesla, if you have a Model S, it has an aluminum frame that's TIG welded together. Just some reference there. The reason why it's aluminum, we have aluminum pieces here. Why do they use aluminum? It's light. It's light, but aluminum has very, very, very high thermal conductivity. It's very easy for it to melt. It absorbs heat really, really quickly, and it melts really, really quickly. It's very easy for aluminum to hit critical mass and melt. Yeah, very easy. Yep. Aluminum. I just call it aluminum because I just like pissing everybody off. This is not friction stir welding. That is just straight TIG welding. Oh, that's killer. Yep. Great penetration on that weld. The welder is on the opposite side here in this picture. So that first jig that we saw right there, this one is designed to, it's making what's called in spaceflight a barrel segment. That's what this is.
Go and throttle up.
It's just one ring of this thing. One ring of this stuff. That's a barrel. These barrel segments are then welded together on a different jig. It looks like they weld the barrel segments vertically, and then they weld the barrel segments together vertically and join the barrel segments together with a, horizontally, this is a horizontal welder. Just call it alumina. Alumini. What's up, Shinar? Did I get it right? I don't think I did. That's what that says, right? Aluminia. No, the N with the squiggly over it is a different thing. Different pronunciation. Aluminia? My mouth can't make that sound, dude. Are you aware of this game? The game is just called Rocket Science. No, I haven't. I don't know, man. Maybe I've seen this before. Interesting. Almost correct. Aluminium. I was close, man. Anyway, the barrel segments are getting horizontally welded together here. Oh, yeah. So, how a tungsten welder works, right, is, well, you have your welding cup. This is called a cup right here. And inside of the cup, there is a tungsten rod, a rod made out of tungsten metal, which is very, very hard metal. The reason why they're using tungsten is because it's really hard metal and it's really resistant to heat. Tungsten melts at a very high temperature as opposed to aluminum. Now, what that tungsten rod does is make a welding arc. It basically, like if you've ever seen like a Tesla coil work, it shoots lightning bolts. You create an arc between the tungsten rod and whatever you're trying to connect, whatever your ground is attached to. What you do with a TIG welder is you take the rod here, that's your feed rod, and you move the rod through the arc and it makes a pool. The arc melts that rod instantly, and it makes a pool of pretty hot metal. Well, not too hot, right? Because it's TIG welding. A pool of hot metal right there that binds the thing together. The rod is also mildly radioactive. There you go. And watch. You want to get overlap on your weld here so you can see their mechanical fixture actually moving up and moving up and moving up here. This is actually super cool. Here, back it up a little bit. Now, another thing to note, actually, you can't really see it there. The surfaces, see how they're getting penetration? So like that one picture, just back a second right here, these two dudes looking at it. See how the weld is shining through to the other side? That's because this jig right here is designed to hold the segments not touching each other, but just close enough. Like we're talking like maybe a millimeter. There's like a millimeter gap. That jig is designed to hold that whole thing true to a millimeter gap all the way around. The reason why is because when you feed that rod into the arc, you want it to melt, and you want it to melt through. You want the weld to be holding the two panels together, not just on top of them. So I learned this when we were making the exhaust, and I kind of already knew it, but I saw it actually happening when we welded the exhaust on the truck the other day. Butting the panels up together like this is just going to weld one side. You don't want that because this thing is going to be under pressure because it's a space station module. So you have outward pressure pushing in the weld on the backside, that could break the weld apart. You want the weld to be joining all of each panel together. So there's a little gap right there. That's what I mean about penetration with a weld. Hey, Blood Fam, you doing Friday night racing tonight? Yes. Yes, I am. TIG welding is also very similar to brazing. Yeah, exactly, Mutter. Yeah, if I had to guess, I'd guess TIG welding is derived from metal brazing because of the low temperature application. Low temperature with brazing being using lead, which also has a very low melting point. See it go back and forth, dude? Oh, yeah. That is sweet. That weld is perfect. Oh, dude, I wish I could weld that good. Damn, that's really nice. That's dude. Can I watch that again, please? Can I watch that one more time? I know that was a robot. They have the jig. The fixture is doing it to make sure that the weld is perfect. But damn, that's still nice, man. Oh man. Now, Raymond, you say, now that they have the design structure and process down, hope we see them actually start building the flight equivalent of hardware at a good pace. Yeah, starts with the Pathfinder, dude. Be right back. Gotta get a bottle. Tonight is a special night. Oh, no. Yep, see? Interesting. There's a gap in the flange right there. That's probably because they'll end up using that flange. There it is again, welding these two pieces together. Note that, see that they have a spacer? See the spacer and those tabs that they welded to the barrel segment for the conic segment? That right there is a fixture to make sure that when they go to weld these two together, that they're not completely butted up against each other, but there's a little bit of a gap. Not quite Binky levels of engineering, but close. Oh, we're friends now. Friends now. You mentioned Bad Obsession. Bad Obsession Motorsport. We're friends now. Yep. That is like one of the most legit car builds on YouTube that I've ever seen. Those guys, Nick and Rich could build a spaceship. I'm pretty damn sure. Based off of what we saw from that project, dude. They could do that. They could build that. Sure, why not? Yeah, Keek, they could make that. Sure. Probably take like 5 years, but they could do it. Yeah, see, this is FOD contamination cleaning. It's a pressure washer with a soap attachment. Yeah. And then that's an HVLP spray gun. That's just a paint gun. I wonder what brand it is. Pneumatic. High volume, low pressure. You want to get the paint to deliver a high volume at low pressure and get the paint to spread out. There's basically a pintle inside of the paint gun right there that shoots the spray out, not in a cone, but kind of like a straight spray that's kind of cone shaped if you looked at it from the side. If you looked at it from the front, it'd be flat. You rewatch Binky every few years? Mm-hmm. Just need Vince from DeBoss? Yeah, baby. Trades are cool, man. Trades build cool things. That's why I wanted to learn welding, because it's cool. You can make stuff. Making stuff is cool. Okay? Obligatory mention of the Reliant Robin space shuttle anytime we talk about the British aerospace industry. Yep. Sweet. She's doing touch-up paint. I don't know why you would paint this. I think that's just to make it kind of look cool. Usually you don't paint stuff. Paint is too heavy. Look at those TIG welds. The pool is different right there. See that? That weld is pretty damn uniform. I'm not one to talk. I could not do better. I would have melted it a long time ago. Pretty cool, man. Pretty cool. Props, or credit to Vast for showing this stuff off, for showing their process. That's actually super cool. It's super cool to learn and understand where their mind's at. Obviously, with TIG welding, they're going for a lower cost solution here, but that just because you TIG welded it doesn't mean that it's not going to work. It's just the TIG weld is a lot heavier compared to a friction stir weld. When you friction stir weld something together, you don't need a feed rod. You don't need to add material. A stir welder will actually use friction and use a head on the end of the welder to actually use friction to melt the material together, and then it stirs it together like mixing batter almost. Yeah. The thing about a stir welder is that you don't add anything to it. So the stir welder will weld stuff together without adding material. The TIG weld is actually probably, I'm not sure if it's stronger, but it'll do the same thing, but you have to add material to it. Then that will increase the mass of a spaceship, which we know mass is the enemy when you're trying to send something. When you're trying to accelerate something to 27,000 miles an hour. Yeah. That looks like the KSP-1 cone adapter. It really does, doesn't it? Why is it two different diameters like that instead of one large barrel? I'm not sure, Jim. If I had to guess, this is just me throwing my hat into the ring here. If I had to guess, the service module is a toroidal shape and probably wraps around this part of the spacecraft. Yeah, wouldn't be the first time we've done stuff like that. I'll bet you, see these pieces right here? 1, 2, 3, 4, 5, 6. Something clearly bolts to the outside of this thing. I'll bet you the service module is a donut shape and wraps around it. This is probably the spot to mount fuel tanks for guidance, propulsion, environmental control systems. Or it could be to fit in a fairing. Could be that too. Once again, these pieces on the outside suggest otherwise. Like you would do in KSP. What do you think? Some of my designs are just something I just pooped out? No, I do. And for a lot of the builds in KSP, I do a crazy amount of research. Yeah, reading about this stuff and figuring it out. It's hard. Stuff's difficult, man. Yeah, exactly. I don't just make up these designs as I go. It's based off of an insane amount of insanely high bandwidth of understanding engineering concepts. That's like one of the hardest things, dude, about what I do here is staying on top of your game when it comes to the knowledge here. Not sure if it still is, but isn't most of Starship TIG welded, or did they swap over? Stir welding stainless is a little bit difficult to do, Raymond. I'm pretty sure that Starship is still tip and TIG welded. It's TIG welded on a jig, just like what Vast is doing. I'm not sure. I think stainless steel might be a little too hard of well, they're using 304X stainless, which is an alloy of stainless steel. I mean, stainless steel is an alloy in itself, but SpaceX is using a proprietary composition of certain metals to make this stainless steel alloy. I don't know. I don't think friction stir welding stainless steel exists. I'm sure there is a stir welder out there that could nice. I'm sure there's a stir welder out there that could probably stir weld like different applications of stainless steel, but I'm not sure if SpaceX does that. I guarantee you they're using jigs though. They could be using jigs with tip and TIG welding though. Just like what we saw with Vast, but stainless and not aluminum. You have to TIG weld stainless steel in real life as well, but once again, it depends on the compound of stainless steel. Stainless steel is not just one thing. There's a bajillion different versions of stainless steel that are all designed for different applications. Heck, there's a bajillion different versions of aluminum too. Like Falcon 9, for instance, is not just the aluminum that they use is not just aluminum by itself. It's aluminum and lithium. It's an alloy. It's an aluminum alloy with they sprinkled some lithium in there for some reason. I bet you it's for structural, but I have no idea. Here's TIG on a jig. It's just like Elf on a Shelf. Yep. And if you're good, you will find a welder in your garage, Electrolama. Yep, that's the truth. Yep. So I think Starship is still TIG welded. Once again, it's TIG welded for the exact same reason. Depending on what stainless alloy you're using, it might not be able to flex the heat correctly. And if you introduce too much heat into a weld, you'll get blow through, or worse, it'll warp the metal. Like getting a piece of paper wet. It kind of just turns into this wavy, crappy mess. If you introduce too much heat into the metal, it'll start to change its shape structurally, right? You don't want that. You don't want you want uniform structure with a spaceship. Anything that's under pressure, you want uniformity. Warping will create problems in this regard. Man, I ain't ever gonna get a TIG in the garage then. TIG on a jig. Oh. Raymond, here, check this out. I'm pretty sure this link that I got over from Phil in the YouTube stream pretty much seals that deal. It's TIG welded. Yep, TIG welded stainless. Once again, it's probably because of the 304X stainless alloy that SpaceX is using. Their proprietary stainless alloy that they developed. Yeah, originally they were using 301 stainless, which is kind of an off-the-shelf application. And then they switched to 304 stainless, which once again, there's just different compositions of different types of metal in these different alloys of stainless. Do I know the difference? No, I have no idea. I'm pretty sure 304 is marine grade stainless, but I'm not 100% sure on that. It's been a while. I'm not the best Texas tank watcher around. That's what my buddies on the flame trench are for. So SpaceX switched to a 304 XL. It's marine grade stainless steel derived, and with that you have to TIG weld it. See? Anyway, credit to Vast there. That's pretty awesome. All right, now this is the last thing we'll do before flame trench. I'm interested in this feasibility study here. Did I say XL? It's 304L or it's 30X. 304X, I think is what it is. I don't know. Anyway, Ship 29 chopsticks are moving to reintegrate Ship 29 after its flight termination system was installed. I might have to save this for later. The best way to do MIG welding MIG welding is with a sidewinder or an AMRAM. Works well with Sukhoi welding too. Found the pilot. What's up, Nader? How you doing, buddy? Oh, hang on. What is this? Oh, Super Dracos. Cool. Where'd you get that video from, Forge? Crap. I spent too much time talking about TIG welding. I don't know if I can make it through this entire freaking article in that time. Oh, boy. Oh boy, we might have to save this until after. Found it in the NASA library. Cool. What is... Oh. I find the best welding is with a B83. Different strokes, though, I guess. I mean, Blood Fam, that'll weld something. You might get some warpage with that. Remember, you got to control the heat here. The B83 makes a lot of heat real fast. I think you might blow through there or blow entirely. Nothing left. Some canned heat, baby. portable sun. I know they were on 304L for a while, then they got their own mix. Yep. My bachelor degree final paper wasn't even that long. Jeez. We weld the ground to the ground, America. B61 is more controllable. It has dial a yield capacity. Okay. All right. I'm going to do the Twitter solution here and just read the conclusion and not read the entire paper. We'll discuss, this is going to take an entire space news to go through this. We're probably going to have to do this next week. Let's see. This paper has compiled a feasibility analysis for Starship based on a published mission scenario and extrapolation of existing systems, where information about Starship had gaps. Okay. Using typical analysis methods, a mass budget for the system and subsystems was established. A Lambert solver was applied to identify the maximum TOF, I didn't read the thing, and delta V. Okay. It has been shown that there are currently several gaps in the available technology to conduct a Mars mission as sketched out by SpaceX. Example, concerning in situ resource utilization capability, making fuel on Mars, power supply, and the performance of Starship itself, which based on the mass estimate presented here is incapable to conduct the mission as proposed by SpaceX. Especially the TOF limits published by SpaceX are to be found unrealistic and cannot be held with current design, requiring at least further improvement of the performance. Some are outright physically impossible, i.e. Mars cannot be reached within 30 days by such a transfer vehicle. We have to read that part, Jax. The current estimate also does not allow the return flight of Starship. Even with an unrealistic 100% recovery rate of consumables, the mission was not feasible for a 12-person crew per Starship, let alone the SpaceX published 100-person crew. Further technological development is required to supplement this launch and transfer vehicle and enable Mars missions. This is affecting Starship itself, but also infrastructure elements needed for SpaceX's proposed mission. Especially those are required for ISRU-based production of propellant. With the information currently available, a Mars mission with Starship is not feasible. Yeah, Jax, that's kind of what I'm getting at. This is a scientific report that was published by Volker Maywald, Micah Bauerfeind, Svenja Faulkner, Bjorn Westphal, and Christian Bach. It's a scientific paper. Overall, with the limited information published by SpaceX about its system and mission scenario and extrapolation from us to fill information gaps, we were not able to find a feasible Mars mission scenario using Starship, even when assuming optimal conditions such as a 100% recovery rate of crew consumables during flight. Written by Mr. Geoff Bezos. No relation. I'm not going to say that they're wrong. Haven't read the paper. Got to read the paper to figure out what they're basing their abstraction on, their analysis methods, the results from said analysis methods, etc., etc. My question is why? And Jax, that feeds you basically picked up exactly on what I wanted to hone in on. Why? Why would you publish this paper right now? Even you admitted yourself that they admitted themselves that there's limited information on Starship and they're making extrapolations. How can you be sure that your extrapolations are, and I'm sure the paper talks about this, to be 100% honest with you. How can you be sure that your extrapolations are correct? Now, here's my other thing. And I think this is important to understand. And once again, Yeah, I could be using my jump to conclusions, Matt. You know, yeah, I would ask why. Why would you do this analysis right now? Starship is nowhere near a fully fleshed out system. And to be blunt here in this regard, I don't think SpaceX even knows how to solve those problems yet. Why? Because they haven't thought about them. Why? Because getting the thing to get into orbit is more important right now. You know why? If it doesn't get into orbit, you're definitely not getting to Mars. And I think this paper, from what I just read, it seems to miss the fundamental point that I don't think SpaceX knows how to do this just yet. But they will figure it out. And that will change the design. Which is interesting that they've extrapolated data based off of, what they know for Starship. Like that. Dude, SpaceX doesn't even know this stuff. They don't know. You go back 5 years ago, Starship's made out of carbon composite. And if anybody decided to extrapolate any data off of that, it would be completely different than to what Starship is right now, right? So why the heck would you even bother doing a paper like this? Super Heavy had a propulsion change between Booster 4 and the early boosters and then the boosters that are flying right now. There's a different configuration of engines. And if I'm recalling correctly, Elon has called for more engines in Starship, at least. So, like, I don't know why I will go ahead and say, and I can say this pretty dang confidently, that there is no way your analysis, the analysis and extrapolations from this paper they probably confine to the laws of physics pretty well. And once again, it looks like a pretty well thought out paper. But there's no way you're extrapolating exactly what SpaceX is going to do. You know why? I don't think even Elon knows how to solve that problem right now. And once again, it's the fundamental premise. The fundamental premise of this paper is that, the design of Starship is a foregone conclusion, which is it's absolutely not. So I guess my whole question for this entire paper is, why would you write this paper right now? SpaceX, because of their iterative design changes, their rapid iteration, Blue Flare, if you ask somebody what Starship's going to look like in 5 years, I don't think even Elon can give you that answer. Elon definitely couldn't give you the answer of what Starship looks like right now 5 years ago. There's no chance. Starship looked completely different 5 years ago, and it's going to look completely different 5 years from now. As we progress further and further into the program, the changes might be a little bit less. But to seem to imply that your analysis method dictates, you could, within the confines of the laws of physics, right? The analysis method is, and what Starship is going to end up being, that is ridiculous. There's no analytical method here for being able to figure this stuff out, because not even SpaceX knows it. They don't know how they're going to fix it. They know they're going to, when it comes to that time, they're going to tackle this problem head on. Look at how many people between IFT-1 and IFT-2 said, "Oh, Super Heavy is a big problem. They really got to figure that out. The Raptor reliability is concerning to me." And then it wasn't. And then it wasn't for Flight 2 or Flight 3. The Raptor, nobody did. Where are all those people? All those people that did good analysis on Raptor reliability here. Where are those people? Oh wait, they shut up because they were wrong. Just saying. And don't get me wrong, I'm not trying to be a complete SpaceX fanboy here, but I think at this particular moment in time, even considering writing a paper that claims that you understand through analysis and some and kind of extrapolations of given data, that you somehow know that what Starship's final design is going to look like is a little bit ridiculous. Like, no, you don't. I'm pretty damn sure. I don't think SpaceX knows. You need a flame trench. Oh, yeah, Phil, you remember that? Where are those people? Yo, you remember how people made a big deal about dumping industrial heat wastewater and how that they're never going to let them fly? I'm pretty sure that was 2 flight tests ago. Yeah, okay. Sure. I can't change the laws of physics. Not to be pedantic, but to what degree does Elon design rockets? More like his engineers. 415, I don't know where you're trying to go with that particular argument, dude, but no, Elon doesn't design every single rocket. He comes up with the stakeholder expectations, and the engineers come up with solutions. But to understand stakeholder expectations in the construct of rocket systems engineering and design, you need to have a pretty damn good fundamental understanding of what rockets do. Right? So no, I don't think he's doing the day-to-day engineering. He comes up with the stakeholder expectations, and you need to be a pretty damn good systems engineer to know that. Also, you need to be a damn good project manager, and I'm pretty sure he's pretty good at both of those, considering the track record, you know? So no, he's not, I don't think he's involved in day-to-day stuff, but he definitely is involved in what Starship's end goal is. Does that make sense, dude? You can't change the laws of physics, John. Yeah. They're still carrying the goalposts to move them yet again. Give them time. Yeah, right. Yeah. They're moving it downfield. Yep. Right. Yeah. I see this like there's a fundamental difference between an engineer and a designer. But to design things, you need to know engineering pretty well. You don't need to be an engineer, but you need to understand it pretty well. Elon is an engineer. I mean, James, he's not an engineer on paper, dude. And I think that's a very important distinction, you know? But Elon understands engineering. You'd be a fool to think that he doesn't. At least on at some relatively deep level. He knows about engineering more than the average person. You know, SpaceX didn't just blow in from the farm, you know? Like, the idea to propulsively land Falcon 9 was his idea. Because he thinks partial reuse and full reuse, well, partial reuse at the time of Falcon 9's development and full reuse for Starship, that's his stakeholder expectation. Think about it like this, dude. A designer is like the dungeon master in a D&D game. You're coming up with the construct for what your engineering exists. That's what a stakeholder expectation is. Elon's the DM of SpaceX. Does that make sense? Obviously, with D&D, a dungeon master can't change the fundamental rules, but then again, it depends on the type of D&D game you're playing. You know, there are certain underlying fundamental rules to any D&D or tabletop game, right? In this particular scenario, those underlying rules are the laws of physics. But Elon's making the construct. He's figuring out what they want to do with those laws of physics, right? He's the DM. Yes, I know what that means. I didn't play much D&D, to be 100% honest with you. I'm not hating. I was more of a Warhammer 40k guy. I had a lot more fun with that because it was like playing Hearts of Iron or StarCraft or something, but on a tabletop where you're actually talking to another person. Like, that's pretty cool. I enjoyed that. D&D mentioned! Success! Yeah, so once again, 415, I see people say this all the time. Elon's not actually designing the rockets. No, he's not, or not actually engineering the rockets. No, he's the designer. Differences. It helps if your designer is an engineer, though. That absolutely helps. Warhammer 401k, you mean? Yeah, you're right. Warhammer 401k. That's pretty funny, dude. You have to know what you can and can't do. So he's an engineer. You and I are engineers. I would, James, you gotta be careful with that, dude. I'm not an engineer. I'm an armchair engineer. I understand engineering. I can communicate engineering, but I'm not an engineer. I'm not confident enough in my abilities to put a stamp on a plan for a piece for whatever and say, yep, this is good. Now, you give me enough time? Yeah, maybe. But got to be careful with that, dude. If you want to be an engineer, you want to build, you want to design rockets and stuff, you got to go to school for it, and you have to get that stupid piece of paper. Right? This is not just whether that piece of paper makes you feel like an engineer or not. This is you're willing to put your name on systems where human lives are at stake. I am not willing to do that because I'm not an engineer. Does that make sense? I play one on Twitch, though. Who is the dungeon master at Blue? What do you think? Who do you think's coming up with the stakeholder expectations at Blue? Beef Jesus. No, Jeff is the one that came up with the overall goal, but Jeff is... The difference between Jeff Bezos and Elon Musk is that Jeff is a delegator. And don't get me wrong, Elon delegates the work too, but he is much more involved in the stakeholder expectations and design process. Jeff Bezos strikes me as the kind of guy that is an insanely good project manager, but is kind of hands-off in the design department. That guy can manage projects. You don't build something like Amazon and not know what you're doing. Amazon is a logistician's wet dream. Think about it. You can click something on a website for a product, buy it, and it shows up on your door less than a day later. That is logistics pornography. The guy's good at project management. I don't care what anybody says. Yep, you have to have a PE licensed engineer. Yeah, there you go, Meatwad. Yeah, that's true. Logictician. That's going into my vocab. I'm not sure that that's even a word, to be honest with you, but you get the idea. Then call him the architect. I would call him a systems designer. He's a designer, not an engineer. It 100% isn't a word, but it is now. All right. Sure. Just making up words on the fly. That's why I'm not an engineer. I'm a good designer, though. I can design things. Sure. Not an engineer, though. I used the small e in engineer. Oh, yeah. It's not capital, so it makes sense. Engineers typically work 60-plus hours per week. You wouldn't have time for Twitch anyway if you were a full-time engineer. That's right, Rogue. That's why I always make it a big distinction. I am not an engineer. I'm just good at communicating the concepts of engineering. I would not fly on a spacecraft that was engineered by me. Maybe designed by me and engineered by somebody else? Yeah, sure. Think about it like that. If you're confident enough in your systems to be able to put yourself on your own designed rocket and fly into space, then you're probably good. I would not fly on something that has my name on it. Absolutely not. Maybe in Kerbal, though. Yeah? That's definitely not true. What part, Duke? Anyway, I got to get going for Flame Trench here in a second. I would like to read more on this part, how they abstracted and how they did their analysis. I'm interested. They might be onto something. Who knows? Can you link the paper? Sure, read it up. Oh, the aerospace engineer in 40, yeah, rocket engineer, 40-hour weeks. Yeah. I guess it depends on the facet of engineering, right? Structural engineer. So, structural engineers deal a lot with statics. Bridge engineers, road engineers, that's different than aerospace. In fact, I would say that if you do too much aerospace engineering, it can melt your brain by the end of the day. You should probably limit your aerospace engineering intake to probably 40 hours a week. That's probably a good idea. Seriously, this is difficult. Hooded as a civil engineer, EJ, I can easily say that an architect's design is sometimes my worst nightmare, since the things they design sometimes without the knowledge of structural engineering are so surreal. So to make it happen, we need to invent new technologies. Yep. Designers and engineers, two way different things, dude. Structural engineering's easy. If you ignore hydrology, that's where it gets real messy, both on paper and in practice. I don't know what that means, Poison, but I'll take your word for it. Mishap investigations can be 18 hours for 2 weeks straight. Fault tree analysis, dude. Troubleshooting engineering. Oh my God. That part sucks. If engineering is like running a marathon, engineering where you have a mishap and a fault tree analysis is like running a marathon where sections of them where you run is in quicksand. Yeah. How hard do you want this to be? Yep. All right. Anyway, we'll talk more about this this paper a little bit later. I did link the paper. I'm interested. I actually want to read this, and it looks like it's going to take a long time. So, you know, what I'll do right here is just look at the pictures. Polyethylene, Jesse. It has to be polyethylene. I just want to look at the pictures. Let's see. Ooh, piece of candy. Yeah, personally, I think that, you know, there's a fundamental flaw in this entire logic. SpaceX wouldn't even be designing Starship the way that they were if they weren't confident that it would do Mars missions. That is the primary stakeholder expectation in the entirety of Starship's design. I think that paper overlooks that part. But whatever. Whatever. We'll read more later. We'll probably end up going and doing a deep dive on this paper. Probably, I'd say we could do it on Monday if you want. We'll do it on Monday. If you guys are into that, let me know. Mars travel needs to be engineered. That's my argument, James. That's exactly what I'm saying. You claim to know how SpaceX is going to get Starship to Mars. Not even SpaceX knows how to get starships to Mars. You know why? No one's ever tried to get a Starship to Mars. Ever. Ever. Starship is gigantic. It's the size of a 22-story building, the biggest payload that we've landed on the surface of Mars, which has no intention of ever returning, is about a Mini Cooper-sized rover. Last time I checked, a Mini Cooper is a little bit smaller than a 22-story building. I mean, who knows? Maybe we'll get an architect in here to make a creative design where they make a 22-story building that's the same volume as a Mini Cooper. I don't know. Could happen. Depends on what your stakeholder expectation is. And on that bombshell, it's time to end. No, Thank you for watching BBC Two. Our next program here on the channel is NASA Spaceflight Live, The Flame Trench, coming up here at the top of the hour. Bow, 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 bow.
the start line, right?
Yeah. Starliner is going to launch within 24 hours, hopefully. Starship will launch within a week, hopefully, and New Glen's might launch sometime this year, hopefully. I'm Jack Byer? Roll the intro.
And here we go.
We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Traveling up. Roger, Atlantic.
Water towers fly! Yes!
Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange!
Orange 25. Oh my God! Oh my God!
Decollage. Look at this! Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You good? We don't need any more of these.
Hello, everyone, and welcome to the Flame Trench. I'm EJ, and I'm hosting tonight's stream. I don't know why they allowed that, but hey, I'm not complaining, and neither should you. Tonight, I got two very special guests with me. We have Sawyer in here with me, and Alex too. Alex, what are you up to?
Are we live already? Oh, sorry.
No. This is just a practice test.
Oh, okay. Thanks. Yeah. So that was
What's going on,
was
buddy?
nice.
How are you tonight?
Well, I was here, on next space flight, looking up all the launches that we have. We have a lot of launches coming up. But I guess we're going to be talking about other more important launches. There's probably a couple of them coming up that I guess are, nerve tingling.
We've been known to watch launches here from time to time, yeah?
Yeah. I'm sure of that.
Yeah, Okay, cool. Well, good to hear. And then always joining me is the ever popular pun extraordinaire, Mr. Sawyer himself. Sawyer, how are you?
Oh, I'm good. Sorry, I felt like I should be reading something, so I was reading the ingredients on the pretzels on my desk. I'm doing pretty good. We got.
You guys stealing my joke?
Well, Alex had Next Space Flight up. You read the book. I'm like, I gotta read something, so ingredients it is. But yeah, no, like you said, a lot of exciting launches, especially Starlink tonight, because that's the one that we all care about, right?
Yes,
I'm
Starlink.
here for him. I'm here for this, for Starlink. Yeah, no, that's a good idea. We should keep watching those. I'm quite fond of those.
Keep watching the skis. I mean, the skies.
Yeah. So
yeah,
we got a lot of different stuff to talk about. We're going to talk about Starliner today. We're going to talk about Starship. I mean, and I don't think we should talk about Starlink, but we'll probably end up doing that anyway. So Sawyer, do you we want to get into the discussion here? What's on the menu for tonight initially? What's the appetizer?
Apart from pretzels.
I mean, apart from pretzels. Yeah, no,
apart from
pretzels are
pretzels,
good.
cheese puffs. God, I need to clean my desk. Our hors d'oeuvre is a crew mission with a capsule named Calypso, with a slight small helium leak that is still going to be okay anyway as it launches. Yes, our first topic is Starliner. It is back out at Space Launch Complex 41 ahead of the crew flight test mission Take Deux. It is all set for tomorrow, Saturday, June 1st, 12:25 p.m. Eastern Time. They held a Delta flight readiness review on Wednesday, which is basically they went over all the stuff that they know has gone wrong. There was the issue that initially caused the screw-up back on the 6th of May, which was a valve that kept opening and closing and went past its lifespan. That's been replaced. That's been checked. Then there was the service module leak, which they looked into. And yes, it is still going to be leaking, but not anything significant enough that it is a concern for the mission itself. And then they even took a look because it turns out that the parachute manufacturer for Blue Origin and New Shepard is the same one that basically makes all the parachutes, including SpaceX, including the capsule that is set to fly. And yeah, that one, you may recall, one of the parachutes didn't open on its most recent flight, although it landed safely. It had to do with one of the cutters, so they are aware of that and say that it is not an issue for this flight. In terms of weather, it is currently 90% go. The only potential concern would be winds, might be a little on the higher side. All the downrange weather looks fine in the event of an abort, and we have no idea what they're having for breakfast.
Oh, I mean, hopefully it's good, right?
Hopefully. The question was asked in a briefing today, but yeah, there was no known answer.
So, sorry, you said that they talked about the parachutes, right? With a New Shepard flight?
Right. Yeah.
Huh.
The NS-26, because it turns out they're all the same manufacturer of the parachutes themselves. So there was a little bit of, cross-companying of like, hey, what's going on here? Is this something we need to worry about? And yeah, it turns out there's sort of like a wrap that chokes around the bottom of the parachute before it deploys. And then there's a cutter that will cut it, and that is what starts the reefing process, which is eventually how they open. And apparently there's an issue with the cutter on that particular one. It is not something that they are concerned about for this flight. And just like with all the other vehicles, it can also land with, a parachute not fully inflated still safely.
Yeah, the main
That's
concern.
cool. Yeah,
The
go
main
ahead.
concern was because airborne systems or something like that. It's the name of the company. Those are the ones that make the parachutes for all four spacecraft. So they make the parachutes for New Shepard, Starliner, Dragon, and Orion. So they make all of the parachutes because there's like one single company making all of them. Talk about a monopoly there. Yeah, you got merch pie. Oh, this is double merch pie because there's like
Help.
here.
Help.
and also
Help.
up
Just
there.
duck and cover.
Okay.
But yeah, it's like there's only one company making all of the parachutes. So when one of these capsules has a problem with one of the parachutes, it's like, oh, maybe we should check the other parachutes and see what's going on. And yeah, one thing that I usually tend to talk recently about is that parachutes are really complicated to model. It's not really something that it's easy to model, and so you really need to treat them really really nicely if if you know what I'm being here, where if you have just a little bit of an issue somewhere, you really need to look and make sure that there's no commonalities. I believe in the case of a Starliner, what they did is that they looked through all the data on the reefing cutters for all of the system, the tests that they have done in the past for Starliner parachutes. And they found out that, on all of these, I think it's like 160 or something tests that they did of those cutters, it was all pretty much good. There was no, any issue with that. So it must have been something relative to whatever set of cutters Blue Origin uses on New Shepard. They're still looking at it though, so we won't know until they actually go through the entire
Yeah,
thing.
they weren't sure, Alex, if I'm remembering right from the presser this morning. There was a lot of information conveyed, but the particular part that caused the chute to not open was not made by Airborne. The chutes are made by Airborne, right? Yeah,
Mhm.
the reefing
Right.
the reefing line. Yeah, okay, cool. But
They
it's
asked
cool to
about
show
the
that there's
contractor for that, but apparently they didn't have the name in hand for
It's a
that.
different contractor. Yeah, it's cool to see, that some commonality between all this stuff. And I know what people are going to ask. Well, if they're all using the same chute, wasn't the whole point redundant, dissimilar architecture? Well, yeah, but I mean, you're still going to have there is some commonality between these vehicles, right? The docking port, for instance, Starliner and Dragon both dock to the same port, which is the International Docking System Standard, or NDS, NASA docking system. It could be either one. So there is some commonality across the board here, but it's cool to see all the industry kind of commingling and working together. That's cool.
It's a good thing you
Or-
mentioned that, because that was actually something that they brought up, which I thought was really interesting in the briefing today, too. The fact that on their last sort of docking, their automated docking, SpaceX noted that one of the reflectors that's used in the assistance of the automated docking is kind of degraded a little bit from what it normally is. And so they told NASA, hey, fair warning, this might be an issue. And Boeing might actually want to know about this. And so they shared the info with Boeing too of, hey, this reflector that's used as part of this sort of international docking adapter that all of our craft are using might have an issue. So they're sharing a lot more data now. And that's the beauty of the Commercial Crew program is, yeah, it's two different companies. Yeah, they're kind of competitors, but the same ultimate goal is to get people safely to the space station. So it's kind of cool to see them actually share information.
Yep, that type of collaboration and sharing that type of information to make the industry better is beneficial to everybody. Rising tide raises all ships, right?
Yep.
Well,
So
yeah, except for the ones that sank, but yes.
But yeah, the best way to actually not have any sort of like the best way to have the similar redundancy, that was the word that was going to be using for landing a spacecraft, is to not use parachutes at all. So there you have Dream Chaser, for example, landing on a runway, or in the future maybe Starship, which is propulsive landing. I will argue that those two are probably much easier to model than parachutes. Parachutes seem very complicated from a modeling perspective. It's easy to say like, oh yeah, I'm gonna put some piece of fabric and pop it out of my capsule and try to keep it there, and that'll slow me down. But then it's like if you have more than one, you have to take into account all the reactions. Like with Dragon, for example, because it has four, in some certain circumstances, you may inflate all of the four of them, and depending on what is your rates and whatever, maybe one of them will inflate and then deflate, and then you'll think, oh, my parachute failed, but it's no. It's just because of the situation you're going down just as if you were having those four fully open. But there are certain occasions where, because of the whole problem of modeling and everything, it just doesn't need the other fourth parachute, and so like it deflates itself. It's not that it's wrong or anything. Sometimes it just eventually inflates again, maybe when it's lower down in the atmosphere. But that has happened many times, and it's like, well, it seems like that's just another way of the whole thing to do its work. And yeah.
Yeah, absolutely. Guys, yeah, I think something that's kind of looked over a lot by spaceflight fans is the process of deploying these parachutes. That's a complicated amount of things happening very quickly. It's good to get this information, like to model this information, as Alex said, like do as much testing as you possibly can, and then when you're done, do more. That's I'm not going to say it's single fault redundant, right? Because these crafts have multiple parachutes, like what Alex was saying. Dragon has 4. It only needs 3, but it has 4 just in case. Just in case one of the the unfurling and the reefing process doesn't go correctly. Process, nice. That's your phrase of the day. Yeah, it is actually pretty dang complicated to come up with the models, the analytical models for parachute deployment. And I think it's something that's very overlooked. And I think if anybody has questions regarding Styliner or anything like this, Styliner, nice. Sawyer, do we have something in the queue?
Press star 1.
Oh gosh, no.
Press star 1 and we won't answer your questions.
Yeah, pretty much.
Yeah,
that's a whole nother
press
story.
star 1.
By the way, one of the major differences to point out between the different parachutes, Blue Origin has blue in it.
Oh.
NASA's doesn't have blue in it, I don't think. I think it's just, is it red or orange?
Well,
it's orange.
It's orange. Actually, you bring this up, Sawyer. Every parachute, including the 4 different parachutes, like let's take the 4 parachutes on Dragon or the 3 that are on Starliner. Every parachute, if you guys look, every parachute has a different design on it. Like one will have a checkerboard, the other one will have like a dartboard, like shape on it, like painted. Like the colors of the parachutes are, they're different colors, but they're also different designs. And that's for when you're imaging a parachute deployment. If one goes wrong, which design is attached to which parachute mortar. So you can see if the number 1, 2, or 3 chute went out. It's actually super interesting. Not something that a lot of people touch on. The parachutes all have different designs. So if one goes wrong, you know exactly which one it was.
Right. There's actually that New Glenn mission that we were talking about that had the parachute that didn't fully reef. Or New Shepard, sorry.
Yep.
New Glenn.
Jumping a little far ahead there.
Yeah.
Within the year.
Yeah.
Ish, hopefully.
Well,
yeah.
Hopefully 120 days away. It's supposed to be September 29th, I believe.
2 weeks.
Well, there's the propulsive landing of their booster.
Yeah. And I will argue that's probably a lot easier to model from a physics and engineering perspective. You can probably replicate it a lot better than parachutes.
Hey, it landed. That was fast.
All right.
The magic
Say
of
what
YouTube.
you want about Blue. That thing is really
That's
cool.
It's
pretty impressive what that thing
capsule.
does.
There it is. Yeah, that's it under some of the chutes. It's got a little rotation to it there.
Yep. That would be a roll rate on the telemetry.
There it
That's
is.
Slight rotation. Yep.
You can see the parachutes. First off, again, it's blue. But yeah, as EJ pointed out, you can kind of notice that there's slightly different patterns on the top of each of them.
Yep. Wait. You're telling me it's not orange?
It's partly orange.
It's orange and blue. Let's put it that way.
The top is orange.
You can see there the parachutes. In order to not stress it, because when you pull it out, you're in the airflow and everything. When you pull out the whole thing with all of the parachutes and everything, you really want to not stress all of that system, and so there are stages in how you deploy the parachute. And there, by the way, you see a lot of dust and everything. That's because of the engine. There's like well, actually more than one, but it's like multiple thrusters that soften the load as it lands on the ground, just like Soyuz. Soyuz also has a similar thing, and I think the Shenzhou spacecraft also has the same.
Yeah, 'cause it's basically a copy of Soyuz.
That's another topic. but yeah, so you have the parachute just comes in and it's like super, like constrained on the bottom and trying to get some of the air into it. And once there's enough load, then there's like this automatic reefer cutter, so to speak, which cut away the sort of line that keeps the parachute closed on the bottom, and so they open and it lets the whole thing free. That's sort of like the second stage where all of the incoming air tries to inflate the parachute, and then there's like these fully inflated mode. And even when it is fully inflated, you can still see the parachutes like still hang on, because the like doing this sort of wobbling kind of thing where it's still taking some air in and some air out and things like that, and it's still trying to get into an equilibrium point, but it's sort of like wiggling, and so you can see it on some of these parachute landings, especially when it's like super close up. You can see that.
Yeah. Sawyer's controlling the queue tonight, guys, because I'm not as cool as Jack is. So, Sawyer, do we have any questions on that side of things? I see a lot of gift subs over there, a lot of members getting awarded, and a couple of tips in there too. So, thanks for the support, guys. But Sawyer, what do we got?
Yeah. Which you want? Let me recognize a couple of those gifters here really quick. Elizabeth, before the stream started, thank you for gifting 10 Red Team memberships. What did I miss? Gifting 5 Red Team memberships. Oh, you missed not too much. Pretty early on. And Chris P, 1341, gifting 550 Red Team memberships. Holy smokes.
What I'm talking about.
Thank you.
It's awesome.
Let's see here. We'll take some questions. We've got Mr. Dollar talking about what is the flight trajectory for this launch. And I think it's worth noting, again, this is a ISS mission, so that will be launching towards the northeast, but it's set to land, when it's all done, in White Sands, New Mexico on land. It lands on sort of these airbags in addition to the parachutes that fly with it as well. And this, I believe they said the earliest date that would be coming back would be the 8th, if I recall correctly.
Yep.
But they said they are going to run the vehicle through its paces, and if that means keeping it on board station a little longer to do so, they're more than happy to keep it in space longer.
Yeah, it is coming back on Monday, June 10th.
10th, thank you. Yeah.
Yep.
There's flexibility in the return.
And there are
depending
two
on...
different landing opportunities, apparently. One, I don't remember exactly when, but the second one is at White Sands. Because they have multiple locations, right? This is sort of the benefit of the US, because you guys have a lot of different desert areas. And so there's like different locations where you can land. And one of them is at White Sands. That's the second opportunity of the day. The first one, I think it's during nighttime, and that will be somewhere else, which I really don't remember right now, to be fair.
Well, here's the timeline for the launch itself. So if you are anywhere along the viewing area where you might be able to see it, here's kind of what to expect as it reaches Mach 1. And then you have the 2 solid rocket boosters that will jettison away. Meanwhile, that main booster will have their engine shut down. The RD-180 is there, and then the Centaur 3 main engine start with the 2 upper stage engines. Get that aeroshell that separates away. And then MECO 1 for Centaur 3. And then about 15 minutes into flight is when Starliner will be on its way towards the ISS with one final orbital insertion burn there.
With the OMAC thrusters. They were really focusing on, because one of the things of the helium, you guys explained it last week, because I watch you guys on my flight. I have proof of that, by the way. But yeah, I one of the things that they really tried to emphasize a lot was like we can launch this thing with a leak. It's not that it is not a huge deal, but it is not something that can really stop us. Like, it's not something that is a showstopper. the whole deal with taking 2.5 weeks to get to this point was more about understanding that that was the case, right? That it is indeed something that they can go forward with. And there's like, usually when you have an issue, there's always like 3 layers of, and there's some glitching here, but anyways, there's like 3 layers that you have to go through. One of them, the first one obviously is like, why did this happen? Why did this issue happen? The second one being, okay, I have an issue. What do I do? What are my options, right? You say, for example, for a Starliner, you either roll back and try to fix the issue with a helium valve, which once they went into all the stuff, they figured out, well, in order to fix the issue straight away, we will have to destack the whole Starliner, make it back to the C3PO, I think it's called the facility.
C3PF.
Or C3PF, whatever. It's because of the Star
The
Wars thing.
R2D2 maybe.
Anyway, so yeah, they will have to roll it back. They also have to deservice the service module, essentially removing all of the hydrazine and nitrogen tetroxide and all the helium, and essentially just safing it completely so that they can go into that area because it's right next to other fuel lines. So it was that option, which will have led to many delays, or was like, well, the other option is, can we live with it? And they figured out that yes, they can actually live with it. The third layer is, okay, we can live with it on a nominal situation. What if we have an unnominal situation? And then they look through all the different, unnominal situations and whatnot, and they figured out that they needed to make changes to, the decision making of the spacecraft and all that. That is more or less what you do on any occasion when you have an issue. You go through all those 3 layers where you figure out the issue, look at your options, and then once you choose an option, you're like, what else can happen here, right? What else could be a problem for my system? And so I understand that, but there's obviously the usual thing of like, you figured this out because there was a scrub on Atlas, otherwise you will have figured this out in orbit. And they kept saying today on the presser that no, we will have solved this and everything. And it's like, would you? It took you 2.5 weeks to really come to a conclusion, to really come to a decision. If you had crew in orbit with this leak, would you really have taken that time? Would you have been able to really take that time? Or would you have taken a more safer path and maybe not just even go to the ISS in the first place and just land them on the first opportunity and return them back so that you keep their safety? And so it's this whole thing where it's like, yeah, now that you have discovered it, you say that you could have done the solution in orbit and whatnot, but it's like, you should have been in that position, right? Like, it's not easy, and I don't think it could have been the same thing if this had been found in orbit. And so I think that Centaur issue was actually beneficial for them, because that allowed them to be able to look into this while they were still in the ground, not putting those astronauts at risk, and being able to really understand what was going on. Again, it is not something that will have hampered and or have been any damage to the crew or anything. They understood eventually after 2.5 weeks that they can live with it. But again, they took 2.5 weeks. If this had happened right after launch, while the crew is on on their way to the ISS, I don't think they will have been able to really figure that out that quickly. And probably the most safe decision at that point will have been to return them back without even docking to the ISS, which frankly will have been quite a disaster for Boeing, if I'm being honest.
Well, okay, so yeah, I mean, I agree with that. You obviously want to find your problems when you're down here, right? You got everybody's seen First Man. You got to fail down here so you don't fail up there. Now, with that being said, NASA said they were confident that if this problem did happen on orbit, that it would be manageable. Now, the thing to understand here is that what took so long with Scrub, it wasn't necessarily figuring out and understanding that there's a helium leak. They figured that one out within a couple of days. The real thing that took the time is to figure out the contingencies needed in case that thruster fails. Now, what we're talking about here is a helium-actuated hypergolic valve. I swear that was English. I swear it was English, okay? I swear. All right, so you have on Starliner with its particularly its orbital maneuvering and control thrusters. Those are the thrusters that are used for on-orbit changes, so changing orbital parameters like boosting up to the ISS, or in this particular case, it's also used for deorbit and landing. Basically, NASA went through and established, I think they called it a Delta Revue team, to be able to figure out, in case this thruster does fail completely, or the helium leak just gets worse than what was documented. That's the important part. What was documented and understood from the initial pushback of the launch, whether they'll be able to get the astronauts back down. Now, NASA said that they are confident that this helium leak is something that they can live with. Like Alex was saying, it's something that they can live with. It's something that it's not that big of a deal. It's not leaking that much helium. And because helium is your actuator for your valves and also your ullage for the hypergolic bladder tanks that are used to pressurize the system, you always have a high margin there, and it's in double redundancy with 2 tanks and 2 distribution manifolds for the pneumatic system. I swear that was English too. I swear. Chat, don't look at me like that. That was English as well, okay? Long story short, there's a lot of redundancy built in to take into account that there might be a helium. Now, I know what people are going to say. People are going to say, why are they okay with stuff leaking? Well, all right, spoiler alert, guys. Every spacecraft leaks helium. It's like a bilge on a ship. Helium's going to leak. It's just a question of where. Steve Stitch in the press conference from last week said the shuttle had this problem, Starliner has this problem, Dragon has this problem, or has had this problem in the past. And now, keep in mind, so I know the next question is, why don't they fix this leak? Why don't they fix it? They're cool with it just leaking everywhere? Well, yeah. Remember, this is a crew test flight. This is a flight that is supposed to mimic the ideal process from Starliner sitting in its hangar, in pieces, all the way to recovery out at White Sands. It's a campaign for a reason. It's not just launch and not just coming back down. That is a part of it. That's the most important part, but it's not all of it. Now, like I said, I was talking a little bit earlier about this on the Twitch stream. I stream on Twitch for anybody that cares. Yes, I'm shamelessly plugging myself. Don't look at me like that. That's what you got to do as a content creator, okay? All right. So you have it's the entire processing flow. You want to mimic the whole thing from Starliner at, in pieces all the way to the landing. All right. Now, which one of these? You got 2 options. You can replace this thing by going backwards in your processing flow, taking the whole thing apart, hopefully fixing the valve. Maybe, I don't know, maybe you damage another one. Putting the thing back together, putting it out on the pad and sending it. Or you could just live with the leak that you understand and is well within the margin of error for your helium tank quantity. The safer solution here is to send it. And that's something that you'll very, very rarely see in the aerospace industry, but that has a lot to do with risk management and how NASA goes about doing risk management from past things. You know what I'm talking about. Anyway.
Yeah.
Yeah, past things.
Yeah. So in this case, it makes more sense to not destroy the entire vehicle and reinstall all the systems when something else could go wrong, when you understand that this isn't as big a deal.
Dude, I got people in the Twitch chat saying, I'm here because he plugged his Twitch stream. Oh my God. Thank you.
Well, you do have Out of This World who did congratulate you on hosting the show from a big EJ fan. So.
Oh, yeah, that was a pretty good. I saw that too. That was £2. £2 sterling. Thanks,
£1.99, sir.
Oh, well, this is completely insulting. How dare you?
Can you believe I went to the UK? I haven't really seen pounds.
I mean, I put on a bunch of pounds, but my wallet has not.
That
changed.
that might have been something that I also took from the UK, a few pounds, but not of these.
Wait a minute. I'm hosting this stream. No puns, Sawyer. Wait a minute.
No,
Wait a minute.
I'm sorry, who's in charge of the panel? Who's in charge of the panel?
No puns? What? A flame trench with no puns?
I'm going to officially rename it to the Punnel then, okay?
Oh, God. Please, no.
Could be worse.
Oh, dear. Okay. Are we moving on? Any more questions about Starliner? Anybody?
There's actually a couple, yes.
Oh, hit
Bring
me
him
with
on.
those laser beams. Let's go.
Yeah, there are a few more that I definitely want to hit here. Let's see. Hang Time Central saying, "Forget the astronauts. What are you having for breakfast?" Don't know yet. I'll probably have a bagel on the way because you know me
Are
and
my
bagels
glasses
here.
blurry? EJ, you need to be in focus. Hang on.
Oh yeah, EJ, what?
Stop it! Stop! What are you doing to me, camera? Whoop. Sorry, chat. I didn't mean to boop you.
He's out of
My
focus.
bad.
Look at that.
Dude, what?
We need focus time. We need focus. Kevin Michael
It's
Reed,
time
we
to
need
stop,
focus
camera.
time.
It's time to stop.
Continue.
See, it says focus time even on the banner. Look.
Yeah. What the heck is this?
Here's an interesting
take me off the
question, though.
No.
For those who don't know, they had to move the Crew 8 capsule to a different docking port. Joe Pipple wants to know, if docking is the same, why does Dragon need to move for a different port in preparation for Starliner arrival? Alex, do you want to try to take this one?
Yeah, that is right now because the software that they have on the Starliner right now can only dock to the front docking port. This was the same for Dragon. For Demo 2, they only dock to the front docking port, so they cannot go to the Zenith until they are actually on the operational missions. Essentially, the whole deal with that is that it is easier to approach the forward port. It is also safer for the ISS operations. Once you've flown a few times up to the International Space Station, then you are allowed to go to the Zenith port, which for Dragon, it happened on Crew 1 and Crew 2, and a few other missions also docked to there or either relocated at some point. Also, cargo missions have also docked to the Zenith port, cargo Dragon missions. So there's obviously that sort of constraint from NASA of, hey, let's not go crazy on this first attempt to dock to the International Space Station with crew on board. Let's go with a safer route, which is the front docking port. So that's why Dragon had to relocate to leave that front docking port empty for Starliner to go ahead and dock to it.
By the way, it's official. Cameras hate us today, apparently.
Yeah, I just tried to ignore it. It's not happening.
I mean, the focus and the flicker.
If I don't see it, it's not illegal.
You hate me, chat.
I think you officially just created an LSR GIF there.
Yes.
No.
Now
Here's
he's available
one.
to do the gifts, because last week he was at the meetup with me, so he was not able to do that.
Yeah. F-13 Media saying, is there a blanket over the Starliner capsule? Because, yeah, we've talked about the parachutes and all that stuff, but the thermal system, that is thermal blanket on the outside of it. In fact, you could see sometimes the scorch mark, the one very distinctive scorch mark on Calypso, since that one flew the original orbital flight test, which was not supposed to have a number, but is now known as OFT-1, after it kind of, didn't make it to the space station because someone doesn't know how to tell time.
Well, the blanket is there, for the cold of a space. Starliner is just cold, so it needs a blankie.
Well,
and then
if the shuttle blankets are, the Nomex blanket, those are the blankets. The tiles are the pillows, right? Starliner has some tiles,
pillows, but
oh, this is the part where you flex and say you have a shuttle thermal tile pillow, Sawyer?
No, I just have actual shuttle thermal tile.
Oh, okay, there it is. All right.
Flex.
Oh, okay. Oh, all right. That's fair.
And then, let's see. One more that I do want to hit here with Starliner. 20-minute event saying, can Starliner be mated onto Vulcan? And we actually interviewed one of the people with the commercial crew program and integration down at the Cape. And if you watch the broadcast tomorrow, you'll be able to likely see part of that interview. The interesting answer to that is probably. The ultimate goal will likely be for Boeing to then transition over to Vulcan because there are no more Atlas V's. All the Atlases have been bought and assigned, and there's none left. So there are 6 Starship flights that will fly on Atlas. Beyond that,
Starship?
It doesn't. Yeah, beyond that, Starliner doesn't really have a launch vehicle. So
yeah,
it would be kind of funny to see a capsule mated on top of Starship. But
and here's the
I don't hate it.
but here's the thing. if that's all that a Starliner is contracted for, and there's no other flights, why will it need Vulcan for?
Well, it might get another contract? Question mark.
I mean, I think it's a fair
That's the
assessment
big
to think
question, right? Is it gonna get
Yeah.
another contract?
I think it's a fair. I don't know if it's going to get another contract from NASA, even though there's stipulations in commercial resupply too for them to extend it out, like what they did for Dragon. Uh, SpaceX got an extension on CRS-2 I think it was an extension on CRS. Anyway, I don't think it's unfair to think that that might happen, but also I think it's important to understand that Boeing has clearly, because they're willing to hedge a lot of their own money to get Starliner working. I mean, the OFT2 test, Boeing paid for that out of pocket to the tune of like 420 million.
Nice.
Yeah, that's the meme number. All right. They paid out of pocket for that mission. I think it's pretty clear that they're heavily invested in this. And the only way that really for that to really make sense is that they're anticipating a commercial low Earth orbit market with destinations that aren't NASA. Even though they could extend the CRS-2 contract, I mean, it really depends on the lifespan of the ISS at this point, I would say. Yeah, I mean, I think there's some commercial low Earth orbit destinations that might not be the ISS in the future. Hint, hint.
See, my only
No,
worry. Oh, sorry. Go ahead, sir.
No, I was just going to say I had no idea who in the Axiom you're talking about. But anyway, continue.
Yeah, Alex, go for it.
Yeah, my only worry about that is that, Axiom seems to like Dragon, right? We also have Vast with their Haven station. They also seem to like Dragon. There's Orbital Reef at one point had renders with a Starliner on it, and with Boeing collaboration.
Yeah,
So you're saying there's a chance.
Of a few months ago, I stopped seeing those renders with a Starliner on it. And it's been a while since I've seen Boeing talking about Orbital Reef, like their collaboration with Blue Origin on Orbital Reef. And then there's Starlab, which is taking none other than the Indian Crew Capsule as their crew spacecraft, which is quite interesting. But hey, the more the merrier, right? Or sorry, Jack is not here, so the more the better.
More
but
rockets,
yeah,
more better.
The thing is like the only like maybe Orbital Reef is not an exciting future for Starliner, if I may say. And by the way, at least three of these four, I've seen renders of at least 3 of these 4 stations with Dream Chaser on it. So that's probably the big winner. Because I've seen with the Starlab, with Orbital Reef, and with Axiom Space Station, I've seen those renders from like official renders. So they really, like the whole concept of Dream Chaser.
And it's worth noting that the cargo variant, Tenacity, the first one, is at the Kennedy Space Center now, ahead of its hopeful flight this year.
Yep. Not only is Tenacity there, but it's the Shooting Star service module, not trunk, but not a payload adapter thing that's there as well. That
could
thing
describe it
that's
better.
on the back. Yeah, the polyagonal conic thing. Shooting Stars are actually super cool for what it's worth. Like, just in case anybody wondering, those things can free fly, supposedly. That's what Sierra Space has said, that the service module / mini space station can like separate and just free fly, which is actually super rad. I think that's
It's also very on point, because then when it re-enters, it'll actually look like a shooting star. So
yeah, especially because then the other one will actually land back at the launch and landing facility at Kennedy Space Center.
Sorry, you didn't name that thing, did you? Shooting Star?
No comment?
It's funny though.
Chat. Oh no.
It's funny though, because Sierra Space has already toyed with the idea of actually making it reusable. So, like putting like an inflatable heat shield on one end and let it re-enter with an inflatable heat shield. That will be cool. If you can reuse both Dream Chaser and Shooting Star, that will be amazing. But anyways, This is
But for
Starliner
now,
talk.
that's basically a way for them to have a whole bunch more up mass to bring stuff up, and then use the actual the space plane itself for down mass, which would be nice
Mhm.
to have another spacecraft that can actually bring things back from the ISS, not just to it. Which right now, the only cargo
Oh.
vehicle that can do that is Cargo Dragon.
So I have a sec for you.
Uh-oh.
We're talking about bringing things back from the ISS, but I've heard Starliner needs to launch something up to the ISS on this mission.
Oh, I am glad you brought that up. And let me just tell everyone
Because I think
watching,
we haven't talked about that.
you're in for a treat. No story here.
That was a really bad pun.
Oh, and if you don't know why it's a pun, I'm about to tell you why. So, they had to make a change to the cargo manifest on this particular mission. They had to add an additional 150-pound item to Starliner that will be going up to the International Space Station. They actually had to remove these crew packing vessels, as they call them. Basically, they're suitcases with shirts and clothes and personalized shampoo items, basically, for crew members in place of something to fix the urine processing system. For those who don't know, most of the water on board the ISS is recycled. That includes sweat as well as urine. It gets processed through a machine and converted into potable drinking water. A part that they thought was going to last at least until the next Cygnus resupply launch broke down. And so they have had to use their other urine collection vessels, including tanks and bags. Yeah, it's as gross as it sounds. And they're starting to run out. Plus, they pointed out, again, they're about to have an additional 2 people on the station for about a week plus that will be increasing the load on the system and on their storage. So,
oh no.
They literally had to get rid of some crew items and are adding it onto this so that the station doesn't fill up with pee.
Yeah.
I wish I could.
So you-
I was making this up.
So you're looking at I'm looking at actual pictures so we can show it here for Kevin because poor guy has asked us on the back channel. Unfortunately, they haven't really released any pictures of this, and so I'm trying to find them, but unfortunately they don't. There's like pictures of the toilet system and everything, but not of these containers and everything. I guess it's for the better, right? And we don't have pictures of that, but
Probably.
Yeah. I don't know what you're talking about, man. I don't need pictures of that.
Well, I mean,
You could say
we've seen the
they'll pee in a bag and we'll be good to go.
We've seen things of their urine processing system, so it's not, it's not unheard of. They've been using it on station for a while. Every now and
Yeah, it's
then,
kinda
parts
old.
break down, and yeah, they're not just astronauts. They're astronauts. They're repairmen. They're electricians. They're plumbers.
Yep.
So.
Oh my god.
And again, it has nothing
Yeah.
to do with the toilets breaking down. It's just what to do after the toilet is then used with the liquid waste.
I just saw a pun. I'm not. I cannot resist saying this, but man, Starliner must have a leak, but those astronauts shouldn't have one because, my God.
Oh.
Yeah.
No.
I was making that joke earlier of 2 leak
No.
story about, yeah.
No.
Yeah.
Yeah.
So-
I'm glad you mentioned that, Alex. So, and yes, it
Yeah,
is
that
worth
was-
pointing out that this is just the urine processing system. That's the one that is recycled. So we're just talking problem number 1 here.
So you said there's right now they're sending up or they have bags up there to address this issue.
And tanks.
Right? That's Oh yeah. You guys want to hear a fun fact?
Oh
The
boy.
Apollo command service module and the LEM did not have toilets. Not
Oh well,
within
yeah.
the mass.
But
They
that
had
was
bags.
the 60s and 70s.
Yeah.
We're in
Yeah.
the 21st century, man. We need those
Believe-
toilets.
No, you're right. The point that I'm getting at is that yeah, no, it wouldn't be the first time an astronaut's had to use a bag for waste extraction.
I mean, we did have a Dragon capsule, I believe, where the toilet had some issues. I think that was Inspiration 4.
Yep.
You also
True. Yeah.
had, with the shuttle, a fun one, the Peacicle,
Oh, not that.
where literally they would jettison the urine. So there was a good chance when the shuttle was flying that if you saw a shooting star, it could have been astronaut urine. But yeah, they went to jettison it and it froze and stuck to the side of the orbiter, which could have caused a problem on reentry. So they literally had to knock it free with the Canadarm.
Yeah, but ain't no meteor. What you got there is a big old chunk of poop. What? Oh yeah. Call them shuttle bombers.
Yeah.
Got it. Got it.
We don't delve into bathroom humor, but we do delve into space bathrooms.
Yeah. Yep.
So.
Yep.
Yeah.
All
now
right.
let's thank some people after that. Which I don't know why you're crazy enough to support us after that, but
no, you should support more. That'd be great.
Ryan,
we clearly need it.
Getting out from the store
They all
saying
went away now.
saying super excited for Star Week. I like that. Getting it from the store right over Alex's face. Blake Alexander, thank you for gifting 5 Red Team memberships. Will saying there's a gap where Test Patch 3 should have been. I'm not letting this one get away. Fingers crossed for stickers soon.
Yeah.
You guys and the community are just the best. Keep up the good work, everyone. Yeah, we're still out of Patch 3. Still not coming back. Stickers are currently still out of the question, but get Flight 4 while they're still available, because as you've now seen with Flight 3, when they are gone, they are legitimately gone.
Gone.
Angel G, what time are you starting coverage for Starliner? About 4 hours prior to the scheduled liftoff times. That way you'll be able to see the crew with their suit up process and driving by and getting in the spacecraft and all of that. So that would be 7:25 or 8:25 a.m. Excuse me, Eastern time.
Yeah, a little bit earlier.
Central. Yeah. So around that
we
time.
are exactly.
So,
It'll be on our channel, so if you follow us, you'll see it anyways.
Yeah, make sure you're subscribed. It should be, on the channel. You can set reminders so that it gives you notification when we go live too. Coco Cats, thank you for gifting a Red Team membership. Anonymous, store message. I'm guessing this was before the bathroom talk, saying thank you for having these kinds of discussions. I'm not sure you still feel the same way now, but
yeah,
definitely not.
Michael Coviello saying thank you, NSF. Thank you, Michael. RC Horseman, thank you for gifting 5 Red Team memberships. And Austin Skirvin with the tip from tips.nasaspaceflight.com saying, I bet it's a very crappy situation on the ISS right now.
Oh, Lord.
I don't even want to finish reading the rest of that. So, yes, the system will hopefully be fixed.
Austin, that's no, don't say those things. Look at that.
You can read it yourself. I'm not reading it.
Yeah, I'm not reading it either, but man.
Bullet hole shooter.
No, let's not bring that up, please.
Why?
It's not. Because then we'll make you read it.
Oh, I'll read it. I'll do it.
We'll make you read the panel. Go ahead, Sawyer.
I think that's the perfect point to just...
Okay.
Yeah. Let's not entertain that any further.
I mean, we could, but anyway. But you guys don't want to hear about poop. You want to hear about Alex, and you want to hear about Alex filling your ear holes with Starship knowledge.
Me?
Alex? Yeah.
Me? Oh, okay. So I guess it's my turn. Whoa. Okay. Woo. Well, there's been a lot of things Starship related. There's this thing called a wet dress rehearsal that happened on Tuesday, if you remember, after Memorial Day weekend and holidays and all that stuff. So there you can see on my, on my left, the 2 vehicles for Starship's next flight, that is Ship 29 and Booster 11. They have received their flight termination system. Again, that was after a wet dress rehearsal that happened this Tuesday, May 28th. Finally completing the wet dress, because they did another one 8 days earlier, May 20th. And let's say that it didn't look full completely. I don't know, like it didn't seem entirely done. But there you can see that um, I don't know. It's a detonation suppression system test. I'm not sure what I'm actually looking at, other than that. But yeah, so they did the whole wet dress rehearsal test sequence where they went all the way through until the end of the count. There you can see those shots
Are
of
you
the
happy,
tank
Alex?
farm spooling up. Yes, I'm happy. Thank you, Kevin.
There's the
I'm
wet dress rehearsal. I
Thank
I
you.
was trying to fill time, but you moved too fast.
But you know, I'm going chronologically. We had. I
I'm
mean,
sorry,
I
Alex
could go.
talking fast about a topic?
You could playing a talk a lot. I could talk a lot more and more slower. I don't know. But yeah, we had the wet dress this time around. They actually went through the entire thing. There you can see a very frosty booster 11 with a very frosty ship 29 on top, and it's a very slow tilt, to be fair. But yeah, we had that live stream. It was interesting because I was on that live stream and we had a Starlink launch at the same time. So that kind of, from a commentary perspective, the launch happened within 10 minutes of the supposed T0 for this wet dress. So, mentally as a commentator, I was like, okay, I'm on launch day. It's June 5th. Let's go. This is the launch of a Starship. Uh, I wish it would have been the actual launch of a Starship, but unfortunately, it was not the launch of a Starship. That launch of a Starship, as I said, is targeted still for June 5th. We have more road closures and all the hazard zones and everything. They're coming out. It's like a trickle every day or so. We get a few more notices and more hazard zones and whatnot. There's a bunch of places that need to be closed off from air, ground, water. I don't know, space maybe. I don't really know if that's a thing. But essentially, there's like a lot of things that need to be closed off, both for launch and reentry, here in at the Gulf of Mexico and also at the Indian Ocean. So as you can see there, that's a list that we have on next spaceflight. If you type whenhop.com, that can also bring it up because that's an interesting thing as well. When hop without the H on the win, so it will be WENHOP.com. So there you go.
Excuse me.
And if you
When
do
hop.
that, it throws you to that page. So that is essentially the status. Again, we are just with the flight simulation system installed on both vehicles. I'm trying to go through the whole list of things here that we have to talk about. This is a lot of things. The flight safety determination was also complete by the FAA. That was actually last week on Friday, but we didn't know until this Tuesday. That was thanks to Adrian, by the way. Thank everyone in chat. Say thanks, Adrian, because he got that scoop from the FAA that they had that safety determination report, which is another way of returning back to flight and everything. And that's essentially where we are right now. Now we are waiting for the final licensing stuff to come out, essentially the modification to that launch license, which frankly, it can come out literally the afternoon before of the launch, and it still is it's still valid, excuse me, to be able to launch on June 5th. So if it releases on June 4th, it's okay. I've seen a lot of people saying, why are you talking about Starship launching next week? It's not confirmed because they need regulatory approval and everything, and it's totally fair. But if we did that, well, I've got bad news for you because there's a lot of different Falcon 9 launches out there that they are not in their license and they need to modify their launch license. And guess what? We still cover those Falcon 9 launches well before they happen and well before the launch license is modified. That's a thing that not a lot of people know about, and I always bring it up because it's true. Sometimes when they do a new type of mission that is not on their launch license, they have to modify it. And yeah, I guess I went all through everything. Did I forget anything, Sawyer, EJ? If you have anything else, there's like 1,000 different things that have happened.
So just to recap, dude, what don't we have here, like in terms of the keys, keys to the ship, like getting to launch, which is net June 5th, right? Like we have the notice to marine traffic, right? What else do we have?
Yeah, again, we have a lot of different hazard zones. You can see marine hazard zone, temporary flight restriction, notice to admission, evacuation notice. All of those come out eventually. Like, this is not something that I will personally be worried about, because it is something that just it's like a trickle, right? One day you get
Yep.
one
Okay.
kind of zone, and at the end of the day they all need to come out one way or another. I will worry more about them coming out for a different day, for example, which can happen. For example, if for whatever reason SpaceX were to delay beyond flight, beyond June 5th, we will probably either hear it directly from them, or if not, we will find out because one of these hazard zones has either either a new one has appeared for a later date, or it's just that one of the existing ones has been canceled, and then they have replaced that with a newer one that is later into the month. So for example, I will worry more about the existing ones or any of the new ones being targeted for like a different date, rather than, oh, this is a very critical thing. Of course it is critical, but it's always completed well before the launch happens. The one that we are looking for that is really, in everybody's minds is the FAA launch license modification. Again, that is something that needs to happen. Now they can actually get it because they have that flight safety determination. The only difference now, obviously, is that they also need to make sure that they still comply with all of the licensing requirements. And this time around, we know that they have the landing of the ship.
Yep.
In previous occasions, in previous flights, the plan called for the ship to just smash against the ocean, so to speak, at terminal velocity. Now they're going for the flip and landing burn. So there's probably some changes as well there on the regulatory side of things. Perhaps maybe an environmental assessment of what it entails, because that was sort of included on the one for Flight 3. Flight 3 had one of these, read and re-evaluations that they do for the environmental assessment, to include that they were landing on the Indian Ocean. But you never know, right? Like, maybe they really need to look into it. We never know until it's actually completed. So once we actually get to the point of getting to the launch license modification and we see all of this documentation, maybe we'll be able to know more what sort of scope of paperwork they needed to do. Sometimes there's a lot of things that they need to go through.
Now, here's the real question. How far do you think this thing is going to get into this campaign in terms of flight? Sawyer, you think it's going to make it all the way to the flip and burn?
To the flip and burn? Yes.
Yeah.
Past the flip and burn? That's another story. We haven't, like we were talking about on the first countdown to launch, which there'll be another one tomorrow. They haven't done the flip and burn with the Raptor V2s yet. Everything was going back to the early SN days. We saw SN15 was the last real flip and burn, basically. So I don't. Maybe there's some changes to center of mass, center of gravity that they might not account for with the extra power. That part I'm not sure, but I think with all of the extra things they've now taken into account so that the vehicle doesn't kind of tumble out of control and the part that's supposed to actually hit the atmosphere hits the atmosphere, I think they'll be okay.
Yeah. Do you think Super Heavy is going to do the fake catch correctly, or hit the water going supersonic, or at least pieces of it hit water going supersonic like last time?
I mean, yes.
Yeah, you think it'll make it?
No, I don't know. I was saying yes to there. I think we'll have a better idea with the burn. I could see that first burn actually working with all 13 engines. Beyond that, for the actual touchdown portion, I don't know why. My gut vibe is that they're gonna either run low on fuel or there's gonna be another clog in the lines, unexpected, that cuts out more of the engines than they expected on that last burn. I think they're going to make it for that entry burn, so to speak, but not the landing burn. I hope I'm wrong.
Yeah, right? You always... Yeah. What's up, Alex?
There's this weird guy in chat called Jack Bayer who says, do we think the launch license mod for Flight 4 will also include Flight 5, excuse me?
Alex, I don't know. I'm not sure. Do you think it will? I mean, it's been on a case-to-case basis thus far. You think we'll get a blanket for 4 and 5? That's a tough one. Jack, why'd you do that? Why are you doing this to us? What the heck, man?
See, the
Don't do
thing
this to
is,
you.
it could go both ways, right? It could go both ways in the sense that it could go as, let's just do flight 4 and we'll deal with flight 5 once we get there, right? It's something that, because if you think about it, having it licensed for 2 flights, it kind of sounds like it's probably more complicated. I don't know if to you guys, like 2 flights instead of just one might entail more paperwork and probably not changing plans at last minute on your fifth flight. Hi, Das, by the way. He's not live, but
What's up, Daz? Wait, he's not here. Oh.
but yeah, this is the video that we put out for ahead of flight 2, because we started seeing all of these usual headlines of, oh my god, flight 2 is going to happen next week or whatever. This was in September. Flight 2 didn't happen until November, by the way, just so you know. So we make this video because a lot of people were confused, when is the flight happening and all of that. And so we made a whole video just to so people could know what are the things that we look out for in terms of node temps, node Mars, and all that jazz and everything, to make sure when the launch will happen. And so that applies to not just flight 2 but also 3, 4, and whatever other things, other flights might happen in the future. And speaking precisely of future flights, we're talking about flight 5 and flight 4 being both at the same time on the launch license. And again, I don't really know. It could go both ways. Again, having both kind of sounds to me that there's probably more paperwork involved, but also at the same time, SpaceX may want to clear Flight 5 already out of the way so that they can go through directly, like quicker turnaround in terms of the paperwork. But also at the same time, it will probably make them decide on a plan for Flight 5 already, right? And I don't know, maybe they fly these 4 flights and they're like, we want to change what Flight 5 is going to be all about. And then, they need more paperwork, they need to change the license again or whatnot. And so, yeah, I don't know. We'll just wait and see as usual. And that's essentially my answer to all of this, my really long answer to
Yeah,
all of this.
I think
I'm
as
a fan of
often
the
as the flight changes, I mean, heck, even just the what we've seen from Flight 3 to Flight 4 now with the flip and burn and things like that, they've made such large changes, and also they technically haven't had a fully successful flight that went exactly according to plan yet. I think they're still going to do the one at a time for now, but I think it's going to be a lot quicker between launches that they now give the approval. That would be my guess to start, and then further on, maybe they'll start adding more, or it'd be like, say, Flight 6 and 7 type approval. But I think for right now, it would make the most sense to just take it one flight at a time. But the more they do it, as we've seen, the quicker they'll get, hopefully, at the approval process.
Yeah.
Yeah. I'm kind of with you guys. I mean, I don't think it's necessarily, like, nothing's out of the realm of possibility, right? With a blanket launch license for 4 and 5, but I don't see it happening. I mean, for the straight reason, like, Flight 4 is supposed to be a propulsive landing out of the ocean. Flight 5 is supposed to be a catch, where wherever that may occur. Catching tower, no, yeah, spicy, no, yes, maybe. Who knows? I mean, it's a different flight trajectory. It wouldn't make sense to do a blanket license, but hey, they've done blanket launch license before during the Starship flight testing that we saw. So too bad that SpaceX didn't fly the things that they blanket launch licensed. They scrapped them instead. That's kind of the opposite of what we wanted to see. But hey, the design changes. It happens.
Ironically, that was actually because that was for SM-15, they had 15, 16, and 17 approved for flight. It was like a blanket license kind of thing. Ironically, that was the last time that I guess a Block 0, if you will, vehicle launched. That was the non-orbital Starship. Then we went to Ship 20, Ship 24, 25, 28, and now we are on 29. The next 2 vehicles, 30 and 31, are supposed to be Flight 5 and Flight 6. Maybe 32 will fly. We don't really know. There's a good chance, essentially, that 30, 31, and 32 are scrapped, and they go straight ahead with version 2 of a Starship. Like, that's a real possibility. If this flight goes so well, there's a possibility that maybe Flight 5, could not be. I'm not saying it will, by the way, just so I get ahead
Yep.
of Chad. I'm not saying it will. It's just that knowing SpaceX, there's always a chance that some vehicles may be scrapped or leapfrog for newer variants, newer and better vehicles, and so I don't think it'll happen for Flight 5 though, because it's probably too early, in my opinion. We haven't really seen a completed Starship version 2 in the first place. But I think maybe, for example, Ship 31 is probably like Flight 6, essentially. It's probably in danger. Sparky,
Yeah.
exactly,
Sparky.
right?
I'm
Sparky
giving it
is
that
in
name.
is in
That's
danger.
it. That's its name now.
And then the armless ship, I guess it's the or rather flapless ship, which is no, I'm not talking about 26. I'm talking about
okay.
Another one that is 6 ships after that, which is 32. I say it's flapless, but it actually has the forward flaps, but it doesn't have the aft flaps. I guess sort of like a weird mix. But yeah, that one, it's not even completed. Like, they just stacked it and put it out in the rocket garden, and they haven't really done anything with it other than, I don't know, look at it and maybe say whoa passing by, but not really anything important with it. Whereas 30 and 31 have actually gone, some work done. They have tested ship 30. They tried to test 31. So yeah, there's a good chance that we see some of these vehicles being leapfrogged, to be fair. So yeah.
I mean, technically, they
we'll see.
tested it.
They tested something. I don't know what the result was. I don't know. Got a little hot.
Yeah, and I was waiting for the stinger and the music. I'm glad it's.
Oh, come on.
There it is.
Kevin, I hope you forget to plug your phone in before you go to bed tonight and the battery dies when you wake up in the morning.
It's even funnier that the stinger didn't come up on screen.
He will actually be very afraid of that, because I think he's operating tomorrow's Starliners live stream.
I hope you step on a Lego.
And tonight's
It's probably
Starlink.
not a good idea for me to miss tomorrow morning's stream or tonight's stream. So that's a bad idea, EJ.
It's not a bad idea. I just wished it upon you. It's different.
I know. Now it's going to happen. And then everybody's going to be upset because the Starliner stream's going to go live late.
Okay, you can blame me if it's late.
Come on.
But not too late. Yeah, exactly. I was gonna say if it has to be a certain threshold for tardiness here, and then you can blame me. But up until that point, it's still your fault.
Jay's already volunteered to steal the job from you.
There you go. Jay says he can handle it. Oh God, no! Stop it! Stop it! It's sucking my will to live.
First off, I love how that still just goes to a black screen before it transitions out. And second, what is the name of that song? Now I want to know.
Oh, I don't.
It's I Feel the Love.
Oh gosh. Okay.
I just feel the hate when I see.
I feel something, all right. Yeah.
Let's not talk about that. Okay, moving on.
Okay.
Oh, dear Lord.
It's in the queue. Do we have anything in the queue?
Yeah, let's go to support, because
probably shouldn't have had me host this.
26 is like a really, really edgy kind of vehicle, right? Because it's like
I hate it.
No, not a lot of people like it, but then somehow people with really bad taste like it for whatever reason.
Yeah, I know.
Yeah, seriously. Paul Kruger is saying here, assuming that ice is clogging things in the booster on landing burns, how do they resolve that issue?
Good question. Good question. Can I take this one, dudes? Is that cool?
Go for it, EJ.
Go ahead.
All right. Well, SpaceX is having problems, particularly with Super Heavy. At least that's what they said was the cause of some of the engines not relighting after most engine cutoff, or MECO for Starship. in case people don't know, Starship uses a hot staging method of staging where for a split second, 3 of the engines on Super Heavy are activated at the same time that 6 of the engines are activated on Starship, and then it separates. It's not what you see with Falcon 9, where, you get a distinct stage separation, and then second stage engines start 1, and then you're good to go. The reason why Starship is doing that is for, a plethora of reasons. One of the big ones being mass. This is the simplest way to stage a rocket. The Russian counterparts have been Roscosmos have been using a hot staging method on Soyuz and previously Voskhod before that, and the R-7 Semyorka before that since 1957. So hot staging works. It's a very simple way of doing things, and so because Super Heavy shuts down 20 engines, 30 it's 30 engines, right? It's just 3. They shut down 30 engines, and then they relight 10 of them after it's separation, after hot staging, separation, and burn, right? Some of those engines have had trouble relighting, and because of that, that basically completely screwed up on IFT3. That completely screwed up their landing burn. Amongst other things, booster it exploded 420 meters off the ground. There's that number again, and what was left of it hit the water going Mach 1 or somewhere in the transonic regime, which that's a really cool way of saying there's nothing left. You're probably never finding a piece of that. So during this relight, you get solid oxygen. SpaceX cited the reason why these engines didn't relight is solid oxygen being built up in the lines clogging the filters.
Did they say
right?
solid oxygen, or I believe they just mentioned like a general blockage on the oxidizer lines, but they didn't say exactly what
that's
it
probably
was.
me. Yeah, that's probably me presuming a little
Yeah.
bit. Now, okay. So let me rephrase that. If I had to guess, it's probably solid oxygen. That probably comes. If I had to guess, this is a big guess for me. It probably comes from the type of fluid turbulent flow that you get from a vehicle with very complicated plumbing. The N1, the failed Soviet lunar rocket, had this same problem. They had problems with filters getting clogged from, they said FOD ingestion, and I believe with the N1 it was a bolt or something coming unstuck. Now, I don't think that SpaceX is having those kind of problems, like I said, which is why I guess it's presuming that it's solid oxygen probably is a little bit of a stretch. But what else could it be? It's not like some guy's peeking his head in the tank before they fuel it and you go, oh yeah, that bolt's loose. Yes. So, how are they going to deal with it? I don't know, man. There's plenty of ways to deal with that. First of all is adding more filters. The filters can liquid flowing through these pipes really, really fast is a lot more complicated than one might think. You're gonna run into cavitation and turbulence a lot faster. Than you think, because think about the turbo pumps and the fluid impellers on Raptors. Even it's not 33, but even 13 of them on that relight, that's moving enough fluid to drain an Olympic swimming pool so fast that you would actually be able to see the water level go down. It's a lot quicker than one might think. So, there's elbows in these pipes. There's bends in the pipes. There's flexible parts of the pipe that are designed to deal with thermal contractions that you get from moving cold propellants through it. All this can create, temperature changes that could solidify or it could evaporate propellants. And once again, I might be presuming, but if I had to guess, it's probably one of those things. It's not like SpaceX had some foreign object debris or FOD sitting around in these tanks. The tanks get cleaned before they, before they send this thing out to the pad, well before that. So, yeah, that's my guess. You can, and keep in mind that these filters aren't just for blocking stuff up that you like blocking up FOD or bolts or nuts or anything. These filters are also there to keep the flow, keep the liquid propellants or the commodities in laminar flow to prevent what I'm talking about from happening. Think about it kind of like it's trying to keep the propellant uniformly going through the pipe, which doesn't happen when you have elbows in your pipe. If you have a pipe that looks like a Z, the water's going to move around, and if you have 290 degrees, the pipe's going to move around, and the water's going to move around in the pipe like a water slide almost. It's going to slide back and forth. You definitely don't want that happening with propellant transfer from the tanks into the motors. So yeah, if I had to guess, that's what's going on. It's basically installing more filters on this. It could not just be for ingestion. It could be for changing the flow of the propellants going in through the plumbing into the motors, because you definitely don't want anything solid hitting that fluid impeller. I mean, I don't know. Engineers aren't, the names for engineering equipment and stuff is usually pretty straightforward. It's called a fluid impeller, not a solid impeller. It's not a snowblower, right? So you probably want to make sure that nothing gets to the impeller. So what's the impeller? Just in case anybody's wondering, that's the pump. It's the pump that moves the propellants pulls the propellants from the tanks and puts them into the preburner, and then downstream somewhere you get an explosion, and the explosion comes out the bottom, right?
Why is
That's
that not called a
very plain way.
propeller?
Yeah, that's a good see. Engineers are not good at dealing with customers.
Yeah. So
With different conclusions you can jump to.
Yeah, one of the issues that I have with the whole thing, apart from SpaceX not really saying what is actually blocking the things, which is, it will be so easy for them to say, "Oh, this is what is blocking our stuff," right? This is really what is being an issue. Apart from that, one of the things that I've sort of paid very close attention to is that this is something that has happened on flight 3 and flight 2 essentially, and both times it has happened on the oxidizer side of things, essentially on the auction side of things. And there's this thing which you can see there, that's actually for a ship, and it's very old. Like, you can even see the old NASA Spaceflight logo on the corner and everything. This is from an old daily video, but you can see more or less, if we can pause it, or there, maybe there, if we can pause it there.
Yeah, see,
So
there it is.
this is the methane sump. So essentially you have the two main tanks of a starship. There's the methane tank on top, and then the oxygen tank at the bottom. And so in order to get all of your methane, excuse me, because I have, I think, in my eye, but there we go. In order to get your methane to the engines, because they are at the bottom, obviously, you need to get this big transfer tube through the through the oxygen tank down to a manifold that distributes all that to the engines. And there's this thing that it's called an anti-vortex device that what does, it literally says, says it in the name, it avoids a vortex as you drain that methane. You don't want a vortex created on your sump, because then you can suck in some of that ullage gas into your transfer tube, and you don't really want that. Falcon 9 has a very similar device as well, and it's some kind of AVD, they call it, anti-vortex device, and it not only helps with that, but as you can see, it has screens on it. So there's like these little filters on it that allow them to be able to filter any debris, any sort of ice or whatever it's there, it gets filtered. And so whatever, all of the methane that goes through, it just goes clean through the transfer tube and into the manifolds, and everybody's happy. Meanwhile, on the oxygen tank, there's no such device, because the engines are attached directly to the dome, on the aft dome of the ship. Well, we're talking about the booster. On the ship, they are attached to a puck, and then the outer vacuum engines, they are directly mounted to the dome. What I'm getting to is that there's a smaller path from where the tank is to where the engine is. So you have a lot fewer chances to have all of these screens and debris, uh, avoidance kind of hardware. You cannot have all of those filters and all that stuff, or at least have a lot of that when you have a you know an engine that is directly mounted to the tank. Essentially, you have a lot of less time for you to be able to put that hardware in. So this is one of the things that really struck me with this whole thing with it, which is like, why is it happening only on the oxidizer side of things, and why is it not happening on the methane side of things? There's that. And then there's also the favorite of the internet, which is Raptors don't have heat exchangers. They use the pre-burner exhaust. Now, there's no confirmation of that, but it will also potentially explain this when you think about it, where you have the methane is already heated up by the nozzle. That's a thing that you cannot really remove from your engine, because that's the coolant for your engine. Whereas on the oxidizer side of things, you really do need a heat exchanger in order to be able to heat up the oxygen and make it gaseous to then put it back on the tank. They use, again, for those that may not know, they use autogenous pressurization, where you put the gas of that propellant inside of the propellant tank. So the liquid oxygen tank has gaseous oxygen on it, and the liquid methane tank has gaseous methane on it. And the way to do that is you use the engines. They are hot, and so they can provide your energy to heat up that liquid to a gas temperature, and you put it back on the tank. So again, this theory says there's no such thing as a heat exchanger for the oxidizer side of things. You can get one for free on Raptor for the fuel, because again, it is used for cooling the nozzle and the thrust chamber and everything. So you already heat up the methane one way or another. So you can just tap it off from the cooling lines and put it back on the tank. You don't really need a specialized heat exchanger. But again, for the oxidizer, you need it because you don't use it for any coolant. The theory is, instead of doing that, they just tap off the pre-burner, the oxidizer pre-burner, and put it back on the tank. That could be a possibility. We don't really have a confirmation of it either way, but it would explain perhaps the blockage by saying, if this were the case, you will have as subproducts on your heat exchanger, not heat exchanger, excuse me, on your pre-burner, you will have oxygen, CO2, and also you will have water. And that CO2 and water could, in theory, precipitate as a from gas in your tank. It gets cooled down by the liquid, and so it just forms like an ice on your liquid. The water will be floating on the liquid oxygen, but eventually the CO2 is actually in solid form. It's actually heavier. It's more denser than the liquid oxygen, so it will essentially go all the way down. That could be a problem for your filters at the bottom of your tank where you have all of those engines there. That's a potential explanation that I've seen put out there. Again, we have no confirmation, right? But we're talking about different possibilities here, and one of them, again, it's
off
like
the cuff, dude.
exactly what and the fact that it happens on the oxidizer tank, and then there's this other theory. It's like, maybe we don't really know, right? It will be so easy for SpaceX to just put out like 2 lines. Oh yeah, it's this, what Block said, right? It's like, but unfortunately we don't have that luxury. So we have to resort to different theories and whatnot, and what might be happening there. I guess at the end of the day, what they really need to find out is what is actually causing the issue. Like if it is the pre-burner exhaust or whatever, then maybe they need to reintroduce a heat exchanger. Who knows, right? Or maybe if it is debris, maybe they need more cleaning. If it is solid oxygen, maybe they need more modeling, essentially removing altogether the source of that blockage. So eventually boosters are not just a big filter with some fluid in it, right?
I mean, it wouldn't be the first time. There are other rocket engines with heat exchangers on them. The RD-170, RD-180, they have heat exchangers. They have heat exchangers on the pre-burner side of things. They're there. It's not the craziest thing to think that they might do something like that. But yeah, I mean, at the end of the day, you're dealing with the real estate of shoehorning, or the space, like the volume of shoehorning 33 Raptors up in there. Anything that you put in there is going to be complicated, and there's going to be some unknowns here and there. I mean, I'll be honest with you guys. The fact that we, for IFT2 and IFT3, we had a sequenced 33 engine ignition and basically a clean burn all the way to most engine cutoffs. That's impressive in its own regard. Like, I mean, that's really difficult to get something like that right. Is this an Earth temperature problem? No, Hoff. I mean, not really. I mean, considering where they're having that restart problem, right? Like they're having the restart problem during relight for boost back. So, I mean, Falcons Maze in chat actually pointed out a second ago that this problem is happening most likely from an engine shutdown. changing igniting engines isn't like just in KSP just hitting the go button, right? It's not like that. It's a little bit more complicated. Anytime you're putting an engine through a startup, you're changing a lot of things really, 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 really fast, and engineers don't like that. They're not good at dealing with customers. No, you're going through what's called transients. You're changing a lot of things super fast. And this is even more on top of that because you're shutting down 30 engines, right? And then you're keeping 3 engines on, and then immediately after that, you're relighting 10. Like,
And all of that while you're
like
flipping.
Yeah, well, the thing is
you're
moving,
also
right?
Going back,
Yep. Yeah, it is a complicated thing going on here. So yeah, I think Falcon's Maze in chat is right in that regard. I really think that it's probably something from shutting down an engine and then restarting it immediately. Because normally, right, what you do is you thermally condition engines. I see NASA Spaceflight over there in chat talking about the RS-25. Yeah, you'd have to thermally condition the engine.
That took 2
Now, when you're
hours.
shutting it off, right? Yeah, exactly, right?
That's a really complicated engine to thermally condition.
Exactly. It takes time to chill down the engine. This is a chill down sequence that, shut down and then a chill down and a prime and then relight that happens in like what? I don't know, 5 seconds. And it's with 10 engines, right? So like, I guess what I'm trying to say is that it's impressive that they've gotten this far this quickly. And I really don't think that whatever the filter problems, whatever the blockage might be, due to turbulent flow or cavitation in the pickups or whatever, I don't think it's so much a unsolvable problem, right? It's very much something that you just got to figure out. And that's what SpaceX is all about. You test something, you fly it, you learn something from it, you figure out a new problem with it, and we got another problem. All right, just smash that problem, move on to the next one.
It might actually explain why, they decided this time around to ask the FAA, hey, can we return to flight even if we don't have the mishap report completed? Because it might very well be that they are just, wanting to get data from this flight, from flight 4, to completely finish that report, right? That could be a thing where they're like, we need a little bit more data from flight, so we really need, to actually test these all of these solutions during flight and see if they actually work. One thing that I saw in chat as well, about putting the pre-burner exhaust back on the tank. It is something that sounds crazy, but that was actually done in the past. I cannot remember exactly which rocket was, but I do know that one of the early European rockets, I think it was maybe Ariane 1 or 2, I don't know. It was very early on in the European spaceflight program, I guess. They used the pre-burner exhaust and put it back on the tank to be able to pressurize it. So this is not a thing that, it was obviously a different fuel though. That was, I think it was hydrazine and nitrogen tetroxide. So it was a different mixes of fuels and everything. So it was probably a much safer mix to put back on the tank, but it is not unheard of to do that on your rocket. It's just not been done at this scale. So that, that also will have been quite a complicated thing. We also saw, for example, during the flips, they had issues maintaining pressure on the header tanks, for example. Even with SN15, they had lower than expected pressure on the header tank, which, it was not an issue at the end of the day because the ship was able to land and everything, but they were still having that issue, right, of having lower than desired pressure on the header tank. So the whole thing of keeping your propellants in the good, we've flown rockets that go up in just one direction for a long time, and it's only being very recently where we have rockets basically doing gymnastics in the air with those hops and all of the flips and everything. And then you have Falcon 9, for example, but then again, it has much more stable propellants. You have RP1, it's a more simple engine. It's a gas generator. You use more conventional, pressurization like helium and things like that. It's a lot simpler in a lot of senses, right? So it is true that they have that experience, but it's not one-to-one at all with Super Heavy.
Yeah, man. Yeah, this is, whenever you're blazing a new trail in aerospace engineering, like whenever you're trying something new, A, you're going to get a lot of people saying, no, that's not possible. We've seen that a lot with SpaceX. And B, these challenges have never been tried. Part of the reason why SpaceX favors iterative design, because they are way into uncharted territory with this vehicle. I'll tell you that. Now, chat, I'm wondering if any of you guys have any questions. And to do that, I'm going to go over to Sawyer with the weather.
Sawyer!
Yeah.
Oh, I'm still here.
That was
Hi.
good, right?
Oh,
The weather is
there's my
cloudy.
bot.
See?
Weather. It is. I don't know. My blinds are closed. So it is weather outside. Yes.
Yes, it is happening.
I do want to hit the support queue first, and then I've got a couple questions that are some really good ones.
All right, let's do it.
Kenneth saying, see you guys down in Texas next week, flying down Tuesday. Safe travels. We've got Mr. saying, thank you everyone at NSF, all the back of house lever pullers, photographers, writers, and hosts. Love all your hard work. Thank you. And thank you for getting items from the shop as well. Musical Wolves, will Starliner need to line the Starlinks for Starship for OFT4?
No.
Don't think the stars aligned for that one, sorry.
Dang.
That's the starception, I guess.
And then Music Wolves also saying, where will the cranes be on launch day? Not near the launch pad, I would hope.
Yeah.
Oh, that's a shame.
I
like.
Here's a good question, though. While we were talking about the landing portion, I still want to kind of stick with that for a second here. Bob Fillmore is one of a couple of people asking this. If it soft lands, will the booster and/or ship be floatable with empty tanks? So basically, what's going to happen to them if it actually does successfully make it down?
Dude.
Well,
I don't know. I mean, we saw Falcon 9. Nobody thought Falcon 9 could soft land in the ocean intact, but yet GovSat-1 and CRS-16 both did exactly that. CRS-16 to the point where they just towed that thing right back in the port. CRS-16, for the people that don't know, is booster 1050. A grid fin valve got stuck, and it started spinning out of control, and it diverted into the water. And it did its propulsive landing over there. And it was spinning like crazy, and then the landing legs deployed, and the increased moment from the leg deploy actually dampened out the roll rate, and it landed perfectly upright and then fell over. So, I mean, now keep in mind, Falcon 9 is not Starship. Those are very different rockets. But I mean, I think it'll float. Now, what are they going to do with it if it does? I have no idea. Blow it up? Maybe.
Well,
Alex, what do you think?
we have already seen paperwork that apparently they have no intentions to recover Super Heavy or even Starship, and so their plan is just to open the valves, essentially command the valves to open on all the tanks and let it sink. If that were not to be, successful or anything like it, then they have the other option of activating the flight termination system remotely. And if that also doesn't do the work, then they can shoot it. They actually have that option as well, like the complete remote option of just shooting it. They don't really want to recover it, pretty much because of the fact that while CRS-16, yes, it landed and it was towed back to the port. First, it took quite a while to actually get through all of that. The Port Canaveral chief, I think, they were not wanting that thing going in until they made sure that it was fully saved. I've heard stories essentially of Port not wanting that thing to come in, and also it was very close to the shore. It was like a kilometer and a half, maybe like a mile and a half, or something like that. It was not very far away from shore, and it actually took like a couple of hours to, once they actually started rigging it and pulling it to port, it took a couple of hours to get there. This will be at the very least 20 kilometers offshore. This is like 20 times the distance. It is not as easy. And it's much, much larger. It's 70 meters tall, 9 meters wide, over 200 tons of mass. there's no incentive for SpaceX to really recover this and trying to bring it back. There's not really anything. What they can do is, if there's any floating debris or anything, they do have part of their environmental assessment sort of deal is that they will recover any floating debris. So maybe a COPV or something like that. If that floats, then they go out and recover it. In fact, I I cannot ask for anything right now, but we have Gav, our own boat guy, I guess. He already found that Go America is, I think, the boat went out there, so it has gone to Starbase to support this launch. So every launch they have like this little boat, little, a decently sized but not big boat that goes out and actually, is part of all of these things of going to take a look at the debris and everything and supporting those recovery efforts of whatever pieces are floating and everything because it's part of their environmental assessment, right? So if they don't follow those rules, then they're not. There we go. Thanks, Adrian. But yeah, the whole deal with that is that it is a very important thing for them to do so that they can keep complying with all of the um, environmental rules that they have.
Yep.
There you go.
Yeah.
Go America.
I mean, unless I saw a lot of people in chat say Navy target practice. I for one am here for this. As long as we get to see it, like I want to see just, that'd be sweet. Explosions are pretty awesome.
I just
like
love
those.
that the ship that will shoot at this rocket is called Go America. Like, come on.
How appropriate.
Poetic.
Go America. Maybe we shoot it. Go America.
Yeah.
Coming again to dispose of the booster. America.
Heck yeah.
I love that you made it
Oh,
PG.
boy. Yeah.
That's totally how it goes.
That's exactly how it went.
It's obviously big rockets, guns, and shooting things, right? Like that's the whole deal with this boat.
Yeah, I love how though it's legitimately in
there
the
you go.
paperwork from the early days that they put it in the paperwork of if it doesn't sink, we'll go shoot it. That it's legitimately written in official documentation.
But
Which,
yeah.
along those lines, though, I've been seeing this question, and it is a really good one. Six String Simpleton saying, does that mean when they say that FTS is safe, that it can be unsafe?
Yeah, that's generally a one-way system, but that's with Falcon 9. I don't know. Sawyer, have we seen them save the FTS with Starship? I think we have.
We've heard them make a call out.
Yeah. So that means that they probably could.
How would they use the FTS then to sink it if it's safe?
Well, that's the thing that
change it.
Yeah, they can just send a command. The thing with the flight simulation system during flight is that it's completely automated. But in theory, they can send an override command and actually, activate it if they really wanted to. They don't have it though. Like the whole purpose of it being automated is that there's no such thing as someone in the ground with a big red button that they have to press. That's sort of I've seen people being like, but for sure they must have like a manual override from the ground, like a really big button that they press, and it's like no, because if they had that, they will also need like this big team of people that need to track the rocket. All of that big team of people, they don't need that anymore for Falcon 9. By the way, we have here a Falcon 9 booster being tested at McGregor. And so, for Falcon 9 at the very least, they can save a lot of money and a lot of time. And those, fast turnaround times that they do between flights, precisely because there's no team of people and no guy with a big red button pushing on that. But there's obviously a way to obviously override if you really wanted to do that. And, on Starship, they have that option of activating the flight termination system if they want to. You just send a signal.
Yeah, that was actually a super good question. Now I'm sitting here jogging the noggin trying to think about this. I'm like,
But
jogging the noggin, I like that.
What will happen to the ship,
man?
What about the ship?
Target practice.
Because the ship is like all the way around the globe in the Indian Ocean. Have we seen any vehicles, any boats, anything?
Well, like I
Starlink
said,
Command?
They should send an A10, right? And use it
Yeah.
as a target practice.
Wait a minute. The A10's Air Force, okay? All right. I think the Fifth Fleet could do with some target practice. Just keep them sharp. Where are my squids at? You know what I'm talking about.
No, it's the sharks with the lasers on them. That's what it is.
Someone say
Hey, they might
should
have
send
that,
ULA.
dude. You don't know.
The ULA sniper, yes.
Yes.
Oh, no. Oh, dear.
But yeah.
We've reached that point in this stream.
It's a great
Yes, we
question.
have.
I actually, ahead of this stream, I actually read the paperwork for Flight 3 that said all, it said all of the stuff about landing the ship in the Indian Ocean, and it has this little portion about the soft landings. It says that they expect it to sink, apparently, that for whatever reason they don't think it'll remain afloat. But you never know.
But also, Flight 3 didn't have the flip and burn. It had the idea that it was
Yeah,
going to
yeah.
crash at almost terminal velocity.
Yeah, so on Flight 3, yeah, the paperwork is for both. So it essentially just talks about the landings in the Indian Ocean. So it has three options. One of them is there's actually no landing at all, like not even a try to get through reentry. The ship is completely expendable. And Kevin, now it's your turn to go to your favorite ship, because that's the kind of ship that will do that kind of reentry where you just not even attempt to go through the atmosphere, you just break it up, but it's over the Indian Ocean instead of the Pacific Ocean. The other option is what we expected for ship 28, which was it goes through the reentry and then it smashes the ocean at terminal velocity. And then the other option is what we're hoping to see with ship 29, which is it goes through reentry, it goes terminal velocity, but then very close to the ocean, it flips and lands. And so for that one, they say they expect it to sink. And ship 26, of course, yes.
Oh,
Whatever you
now they
wanna
can
say.
clip you saying that.
Yeah, sure. Yeah, clip it, and there, you have it. Make a video out of it.
Someone will. That's the scary part. But yeah, no, it'll be interesting to see what they end up doing with it out there, unless it's just one of those where it's like it's so out in the middle of nowhere that eventually over time it'll just sink, and where it sinks, maybe.
Yeah, that might be. It'll just sink, I guess. That's what what they think. They think it'll sink. Whatever.
Oh, no.
Hopefully
No.
you don't have a sinking
No.
feeling about it actually
Oh,
working.
I knew it. I knew it was coming. Ah! Saw it coming, chat.
And it's funny because it's not even the correct word. The correct word, I believe, is scuttle. But yeah,
We'll scuttle the ship.
there you go. Or from Connery.
Right now, Captain Tupolev is removing the
Anyway.
safeties. on
Anyway.
torpedoes.
While we're
Let's
talking
keep the
about
questions coming.
while we're talking about the ship, here's one from again Six String Simpleton with another really good question. What's the current condition of the tiles? Last we saw, there were still a few bare spots on D-Stack.
They look better.
Hmm.
I think they have already completed a lot of that work because I haven't seen them working again on the tiles, so that might be a good sign.
I
No,
mean,
EJ, you're actually out there. I can see ship 29 behind you.
oh yeah. Yeah.
There you go. Can
you know,
you
going
report
on.
us on the status?
All right,
of
yeah, here,
ship
let me get my
29?
binoculars.
There you go. There you go.
Okay. So what I think's going on here is that, I think it's much more important to SpaceX to get, some orbital launch capability here and just get the ship up there in one piece and, maybe back down with a reentry. But I don't honestly think that the tiles are in the critical pathway right now. So, we might see, I mean, don't get me wrong. It's not like they're not going to work on it, but if it makes it through reentry, remember Elon said for this next mission, it's just getting through peak heating relatively intact. Like, if they get through there, that's, the flip and burn is playing with house money at that point. And I know people are going to look at me funny, like, what do you mean the thermal protection system isn't part of the pathway? Well, think about it. Who's SpaceX's biggest paying customer for Starship right now? It's NASA. It's HLS. does HLS, does anything that is required out of SpaceX's architecture for HLS denote reusing a Starship? Right? So let me phrase that a little bit of a different way. Yeah, right. But yeah, I mean, if we have a Ship 26 clone up there with a tanker or depot or whatever, right? But theoretically, you could do this with expendable starships too. Super Heavy is the thing you need to get back. That's the most important part. And I think that's why it's not that big of a priority. I mean, don't get me wrong, SpaceX is working on it. I think SpaceX has enough of an industrial capacity to be able to solve two problems at once. I'm pretty dang sure. But, even Elon himself has said, like, hey, it's just about getting the thing through peak heating. He says, the landing is...
Is that how Elon talks?
I think so. Maybe. Yeah, definitely not.
There weren't enough
Anyway,
memes in that sentence to sound like Elon.
Continue, sorry.
Oh boy. So yeah, no.
You just put a voice, and I was like, "Is that Elon? Is that EJ
Yeah.
imitating Elon?"
Yeah. No, definitely not. Mountain. Anyway, so I think even if we see some tiles, maybe hopefully they don't. If we see them come off during ascent, or you don't see the thermal protection system like completely perfect, I don't think it's like that. It's not the highest priority. I'm not going to say it's not a priority because they're there. Obviously, it's a priority, but it's not the highest priority, right?
Yeah. I mean, at that point, I think that would just be a win to get it stable upon reentry. If we can, if we can see where it's not flipping and rotating and all that, and it's actually belly down, that would be great. And given what we saw with the cameras on the flaps on the last one, I think even if the vehicle doesn't make it all the way through, they'll still get a lot of good tile data on the ones that are attached. At least I would hope. And more importantly, the ones, if they stay attached all the way through as well.
Yeah.
Yeah.
We always...
So, yep, go ahead, Alex.
I at least see, the usual comment of like, oh, why is it that, they're so worried about the heat shield tiles, and why don't they put it on a second stage of Falcon 9 or something and just make it re-entry? It's like, it's not about the heating problem. It's not like they don't know that the material will survive or not. It's actually about the whole complete system surviving or not. That is something that Elon talked about, and in his comment on social media, he was saying that it's not even just the whole thing of re-entering, but also being reusable and rapidly reusable. Essentially, you can just reuse it again rapidly. I guess it's there in the war, right? Essentially using it quickly again. That's the whole deal with a Starship. And right now it's like, yeah, let's get it through max peak heating and all that. Let's get it through all that, and let's see what places we can optimize it. I always see, and again, that's those comments are fair about why are they going with tiles and not going with anything else. And I always say, look, right now they're trying to figure this out, right? There might be a point in the future where they figure out that maybe this was not the best choice, and then they do something else. They did it with Fair Recovery. They were doing the whole catch from the air with the nets, and then they figure out, well, when they are out in the ocean, they are good to go. So let's just pick it up. And so it was not really that big of a deal to make that change. Of course, if they were to do a much more substantial change to Starship, that will probably impact more their timelines. But again, it's like they do have the resources and sort of the willingness to fail and change course when they really think they are not in the right track. So
yeah, I mean, that's the beauty of rapid iterative design, dude. That's what this is all about. Try something, it didn't work exactly how I want. All right, try something else. Right? Anyway, Sawyer, do we got more questions?
We got a few more.
Questions. I like these questions.
I think we have time for a couple more here.
All right, hit me up. Let's go.
Here's one from Roblox Master. I feel old.
Okay.
When ship catch?
Yes.
When do you think? I mean, obviously they've been working on the systems. We saw last time. We saw this time they're working on getting that booster back. We're doing the flip and burn again. When do you think we'll actually see a catch?
Ship
year.
catch or booster? Dude, ship catch? I think that's a little ways off. For a ship catch, I mean, that's a little ways away. Booster? I think the booster, once again, I think because the booster is way more important at this point. If the booster doesn't work, there's no point in trying to get Starship working, right? Like, there's no point. If Starship can't SSTO with any usable payload, I still firmly believe it could. That might be useful in the future. I don't know how, but that'd be kind of cool. But yeah, I mean, I think the booster catches are going to happen a lot sooner than ship catches. I think ship catches are, once again, not the highest priority right now. But also, yes,
So then when do you think booster catch? Let's change up the question.
I think Flight 5, that probably will happen, I'd say Q3 or Q4 this year, depending on how good 4 goes. You know, the FAA seems to have, they seem to be getting better at figuring out these mishap reports. And, as we progress further and further into this endeavor that's mutually between FAA and SpaceX, I think the iteration or the rate of flights will go up. And honestly, okay, like this is the okay, we're gonna get spicy here for a second. I think they can catch the booster. Yeah, I think they can. I think they'll do it on Flight 5. I think it'll work. Yeah, the physics behind it are tough, but with a bigger booster like that, you have a lot more moment, right? It's bigger. It's bigger. That's what I'm trying to tell you. If it's bigger, you get a lot more momentum going in one direction. It actually might be a little bit easier to get that thing to, I don't know if it's going to hover next to it and kind of translate over, but at least come down kind of sideways and land on those chopsticks. And like I said, SpaceX must have some ace in the hole here for booster landing, because you guys, like, we've seen the second set of chopsticks, they're shorter, right? So clearly they have some ace in the hole here to do a precise landing with the booster. I think they're going to do it. And, that would be really bad if I ate these words later, but I think they will. So, I mean, I don't know. On a future Flame Trench, you can come and make fun of me for getting it wrong later. Like, I'm sure someone would enjoy doing that. It's the internet, right? Like, but I think they'll catch it. I think they'll catch it sometime this year. I think that will happen.
Yeah, yeah, I agree with DJ. It's probably going to be booster later this year. I don't know when later this year, to be fair, and ship probably next year. That's my take. Maybe late next year, but we'll see.
I wonder if they're going to wait until more of the new tower is built. I mean, we've seen them, obviously, we've got a lot of the second tower parts already there. I think there's just, 2 left that are about to leave Kennedy towards Brownsville sooner than later. So I think maybe, I mean, it's going to go up fast. Once they get all the parts there and move everything with all the transports, it's going to rise pretty quickly. I think once we see more of that stacked, then we might see that catch attempt. So I'm thinking more towards Flight 6. But I think this goes along with one other question that we had that I think was also really good and worth asking, which is, what do you think is going to be the turnaround time, assuming all goes well, between Flight 4 and 5?
See, I think that pending the mishap report, right? Because if Flight 4 doesn't do exactly what they wanted to do, they're going to open a mishap report, right? So I think between Flight 4 and 5, I think that's pretty smart. I think they'll have that second pad made. I think it clearly, like, if you look at, so SpaceX had a permit that they applied for with the FAA of erecting a permanent structure to show up on FAA maps. That you do that for like tall buildings, so pilots can look at a map and be like, "Oh, there's a tall building here. Let's not go near that," right? And the permit for the construction of the building was less than a year. Now, that you're not gonna if you're managing that project, somebody at SpaceX that's in charge of putting all these pads together, you're gonna budget the absolute maximum amount of time and then some that you think it's going to take to construct this thing. So you said we got those parts; they're down the street. Actually, down the street. Like, they are down the road. So I think that second pad will get made a lot quicker than the first one was. I mean, honestly, you built one, I have get 2 at twice the price now. That's a different reference.
Well, technically 3, because you had the one at 39A.
Right? Yeah, that's true, right? And not only that, but we see the tower segment. So, like, okay, the pad that you see right here, the main pad at Boca Chica, they moved kind of empty tower segments, stacked them, and then kind of installed a bunch of stuff on the side. These tower segments, the ones that were, I think those ones were made at Roberts Road, right, guys? And then they were shipped to
7 of
just
the 9, yes.
yeah, 7 of 9. Nice.
7 of 9.
Yeah,
Yeah.
2 hopefully
segments.
leaving sooner than later.
Yeah,
Yeah,
there's
right.
2 remaining sections 4 and 5 at Roberts Road, and hopefully we're gonna see them rolling out
boy.
in the next few days to Starbase. Yeah, continue.
Yeah.
VJ.
Flyover,
Yeah.
maybe nothing there.
Yeah, maybe. I don't know. Maybe we'll have to wait and see the video, man. Right? Sorry, it's 7 of 9. All right. So not only that, but we see parts on these pads. They're already there. So like a staircase, for instance, and conduits for electrical. They're all already installed on this. I think this pad's going to get put together a lot quicker, and I think it will be ready in time for Flight 5, which makes sense because, like I said, I think they're going to catch it with Flight 5. I didn't say what pad, right? I think that tower will at least be ready to accept a landing booster at the very least. At least I hope. Once again, if I'm wrong and the booster doesn't get caught on the first attempt and you get some pad damage, it might be a good idea to have 2 pads. Just saying, just put it out there. Like, I don't know.
Yeah, it's probably gonna take a lot more time though to get
Yeah.
to Flight 5. Excuse me, to the second launch pad. But yeah, go ahead, Sawyer.
No, I was gonna say that's why I think Flight 6. It gives them more time to build it, and obviously, I don't think it's going to be complete by Flight 6, but I think it's going to be at a point where they've at least started construction. That knowing SpaceX's speed, they could kind of pick it up and allow them to get back faster in the event that the catch doesn't go exactly as planned.
I have probably a hot take here. I don't think that second tower will be ready for anything this year. Like not a catch, not anything until next year. And will probably not be used until Starship V2. That's my take.
Yeah.
It's a hot take maybe, but
No.
I've seen already them building 2 Starship towers. The second one also was built in like 3 months, the structure, and then it took a long time to just get even the chopsticks installed. So I don't know. We'll see.
It's always going to take less time the second time you do it.
Third.
I'm just putting it out there. Yeah.
Not a third.
Third. There you go. Yeah.
But the second time,
my own disagreement.
The second time, it took about the same
Nice.
time as the first one, just to
Also-
stack. No. But I'm saying,
Yeah, that's fair.
I'm saying precisely because it has a lot more stuff already installed. The stacking and everything will probably take even longer. So instead of stacking it during 3 months, it'll probably be for a longer time. You also need to take into account the launching next door. So
And Elzar with a really good point in the back channel. There's no orbital launch mount for it yet. We have the tower segments built, but
I
not
was
the
getting
OLM.
to I was getting to that. Like they might, but see, I was getting that for a different reason. They don't need the OLM for a catch, do they?
well, you need a way
Don't.
to save the booster, and the way to save the booster is put it back on the overall launch mount, hook it up,
But
and
you could
you can
put it on
drain
some
it.
SPMTs. Maybe the SPMTs that delivered the booster to the other pad in the first place. I'm just saying it's possible.
Yeah, put that
Awesome.
underneath. That sounds safe.
No, we don't need
Yeah.
to put it underneath it. We could put it over to the side. It can drive in later. I mean, I'm not going to say I don't want that, Sawyer. That would be kind of fun to watch, but I'm
Yeah.
pretty sure that's not what we want.
That is very true. You know what else is fun? Representing your love of everything Starship, especially for Flight
Merch,
4, which you can do with the shop.nasaspaceflight.com Flight 4 apparel, including our patch, of which we have more than 60% sold, and once we are out, we are out. So if you want one, now is the time to get one. Don't wait. Call
one you
now. But wait, if you're not a patch fan, don't worry. There's more. You can also get it on a shirt. You can get it on a mug. You can get it on a rug. Well, no, you can't get it on a rug, but it sounded cool. And you can get it in multiple different colors, including on that sweatshirt there. You see it. It's red. It's blue. It's black. There's different color options too. So
I think we have orange too.
yeah, and don't forget, if you don't have
Orange?
patches for Flight 1 and 2, you can still get those. We still have some of those left. Flight 3, sorry, we're out. But don't forget, shop.nasaspaceflight.com for all your Starship Flight 4 needs.
I'm not going to lie to you. I kind of want a Starship patch rug now. Like
Adrian.
Let's get
Adrian,
Adrian
hey,
on it.
mein Freund, bitte, bitte.
I mean, we have a towel. Of course, I still
That
lie
is
here,
true.
which is great. But yeah.
That is true. Yeah.
Anyway, sorry, I had to
No,
mention that.
that was excellent, man.
Speaking of putting things on other things, I think this thing will have a thing on top of it soon.
That was
Anyways.
good words there. Yeah.
Yeah, yeah. I don't really know how to word, but
Use your noggin to talk about New England.
No,
I think that was
Stop it.
EJ. EJ.
Stop
yeah,
it.
EJ, this one's all
New
you.
England.
No, all right, I'll take this.
Nuclear.
So, yeah, I've posted on X here about a certain not autonomous spaceport drone ship, but what landing platform vessel 1 floating through the Bosphorus Strait in Turkey. Turkey, you notice, for if anybody's an antiquity fan, there's the Hagia Sophia in the background on the upper
Yeah.
right. It's a beautiful building. Anyway, so what are we looking at here? Well, we're looking at a converted barge that's been, a barge that's been converted for accepting New Glenn landings. Now, we know that those drone ships are the ones that SpaceX uses. Those are not small. Those are not small drone ships. They're about the size of a soccer pitch or football pitch if you're from non-American land. Hey, the Australians call it soccer too, okay? Shh. Right. Anyway, so this one, guys, like Kevin, I don't know if we can zoom in on this. Look at the port aft part of that ship. You see a staircase and some doors. And if we can zoom in on that real quick, you can see the scale
He's trying
of
to
this
zoom
thing.
in now.
Well, he's zooming in on Kevin's face, or on
Give me the zoom.
on EJ's face.
No, wrong zoom. Wrong zoom. Anyway, no.
There you go.
There we go.
If you guys look at the port aft part of this barge, you could see the staircases there. This is not a small vessel. This thing is significantly bigger than the drone ships that SpaceX is using. Now, bigger doesn't necessarily mean better, but also at the same time, you probably need a bigger drone ship to catch a bigger rocket. Falcon 9 is a 3.7 meter core, and that requires a pretty big drone ship. New Glenn is 7 meter, a little under double that size. So it kind of makes sense that, bigger booster, you need a bigger drone ship. But I mean, it's so cool to see it. One thing that I always say, from all my years covering spaceflight and hanging out with you guys, is that talk is cheap. You see companies say like, oh, we're gonna do this, we're gonna launch this in 2017, and it ends up launching in 2022, right? Like, talk is cheap. You got to look for the hardware. The hardware is the important part here. And right here, what you're seeing is a critical piece of hardware for New Glenn right now. Now, does New Glenn need a converted barge for its first test flight? No, you probably don't do that. But also, Blue Origin has said that the first flight will be a landing attempt. They're gonna go right for the bacon. Jack, you're out there somewhere. They're going right for the bacon, dude. Yeah, I'm bringing you right in on this. I know you. I see you back there. No, not you. Jack. Yeah, see, he's waiting. He's in the back with a trench coat on. Go, no. But yeah, this is a first critical piece to support that Blue Origin will land their first test flight, or at least attempt to. Personally, once again, I think they're going to do it. I think what they learned from New Shepard is more than enough. Sorry.
He zoomed.
I think, oh gosh, you're zooming in on me. Please, no, I told you not to do this, Kevin, Jen, Michael, Vincent, Reed.
We're gonna start looking at your cells, like each and every one of them.
Stop it. Anyway, so this is, I mean, I think this kind of supports that we will see a New Glenn launch sometime this year. I think it'll be this year. I think it'll be late this year. The dish, yes. So, and this is one of the critical pieces to support that theory. I mean, the other thing would be, if you know a little bit about like procurement and systems engineering when the application of launch vehicles, you know that propulsion, the engines are your long lead items. So people are going to say, "Oh, EJ, how do you know they're going to? We haven't seen any New Glenn." You just said look for the hardware. I don't know about you guys, but I've seen Tori Bruno post an awful lot of pictures of B4s on X lately. Now that's for an entirely different reason. He's trying to show that ULA has plenty of Vulcan boosters teed up, and frankly, I'm here for it. I wish them all the best. That'd be fantastic. Now, don't get me wrong. The B4 engines that are on Vulcan aren't the ones that are going to be going on New Glenn. They're not just going to be like, we need some of these for our flight. Bye. No, what this shows is that Blue Origin is scaling. They are scaling their propulsion production. Any Factorio players out there? We're seeing a scale up. That factory that they built in Huntsville for BE4 for propulsion manufacturing is cranking out BE4s left and right now. I mean, the ramp probably started sometime right around Vulcan's first flight, a little while back, but you see them popping up all over the place. So you've heard it from, we're talking about Blue Origin, but you've heard it from Elon himself that scaling propulsion is vital to support a high launch cadence, and you run risk of bankruptcy here if you have a lot of launches to do. Now, ULA and Blue Origin do have launches in the pipe, like New Glenn's first launch is NASA's Escapade mission. So now NASA's a paying customer for a New Glenn flight. And ULA is pretty much backlogged with Vulcan launches, because of Amazon, but so is New Glenn. There's contractual launches all over the place here. So not only are they mass producing engines, but they're mass producing engines for paying customers, right? And once again, look for the hardware. Talk is cheap. Look for the hardware. We see BE4s all over the place. Officer Murtaugh, look at the hardware, right? Yeah. No, hey, that was a weird one, but if you got that right.
Also worth noting, by the way, really quick, for that Escapade mission, that is a Mars mission, which means it has a very tight window. It has, what, you said a 10-day transfer window in the pre-show we were talking about?
Yeah.
Yeah.
Very, very, very short.
It opens on September 29th, and then it closes on October 9th. So they have 10 days. Actually, no, October 8th. So yeah, it will be the 29th, 30th, 1st, and then all the way to the October 8th day. So yeah, only 10 days to get it off.
So,
I have this thing in my phone. I don't know if we want to show it even, but I have a countdown, and you can see even there's one that's green, so that's like with a chroma kind of thing, the chroma key. So I have Slick 40. That's the next Starlink mission. That's going to be in almost 3 hours now. Slick 4 East, Starship, Pad, LC-39A, and then New Glenn. So there you can see all of the different countdowns and everything that I have. And one of them is New Glenn, and it is precisely counting down to September 29th at midnight. I don't really know what will be the launch time. So yeah, 120 days to that.
There you
120 days.
Yeah, I think it'll happen. I mean, once again, talk is cheap. You could say you're going to launch this in September. They can say it till they're blue. Oh, God, I'm hanging out with Sawyer too much. You can say it till they're blue in the face.
Yes.
They can say it till they're blue in the face, but the hardware backs it up. Kevin showed that picture of the New Glenn Pathfinder on the
Simulator.
transporter director. Yep. Yeah.
Because otherwise Harry will pull my legs or something. Anyways, but yeah, go ahead.
Pathulator.
Because he's like, the Pathfinder. The Pathfinder is actually the one that they put vertical and they loaded it and everything, while the other is the simulator. Anyways, but yeah, this
it would
is
have
the
to be your leg
simulator one.
anyway, because he's upside down in Australia.
Yeah, he is, mate. That's right.
But anyway, continue.
So, like I said, we've seen the structural simulator Pathulator, and then we've seen them do fueling tests with vehicles that have high fidelity or maybe future converted flight fidelity tanks. So, like I said, talk is cheap, but also here's the hardware. I wouldn't be surprised if we saw just a fully kitted out New Glenn booster just rolling out of their production facility down at the Cape. Like, I don't know, sometime sooner rather than later.
At one point, they'll have to, if they're launching in September, right?
Yeah, exactly.
We have to be very, very close to the point of them rolling out one of these boosters with engines attached. They put it out on the pad, they fire the booster, and put it then a second stage on top, put it out again, maybe a wet dress or whatever, put the payload on, and launch it. Like that's the whole thing, right? We should be really close to that point because we're essentially 3 months away. Well, 4 technically, but yeah, we're 4 months away from that launch, from that opening of the window. So they really need to get really, really close, or else they're not going to be able to launch that mission.
Yeah, and I mean, we've seen vehicles in, well, we've seen in the 2CAT, we've seen some of the flight, what we believe to be flight hardware, in progress. So we know it's there. It's just a matter of when it actually is able to roll out. We think maybe they'll hopefully do some testing soon, because we've seen late at night, the last couple of nights, they've been turning the lights on at the pad. Haven't seen them do anything besides turn the lights on and off, but at least someone's there flipping the switch, so that's something.
Hey, that's better than nothing.
Yeah.
Right?
Yeah.
All righty.
You know, they've said that they have at least 4 boosters right now in production, and that is essentially what they're wanting to produce in terms of boosters. We have seen perhaps tankage for 2 of them. So we saw the one that was used as Pathfinder to load stuff, and that apparently that tankage. So the engine section and intrastage are not for flight, but the tankage is for flight. So the methane and oxidizer tanks, they are for flight. So those essentially, they just slap an engine section that's for flight, and on an intrastage that is for flight as well, and boom, you have a booster for flight. We saw another set of tanks being tested at I think at the TCAT building. We saw that as well, and more recently we saw more parts within, you know, on one of these flyovers. We saw one of the hangars that they have at the exploration park. It was open, and we could see parts of a tank already for, you know, for stage 1 and everything, because you could see the 6 or, you know, holes for the outer engines on the bottom of New Glenn, because they have the other, the middle one is right in the middle. So, you know, it already has a hole because it's a dome with a, you know what I mean. But yeah, we could see those attachment points and everything. So we've seen at least tankage for maybe 3 boosters, which is interesting.
Yep. Dude, like I said, everything points to a production ramp, mostly for propulsion, but also for boosters on the ULA side of things and on the Blue Origin side of things.
And also, I now know where those are, because I had to go and highlight and circle each and every one of those points on that video.
You did the editing of those, but it is true, right? Like, now, obviously, there's the thing of, oh, they're now making the boosters, right? It's like, look at this. This might be like what, 1080 something. I don't know. It's a Falcon 9 booster. I know it's a Falcon 9 booster because it has the black intrastage, Falcon Heavy center cores. They have white intrastage, and it also has a Falcon 9 logo on the side. Unlike the Falcon Heavy side boosters, they don't have a Falcon 9 logo on them. So that's like the 80 something Falcon 9 booster, whatever, or this here. Hang on.
You changed the pictures on you, man.
Jeez. Yeah, they keep changing. McGregor Live, whatever.
What are you doing?
But it's like they have produced all of this in 14 years or whatever. Meanwhile, Blue Origin is now building 3 boosters. Oh well, you know, are they going to be you know, launching at all? Is that something that they can really sustain? Are they going to be even attempting the landing of the first one? Like, what else are they going to be doing? Right? It's like there's so many questions about their production, where it's like, sure, you're working on it. The problem might be not about you not working on things, but rather how fast you work on those. And that is a totally fair question of, you know, sure, you're working on boosters and second stages and everything, but are you making them at the rate that you will want to? And
yep.
Yeah.
It's hard to scale a production base for a launch vehicle.
Yeah.
Whoever cracks mass production of rockets is going to really break the mold in terms of like industry standard here. Now, I think SpaceX is looking to do that, but there are other companies out there that are trying to solve this problem too.
Yeah,
definitely a thing.
And you're talking different size launchers too, worth pointing out. You know, you can have different companies mass producing different vehicles for different size payloads. For example, Rocket Lab starting to pick up the pace again a little bit with Electron, which, if we ignore Neutron, Electron has got that small sat market, whereas Falcon 9's got that kind of mid sat market, and Starship, as of now, is going to be competing with Vulcan and New Glenn and things for some of those larger payloads. So you've got that factor as well.
Speaking of that,
Speaking of
isn't there
Rocket
an
Lab.
Electron launch tonight?
Yeah, 3 hours and 49 minutes from now.
Yeah, there's dude. We got a
Pre-fire
Rocket Lab
and
launch tonight.
ice. That's gonna be the fastest turnaround for them. It's gonna be under 7 days because they had
That's cool.
the ready aim pre-fire launch, and then they're gonna be doing pre-fire and ice. Those two missions are for NASA, for the pre-fire sort of CubeSat. It's technically a constellation because it's more than one satellite. But yeah, I don't know. It's complicated. One of the things that worries me about New Glenn is that they say, "Oh, we're gonna build like 3 or 4 boosters, and that's gonna be our fleet, and we're just gonna be reusing them 20 times." And it's like, yeah, but 20 times 4, that gets you 80 flights. Like, what are you gonna do after that, right? Are you gonna be doing anything else? And so it's like, and having a really low rate of production. Even Falcon 9 boosters get produced like maybe 6 or 7 each year. Like, that is a much larger pace of production, I guess, than what Blue Origin has, publicly talked about in terms of New Glenn production.
Yeah,
So, anyway.
but the thing is with Blue is that sometimes it's hard. It's hard to they have a poker face when it comes to this stuff. Sometimes it's tough to kind of predict, to extrapolate what's going on, But anyway, yeah, great discussion, dudes. Sawyer, what do you think? I think we're done here, yeah?
No, not yet.
No, not yet. What else we got?
Because we got Bideford here gifted 5 Red Team memberships, so we want to thank Bideford, of course. They're always fantastic.
Margarita time. All right.
Brian, getting items from the store as well, saying buying patch 4 after I have the first 3. Let's Go from New Orleans. I'm guessing a Saints fan as well, based on the spelling of Let's Go. Matthew saying, hey, at NASA Spaceflight, you rock. Well, thank you, Matthew. You rock too.
But without
Misty,
the K?
What?
You rock. Anyways, I just saw today
I
that
got
Rock
it.
from Star Launch flew
got
again
it.
today. So
Oh,
it just
man, that pun was tough. Tough rock, you might say.
I'm leaving. I'm leaving. You guys finish this.
Misty,
I'm gonna
saying
need
you
tough
guys,
rocks.
saying you
that
guys
bird.
bring my husband such joy. I love seeing the kid and him peek out. Thank you for all you do. Well, that's really sweet. I'm glad we can bring the kid out in him because, as you can see, it does the same to me, and also brings out the puns, which, yeah, take those as you will. And then Michael Delaney with the support, I guess going back to Starship here, saying possibility of explosion for this test flight? Non-zero. There's always the possibility, but I don't know. Flight 2 and 3 looked pretty good, so fingers crossed that we don't see any unplanned explosion.
You have a 100% chance of steel tubes coming out of the sky, though.
Excitement guaranteed, as it says, right?
That is also
Yep,
true.
yep.
Yes.
Yep.
EJ?
Cool. All right. So with that, I think we might be ready to wrap it up, man. I think we're done here. I think we're done. So, Kevin, you're gonna have to. There we go. That's what I was waiting for. There it is, baby. That's what I've been waiting for. All the members, launch
Look at all
directors, and
those
flight
names.
engineers. That's a lot of names.
You're gonna read every
crazy.
single one of them, right?
Here, I'll do it in less than a second. There you go.
No,
See?
no, Kevin.
No.
I've already
No.
heard that.
No.
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 Stop
no. No. No.
We will talk over it if we have to.
Yeah.
Oh man, you are making me so angry.
We love our launch directors and flight engineers, but not that.
Yeah.
Instead
No,
of playing
stop
this, why don't you go to our amazing launch live stream and play another thing that is so amazing? I don't know if you guys have seen the trailer that we have for that launch live stream.
Yes, we have a launch live stream
But
teaser.
stop
It's phenomenal.
playing that thing. Yeah, there you go. And thanks to members, because there you go. That's the teaser, the trailer kind of thing. It's always cool to see this.
Oh, I don't hate this.
Oh, it's dramatic. It's great.
I don't. Oh no, this Oh, this is killer. Look at this. I'm getting my popcorn. Oh, that's that.
Liftoff of the Falcon 9.
Nice.
Yeah, there we go.
Oh, that's pretty. That was pretty good.
That was awesome.
The hype. I can listen to
I
that
did-
music.
Dude,
Oh, there you go.
The gifts are back.
The gifts are back. So,
Most importantly, though, don't forget set notification on that stream so that you know when we go live to cover Starship.
So, yep. And okay,
Oh, come
Kevin,
on.
stop the music for a second. For real. I have to outro our guests here. So, guys, I've been EJ. I've been doing a terrible job hosting this train wreck of a live stream. With me is Sawyer. Sawyer, you have anything to say to these fine folks here?
Yes, we've got 2 launches coming up very quickly as well. So besides sending the
stars.
reminders for Starship, don't forget we have the Starlink 6-64 coming up tonight. And then on top of that, we also tomorrow have Starliner, which is a crew flight. There are people on it, so make sure you tune in.
Yeah, baby.
Check in around 8 a.m. Eastern Time. We will be live from the Kennedy Space Center and Cape Canaveral Space Force Station.
Cool.
Yeah,
Thank you,
definitely
Sawyer.
set
And-
all your reminders and everything. I don't know. I have the camera on me, so I'm gonna just say, yeah. So set all of your reminders. Watch Twiz as well, because we've featured here Starship, New Glenn, and Starliner. But there were other news. So if you want to watch all the news and all the launches and everything, we have a really great summary as always. Narrated by Alicia, written by me this week. It's been just
There you go.
me, but yeah, we're gonna have Starlink, Starliner, there's a Starship, there's more Starlinks afterward. There's a lot of things going on.
More Starlinks, you say?
Yes.
Wow.
There's
that
actually
never
2
happens.
Starlink launches.
Unheard of.
When we go live for Starship, there's a Starlink launch from the Cape. And then there's, in between that and the launch of the Starship, there's another Starlink, but from Vandenberg. It's crazy, you all. It's like, whatever. And then like 2 days after Starship, there's another Starlink. It's all Starlinks everywhere. Anyways.
Always has.
Also, God is
Thanks
hovering
to
over my
Kevin.
head and it's creepy.
Yeah.
And actually, Alex, thank you for popping in, dude. Thank you for spreading the knowledge and filling our ear holes with Starship and other spaceflight knowledge tonight.
All the stars.
Thank you yeah, all the stars, man, all the stars. And once again, I'm your host, EJ. Kevin, let's roll those gifts so we can cringe at them. Can we do that?
There we go.
Yeah.
Cringe
jeez.
time.
We're
Oh, it's the
rotating.
cringe time.
And I have an
It's
EJ
the cringe
top
time.
now. Oh, there you go.
Oh, I don't like
EJ and
rotating. This is
EJ.
making me sick. Oh, God. Please stop rotating me. This is weird. This is weird. I'm uncomfortable.
I'm gonna need
Where's the next GIF?
some of that stuff for
Oh,
being
yeah, there's
parsing.
the hap.
Oh, I have
That's
some.
better.
Yeah.
Oh boy.
Kevin, you really like this song, don't you?
He loves it.
I think I hate this song now.
Just because I was reminded, also follow the socials. If you don't, I don't know, if YouTube for whatever reason is mad at you and doesn't throw notifications, which we'll probably have problems with notifications, by the way, just saying. So do make
Thanks for
sure
reminding
to, check socials and everything, because that's also another way to get notified when we go live. They always make sure to notify people.
Someone in chat said
Yeah,
get
there you go.
rotated.
Why not follow the socials, right? Look at that.
Yeah.
That's why.
Oh my goodness.
If I don't see it, it's not illegal. Yeah, there you go.
You didn't see it. It didn't happen. Oh boy.
No. How did this make it in? This should not be in here.
Why?
Yeah, no.
Will you
Go
stop?
away. Ship 26.
Stop trying
We
to
don't
make
want
26 happen. It's not going to happen. Stop it.
It's not happening.
Get some help. Get some help. Stop.
On that note,
what happened?
Roll the outro.
Yeah, roll it. Come on.
And here we go.
Just gonna leave us here.
We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Traveling up. It's orange! Oh my god! Decollage. Look at this! Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
If methane would be igniting in the flare, correct?
Yikes. You bet. Sure. We don't need any more of these.
Dear Lord, I'm tired.
Oh no.
And,
Oh no.
Ow. And hot and everything. I completely turned off my lights as soon as.
Welcome. Yeah, got a little toasty over there, man. Welcome to the Flame Trench post show members and Twitch chat. I see you guys over there.
Yeah, this is the deluge pond now. We've gone from
This-
the
yeah.
flame trench to the deluge pond.
Yep. Yep. Oh boy. Oh yeah. I think we learned that I suck at hosting, and I have to get better at that. That's what we learned today.
I thought you did
I
pretty
thought you
good.
were pretty good.
Nah.
Yeah.
Oh.
Hold on 1 second. I need to make it
That's
so
good.
you can be heard.
You just need the whole thing of access, access to the panel and everything.
Think
Oh,
I
we can
did just
deal with
fine. I did as well as I'm expected to do. I don't know if that expectation is good or bad, Kevin. Like, I don't know.
It's okay.
I did fine. All right, I'll take it. I'll take it. I think I could have done better. I could have done better.
Don't be too
Ignore
hard
the
on yourself.
echoes,
It was
chat.
really good.
Members, ignore the echoes. Hold on, I'm getting rid of the echoes.
He's never going to get rid of the echoes. You're stuck with them permanently.
Permanently. I think I got rid of the echoes, and I made it so we can hear Adrian in the back channel now.
Hello.
I think we're good. I think so.
Woo.
Hey, we have about roughly 100 minutes until we go live again.
Oh, no.
Which
I'm so
Alex did bring up a
Jay,
good
since
point.
you're awake.
What's the deal with
Since you're
notifications?
awake, Jay.
Well, the
We're
deal
out
with
of
notifications.
We have none for Starliner tomorrow.
That's
Because
what I was
we've
wondering.
published Twiz, we've done Flame Trench, and now Starlink as 3 notifications, and then Starliner.
Cool.
Notifications have a surprisingly little amount of influence on our performance.
We're also we have Countdown to Launch tomorrow afternoon, which won't have a notification either.
It will.
Yeah.
It's
should.
at
No, because
3.
Twist.
So,
Yeah.
Oh, Twist went out late.
Yep.
Yeah, Twist was late.
It was 2:30, I think, or something like that. 2:30 p.m.
Well,
no, you can't skip a notification if it's a live event. It automatically sends one out.
Yeah.
Yes.
The good thing about Starliner, at least, is that it's like a 4-hour stream, so people will have enough time to look it up. We'll just, we'll probably just not have a lot of viewership early on, but it's okay. We'll have just the casuals.
Again.
It's gonna be a really.
I looked at the statistics, and you would be surprised how little that influences our live streams.
Oh, but I meant like, as soon as you go live, if you get the notification through, people will be alerted, and so at the beginning you can get more viewership. But it's a long run. What really matters?
It's like
for this.
Yeah, it's like 5 to 10%.
Yeah, and considering that launch is 12:25 Eastern, there'll be
Yeah, I
times.
actually disagree. With
They're doing a cryo of the booster. I didn't know that.
Oh yeah, it's
Oh,
Frosty.
look at that. Yeah, it's Frosty. Oh my God, I should have been notified of that. Come on, McGregor crew. It's okay. No, but I didn't notice because it's like white on white, so it's very complicated. Unless it actually vents, like here, it's venting. You can see it venting. But yeah.
You can tell it's a Falcon 9 because of the way it is. It's pretty neat.
And by the way, that black square is where I'd put Jack. If I had one.
If I had one. Nice.
Is there going to be a BTS for Starliner? No, probably not.
Please no.
Because it is too early. There's also no cameras or no host cameras. And it's a single operator, so it's with all of those NASA feeds. It's really tough.
Yeah, and then you'll also have Max at his location, Julia with the other camera.
But we do have some kind of behind the scenes. It's just not live.
This is a behind the scenes right now. Is that good?
Well, I mean, I'm going to have my GoPro. I could set that up for some behind the scenes.
We'll see. If I wake up early enough, maybe I'll put together a multi-view and put it in here. We'll see.
But you won't.
There's also some stuff that we can't show.
That too, yeah.
Exactly. And the stream's going to go live late. It's
Not
all
sorry.
your fault, EJ.
Not sorry. Yeah. Jay's gonna tap in. It's gonna be fine. Jay's got my back.
I'm glad we are seeing Kevin Michael Reed at its peak at 7 a.m. in the morning.
I hate mornings. Absolutely hate mornings.
You're also going to have Cape Crew that's been up for the launch the night before that are then also covering the launch the next morning.
Yeah, I also, not only that, but also one person on the commentary will do the stalling now, and then apparently I scheduled, so a German YouTube channel asked me for like a recorded interview for their Starship coverage. So I'm doing that at 8:30 in the morning, which means I kinda did not really plan my evening well.
Oh, at 8:30, what, a.m. your time?
My time.
Oh.
Yes, so that's like 4 hours after stalling. So.
And then you're also going to be on Starliner, right?
Yes.
Yeah, I'm sorry, Adrian, for that. I did not really want to be on Starliner.
You need to get me SBU written and after that stream, please.
I have SBU. I have another. There's like 1,000 things that I need to complete.
Yeah, it would
and I have no time.
Really helpful for me if you have SBU ready by the time Starliner is done.
Adrian, I have a question.
Yes.
For our members.
Yes.
How sold out of the patch are we right now?
Wait, let me do some quick maths actually in my head. We have about 1/3 left.
Wow.
So 66.666% of the way through.
Yeah, like I think the current banner says over 50% sold. That is already out of date. Again, we are definitely in the last. Actually, we are probably in the last 30%, based on when I last looked.
Dang.
So if you haven't ordered your patch, seriously order it. We were talking about it, and like Adrian is 100% against doing a reorder. Plus, it costs us way too much money. So once they're gone, they're really gone. Like really.
I'm not sure if I'm fine with the recent trend where both Chris B, Kevin, and Das use me as the boogeyman for why we can't reorder stuff.
Well,
You know-
what? I agree with you as well, because we said that they were collector's items. They are collector's items. If we change our minds now, we're idiots.
Next
because
time,
then it
the only
becomes just
thing-
about money.
Next time, you just gotta put more.
Yeah, I mean,
get
we did
more of them.
This already is more than the Flight 3 patch.
I'm gonna turn off my camera, by the way.
Why?
So
Just don't turn off VMix, please. Just mute your camera in VMix. Okay, now hold on.
But yeah,
So it's going to
No
Memphis
ring
Highway,
to
right?
no
always
room tour. No.
demand planning for stuff is always annoying. It's you will never get it right. You can only aspire to be as right as you can be. But yeah, it takes like 6 to 8 weeks to get in a warehouse. So by the time I would even get a new order batch of like flight 3 or 4 in, we are already probably moving to flight 6. And it would be like, how many would we even get at that point, and what's the unit count? And it's so super unfair to the people we told, oh, you gotta order now because they're
What the hell is this, EJ?
What is
What?
that?
No, nothing.
What did you steal from NASA?
I didn't.
Hold it
it's
up.
not NASA's. It's not NASA's.
That's SpaceX, isn't it?
Nope.
No.
It's got a little spinny boy on the back. If you know, you know.
I feel like I should know.
Does anybody in chat know? Because
People in chat know. People in chat know. I got a lot of cool stuff in this room. I'm not giving you a room tour though. No, can't do that. We got stuff. Yeah, Zeppelin. My chat over in Twitch knew.
Well, yeah,
They knew.
that's not fair, but
This is a aft fin to a very, very old Sidewinder. Very old.
oh, nice.
Yeah. The 7 and 9
now
reference,
I get
dude.
the spinny bit. Oh, okay.
Yeah. It's passively gyroscopically stabilized. Yep.
Was it?
Boy.
I think there will never be a bigger flex than Tom Euler logging into NSF Live and having a Draco thruster behind him, like an actual. Like you looked in, like, oh yeah, that's my Draco thruster. I'm like, huh?
Oh yeah, that.
Yeah, it's because the missile knows where it is at all times. I got a bunch of good stuff in here.
Yeah,
I
because
don't know.
it knows where it isn't.
Yep.
All right, chat. I have another question. I want to know what you thought of EJ as a host. Let's put him on the spot.
I think I did awful, and I think Jack is a way better host than me.
Ring says he did good. Oh wow! Space Pandaroo says better than Jack.
Wow.
No, not a chance.
We have a did awesome, 10 out of 10. EJ was an okay host, says Kevin Bradford.
Kevin, I agree. I can do better than that.
I love the like 10 out of 10. Great. Yeah, it was okay.
Well, Martin, same thing. Which, by the
Eric
way, Martin,
says just needs a bit of practice.
I don't know if I ever asked you, Martin. Is that a ham radio call sign at the end of your name there?
EJ and Alex together on a stream is a bit unbalanced, says Alien. That might be true. They both talk a lot, don't they?
Yeah, we don't shut the hell up. Believe me, I noticed. Here, you guys want to see what else I got in here? I got this book.
It's always the balancing of excitement, because excitement makes you talk, and if you're like excited, passionate for a topic, you will talk about it. So it's I rather have people being too excited and talk too much on the stream than too little. That's always my opinion about this, and you will never get the perfect balance on everything.
Also, nice to see another ham in chat. I also am a ham radio operator, although I have
Cool.
not gone on the air in a very long time. But I have made contact with the ISS, and I have the QSL card, so I'm proud of that.
Just so you guys know, Jack was traveling today. He was working out in LA this week, and he's heading back to Boca tonight. So that's why he wasn't
Cool.
here.
What else we got?
Oh,
We got
what is this? What is this book? I'm sorry, EJ.
Shuttle Owners Workshop.
Is that all? Did you get that one signed when I did too, or?
Oh dear Lord.
Yes, you did. We both got it signed.
Yeah.
We have Julia and Max and Sawyer on site for Starliner.
Yeah, I'll be driving in the middle of the night, heading up to the Cape.
This is a good book. So I like launch pads. Launch pads are my favorite. I like the machine that makes the machine. This book is a detailed explanation of all the hardware that it took to launch a Saturn V. It does not suck. It's an awesome book.
Isn't it?
What time do we go live, by the way, for Starlink? Anybody know?
We go live in
1 hour, 20 minutes.
Okay. All right. Good. Thanks.
Oh, Martin, that's really cool.
Keep
I'm
having
a
your
little
chat.
before my time, but that's still really cool.
EJ, isn't that more the machine? EJ, isn't more that the machine that launches the machine?
Yeah, sure.
And Alien, they managed to move one of the KSE cameras onto me during the first Starliner attempt, I think.
Oh.
I feel like they did. So yeah, figuring that we'll set up in probably the same spot, it is possible.
Nice. That beats mine for the coolest thing in the room. Dude, I got stuff in here that I can't show people. Let me put it to you like that. Here's something that no, I probably shouldn't show that. That's probably not a good idea. No, I'm not teasing. You can't see it. You can't look in the box. Let me find something else.
What's in the box?
You can't look in the box. Here. I can show you the cover of this if you guys want to see. Take a look.
By the way, Sawyer, I'm curious. Are you still tracking how many launches you have seen in your life?
Yeah.
Do you know the number in your head?
56. This would be 57, I believe. Nowhere near what Max and those guys are at.
Yeah, I think this is like a crazy thing, but Max is probably like approaching because there's not that many people that have seen like all of these Starlings from like almost all the Starlings from the Cape. So he's probably up there in a very, very low percentage of people in terms of how many launches they have seen.
He's over 170, I believe. And keep in mind, when I say the 56 that I'm at, I've never lived at Cape Canaveral. At one point, I lived up north and would travel down for all the launches. Then I lived in North Florida and would have to travel for all the launches. And even still, it's a couple-hour ride for all the launches. So that's 57 with all of that in mind.
But there can't be that many people in the world that have seen more than 170 orbital rocket launches, right? Like, there are a few, of course, that work there, but...
And there's some old-timers that are still there that have.
Yeah, but it's probably... Like, the percentage is low. Let's put it that way.
Alien, I think I've seen 9 or 10 of them. And that's just at the Cape. I mean, where I live now, I can see all of the launches. So I will go out and just watch Starlink launches if I'm not on air from home, if I'm not up there.
How much classified stuff do I have? I don't carry anything that's ITAR or classified. Everything that I have was procured through lawful avenues.
You're such a liar, EJ.
Not.
Uh-huh.
Oh, I remember the SDO scrub. That was 2010, wasn't it? That's going way back.
What you talking about?
It was like 2011.
Have you seen the latest video from Joe Bernard about his whole, like how he analyzes the amount of steering his fins can do, and he's actually explaining that he cannot present certain things because they actually get close to the realm of ITAR.
Yeah, I've been watching his roll-around videos. Those things are dude, Joe's a legend, man. I actually grew up not far away from him. He's from Massachusetts, too. Pretty cool.
Also, Eric, that
Dude,
was my first launch ever.
I watch
SPS
I watch
130.
his I watch his videos like religiously. Every time he uploads, I'm right there.
Yep.
I love how he's like combining actual like almost comedy with education. It's like he's really interesting but also really funny.
Yep. Yep. That's how you got to do it, man.
I'm only gonna say that ITAR is really dumb in the sense that it really is not that much enforced. I'm just saying.
Also, why do we care so much about people that make roofs?
What?
ITAR.
Here it comes.
ITAR roof.
Where's the mute button? Hold on.
You have server mute capability. That's the worst part.
Why don't you have like at this point you should have like a giant red button that automatically mutes Sawyer?
But yeah,
I
the
just
whole
need a Sawyer mute button, yeah.
Although
yeah,
at
the
this
whole-
point, a lot of people will just use ITAR as an excuse to say, we don't want to talk about it, even though it's not ITAR.
yeah,
No,
because
but
the whole
it is
thing, ITAR is supposed to be a protection against like foreign people to see very detailed technical stuff about rocket engines and everything. I can tell you that didn't work for me.
But the problem is, and that's what Joe actually very much explains in this video, ITAR doesn't tell you if you are under ITAR unless you violate it. So basically, they have like a giant gray zone, and that's why he's careful, because otherwise you by accident might step into that gray zone. And
it's like
you cannot call a number and be like, hey, is this fine? They don't tell
No.
you.
But there are rules, right? So like I took a 1-day course on ITAR just because of some of the work that we're doing. And the course was actually to sell me into like a 6-month long course. But I learned a lot about it. It's like you have to just know and understand what the rules are.
Yeah, and
Like there is a manual.
Yeah, there's legit things that it's like, oh, can you just take a picture of X at this thing that he's talking about? And it's like, nope, even that we can't.
Yeah, he mentioned, for example, that he gets now into problems because he's doing aerodynamic analysis of rockets in supersonic airspace, and that apparently gets very close to what ITAR considers. Please don't publish this.
There is a line. I know
They
where
don't
it
say
is.
please.
I'm not going to say where it is, but there's a line, and I don't cross that line for nobody.
I know you want to know
where it
what
is.
work we're doing. You'll find out eventually when it's not ITAR.
Yeah, it's like I think ITAR tells you like here's a general line. If you feel like you're getting close to that line, you're probably already too close to that line. They kind of by intention make it so don't step near.
it's like on the cartoons where the guy just runs off the cliff and then he looks down and it's like, oh, I'm already off the cliff. That's sort of the same thing, and they fall,
Yeah.
right? And once you find out, you're probably already in.
Yeah, once you get a notification that you have an ITA violation, it's like, oh, sorry, I will do better next time. Nah.
What next time?
Yeah, what do you mean next time?
Also, to answer the question, Pandora, definitely slower ascent, because then the sound lingers longer too.
It's much easier to be the technical director on a stream when it's slower too.
Oh yeah, that. Yeah, for photos, it's definitely easier too.
I just dislike the fact that ITAR these days is also used as used as a secondary loophole for American workers' protection, and it basically stops free movement to get other nations in. It's kind of also used as that secondary loophole because they can just say sorry, ITAR. But I think there's a way how you can clear, for example, European or I don't know Canadian workers to work on rocket programs without instantly compromising your national security, especially if we are talking about RP-1 based orbital class rockets. That's not really the prime weapon technology.
that you know of.
Yeah, but I mean, I know we are a bit behind here in Europe, but I don't think, like, I don't think our weapon systems are that bad.
Ariane 6 could use it.
Oof.
I mean,
Oof,
Ariane 6 could steal something from a 1960s rocket, but that's just me. Also, Ariane 6 could please not exist. That's also a thing.
Yeah. Anyway, I still have stuff I need to do to get ready for the launch in the morning. So, unfortunately, I'm going to have to bail a little earlier than usual tonight. So,
yeah, I'm gonna head out. I'm gonna head out too, Membies. I gotta get back to my Twitch chat. They're looking for me.
I'm also
Streetlights
have
are
to
on.
drop because I have a lot of work to do.
Yeah, I think we all have to take off because we have a launch in an hour.
Yeah, let's shut this down because we have so much stuff to do.
shut it
I
down.
enjoy a
Gordon
lot
Ramsay
of
it.
more activity from Sawyer and I. Wait, hang on. Which one are we doing? Oh no, Adrian and I are doing Starlink 664, and it is also
Sawyer,
tomorrow Countdown to Launch. I'm also on that one as well with Adrian and Trevor, and then
We don't need
Sawyer is
another
in
list.
tomorrow.
We
Yeah,
don't
and
need
I'll be-
another list. You already gave them the entire list on stream.
And I'll be
I
on
know.
Sawyer,
site
you can
tomorrow with commentary from the field. So,
I'm on the next free, and I'm on the next free streams, and they're all in the matter of 24 hours.
well, then let's call it quits, everyone.
Wait, we
Thanks
have
for
a
watching.
special request.
Oh,
We have a
What?
special request.
Nope.
no,
I'm leaving. Bye.
no, ship 26.
Someone asked for something.
No, don't listen to Alien. No. EG left.
All right, and I'm gonna play us out with this.
Oh,
nice.
I don't hear anything though. Have sound.
Thank you.
It does. I don't know why you don't have it.
Yeah.
It was the same during the.
Thank God you told us to listen to Cloud 11. Yeah, I didn't know we had audio, and I was like, oh, that's cool. And then I was like, oh.
I didn't even hear it.
Huh? Some audio there? Not all the audio.
Oh, you know what? I know why you can't.
To Star Hopper is a 5. 6 is a 8. That's 15. 5 1. 5 2.
Alex, conserve your energy. There's so much to do talking next.
3. There you go. Let's go. Come on. I don't know. Now we have audio. I can hear it.
All right, Memmies. We will see you later. Have a good night.
See you all again next week.
Bye.
To recap this week in Space Flight. Anyways.
Okay, members are gone.
Okay. Do we have a reacquisition of signal here? Oh, okay. Chat, how do I copy? 5x5. Excellent. Excellent. Oh. Okay. Hey, come back. Come back. Hello? Hi. All right. Woo! So, yep. How do you think I did hosting? I did not realize that Jack was not there. That was a complete curveball. Derek found a CUDA. Oh, well, I'll be dipped. I'll be dipped. Astro Level's nephew, tier 1 3 months in advance. I see you Levels over there in that YouTube chat. Did the YouTube stream not go down? Huh. I guess it's still up. Cool. Totally groovy hosting. Oh, well. It didn't stop. All right. Sweet. Yeah, that was that was I got a little nervous there because like the queue and stuff that you have to read, like I'm just so used to just reading what chat says and acknowledging sub notices right away. Like, oops. I did well. Well, thanks, guys. Yeah. Ironically, you kept them on track more. I can be professional if I choose to. God, I just don't do that. How did you think you do? I could have done better, but I guess given short notice, I did all right. Yeah, that was on me. They told me, but I didn't realize that Jack was away. I didn't check that Discord until like 30 minutes before the stream, dude. It's too much stuff to keep track of. Oh, boy. How would you do variable swept wings in KSP with robotics? I'm eyeing making an F-14. Figure out where the wing pivots from and go from there. Oh, thanks, Self. Right on. Right on. Cool. Would you do Kraken Tech? With a wing, because of the loads from the wing, I would probably do a hybrid tech system. Yeah, a hybrid tech would probably be the best way to do that. Anyway, Astro Level, thank you very much for the subscription. Doom had a 92-month resub in there. Do appreciate it. I had NSF Live on at the haircut place. Want to show us how? Dude, that takes a lot out of you. There is a lot to keep track of, man. I'm actually tired. It's like I'm constantly talking to Kevin in the back channel and like controlling the pace of the entire stream. Like, that's a lot of work, man. I like just sitting back and letting Jack do the thing, man. Woo! Says I did a good job. Thanks, dude. Thanks. Thank you. Been lurking, respect the knowledge. Thank you very much. I do take a lot of time to learn this stuff. Yeah. And if I build up enough confidence in what I know about something, then I'll throw my hat in the ring and give my opinion on it. But until then, like, if I'm not sure, I kind of just shut up, you know. As someone in the back channel, you did good. All right, Sudi. All right, man. All right. Hensley, can I add so much? Oh, I appreciate it, dudes. Thank you for those kind words. Man, it takes a lot out of you. I'm actually tired. But I think we're going to do racing sooner rather than later. Wait, hybrid tech. Kraken tech with robotics. Hybrid tech, dude. You know what hybrid tech is. Don't you wait hybrid tech? Don't you wait hybrid tech me? Anyway. Yeah, we did okay. Anyway, I have to check my messages. My phone was going off like crazy. I just want to point out that this is a message that I got from Brimo's mom. That's a, yep. Okay. Yep. I just want to point that out. Yeah. Okay. 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 Yeah, no, that's good. Any news about IM2? Nothing yet, Level. Not that I've heard of. You're lucky guy. Yeah, no, it's not. No, it's not the worst. Not the worst in-laws, man. Not the worst in-laws. Oh, jeez. What do you even respond with? Okay, I got something. Did you know that on spacecraft, fuel is actually stored in a spherical pressure vessel? So, fuel, in fact, is stored in the balls. In the balls. Yep, that's what we're replying with. Oh, dude, I'm actually tired. What the heck? I mean, then again, I did do a lot of talking today. Doing space news, like right before that, definitely, yeah, that's a lot of talking. Hang on, I'm just... Okay. Oh, we got a message back. I did not, in fact, know that. Okay. You need a nap. Well, hey, we got racing to do, man. We got racing to do. What time does racing start? What time do the boys usually get around there? Take 5 before Friday night racing in about 2 hours. Cool. All right. Do you do Flight Simulator often, Ellisers? Sometimes. The most recent thing I've been playing is DCS, but that freaking VR headset when I'm flying around, I don't know what it is. It makes me sick, dude. Like, yeah, I got seasick for like a couple of days from playing it, like for 6 hours. So I got a track IR, but yeah, I do, yeah, flight sim and stuff. Like, I don't know, if we got some crowd in from the NASA space flight streams, if you don't know me, yeah, I'm a plane and space nutcase. Planes, cars, trains, whatever. Boats, sure, why not? Can I ask a question? You know that screenshot I took of the thing? We should you share that? Oh, I don't know, maybe. Dude, I put the helicopter into a failure mode where I had blade stall on the tail, or yeah, rotor stall on the tail rotor, and the thing started spinning around while I was trying to look at the landing site. That was it, dude. I almost puked. I almost blew chunks right on stream, man. It was close. I was like, oh, God. Dude, it was bad. Yeah, the way the controls were bound on the Warthog, so like there's a throttle quadrant because it's a HOTAS, right? And the left engine throttle is the rotor RPM. So it's the throttle for the helicopter, and the right engine throttle is your collective. Now on a helicopter, those are on the same thing. It's on the collective, and the collective has like a grip on it that's kind of like a motorcycle throttle almost. Now there's two parts to the grip. There are two parts on that grip that move independently. Well, actually, it depends on the helicopter, to be honest with you. The bottom part of that thing that you turn, it throttles the engine. But the thing about helicopters is that helicopter throttle controls are like, there's only, it's not like 0 to 100% throttle like it would be on an airplane. The helicopter throttle controls are like 90 to 100%. So you can't like turn that thing and turn the engine off. It doesn't work like that. The reason why you have 80 to 90% throttle control, so like that twist only throttles the engine the last 10%. The reason why is so you don't throttle down the engines when the helicopter is flying, right? That's what the that lever that you see them pull on the top of the helicopter, like up there. That's what that is. That's the well, that's the rotor brake. That's what it's there for. That's the rotor brake. I mean, once again, it depends on the helicopter. It's like an e-brake handle with a motorcycle throttle on the end. Yeah, pretty much. Yeah. So when I would command the collective, which collectively pitches all the blades on the main rotor, it would throttle them as well. So if I pulled back on the collective to try and go down, it would basically throttle the engine down to 90. The thing about it is that the helicopter engines need to be the same RPM. You need to have the same RPM out of the main rotor. You start screwing with the RPM, then it just completely throws things out of whack. So, for instance, if you throttle down and collectively pitch down at the same time, you're not just going to go down, but the helicopter you'll have rotor stall because of the high pitch of the blades, and basically the drag made from the blades will basically compressor stall your engine. And yeah, this makes the helicopter not helicopter very well. So I was coming into land, and I put the collective down to go down, and I got rotor stall, and the helicopter started spinning out of control in VR. And I was trying to look for the landing site while the helicopter was spinning. It was induced failure from me. That wasn't the helicopter's fault that I don't know what I'm doing. But, God, did it make me want to blow chunks. That was bad. It was bad. The XB70 went outside for a bath this week. Cool. Yeah. So if racing isn't for another couple hours, guys, I'm probably going to go take a break for a little while. Go outside for a change. Get a little bit of daylight in. It's probably dark now, but... Yeah, I stalled the entire system. That type of Huey has one turbo shaft, and that turbo shaft essentially has a drive shaft coming out of the back and a drive shaft. No. It has a drive shaft coming out of the front that goes into a gearbox that has two drive shafts coming out. One of those drives goes down the tail rotor to the tail, and the other end of that gearbox goes up to the rotor. On that type of Huey. There more modern Hueys have twin turbo shafts. So like a Bell 409, I think it's what it's called. The military version is used by the Marine Corps. It's a UH-1Y. Almost dark. Evening colors just went down. Yeah, so I think I'm going to take a break for a little while. Racing is going to start at 10. I'll be back for it. So, yeah. Thank you very much for watching, everybody. We still got some stream left in the day. We're going to do our Friday night racing. I'll be back for that. And if you're not into that, I will see you guys bright and early here at around 8 a.m. for Starliner. I'm not missing anything. We're not gonna miss anything. So, because of Starliner Geek, I'm not sure how many races I'll be able to do, but we'll still do some. So you get a Saturday stream for me and an early Saturday stream at that. And then I might have some other stuff planned for Saturday afternoon that has to do with streaming. I'll let you know. Okie dokie. So thank you very much for watching, everybody. I do appreciate it. I do appreciate you a lot. Everybody that followed, I saw the follower alerts go crazy after people said, oh, I stream on Twitch. So I do appreciate it, dudes. Thank you. Yeah, you know what? I don't want to raid and runs because I'm gonna go take a break and be back. So I'll just shut the streams and I'll see you guys all in a little bit. Thanks, EJ. Relax and take it easy. Yeah, Brian, I'll try. It's hard to do with all these rocket launches, though. Wait, what's the Saturday stream? Starliner CFT1 launches tomorrow, 12:25 p.m. I'm picking up the coverage at 8, so we can watch the astronauts come out of ONC and, you know, drive to the pad and stuff. That's the beauty of crew launches. I love watching these things. I won't miss one. Absolutely not. We also do have a Starlink right at the start of Friday Night Racing. So you guys, yeah, there's a Starlink launch at 10:11. So that's in well, not exactly. It's in 1 hour and 53 minutes from now. We'll just say 1 hour and 54 minutes. Call it a day. So I'm going to take a quick break. Mr. Weldon is asking me to touch grass. All right. I'll see you guys on the other side. Rocket launches and racing happening in about 2 hours. Thank you very much for watching. I'll see you in a little bit.